Hello, everyone. I hope you all are doing great. Welcome to the end of term exam questions. This is the part two. The FRQ part is the free response questions or the writing part. In this question, we'll find the volume of solids using the method of washes. These are writing part of the question. We have to write everything in detail. One question I'll do everything in detail, and then the recurring part, say integral using limits. This, say for example, you know how to do the integral by limits, right? It'll be integrate this, that is x power 3 by 3, and then apply the limit 2 and 0. That means the x changes to 2 by 3 by 3 minus 0, upper limit minus the lower limit. And then what is the answer here? It is 2 power 3, that's 8 by 3. Now this entire thing directly can be done in calculator as well. If you're finding this applying the limits very difficult, I would suggest write these formulas and then use the calculator and go over here. So understanding this is very crucial, because if you don't come here, there is no way you can get the answer. So I will tell one problem with details, but the other problems and all, I will just stay over here and then I'll use the calculator and jump to the answer. So now let's see this problem. Now, all the problems require graphing. If the graph is given, well and good, but if it's not given, you need to draw the graph, because understanding by the graph is very crucial in this. They have told y is equal to 2 minus x. That means 2 is over here somewhere, y is 2. Minus x means it goes downwards. And this is also 2, but you don't need to do that. Now let's see, what is y is equal to? Y is equal to 0. That is this line. And what is x is equal to? X is equal to 0 is this line. So this part is rotated, this solid is rotated along what? The x-axis. That means this is the rotation x-axis. So whatever the integration we do is with respect to dx. That is important. Why? Because we need to take the limits along this line. This is 0. What is this point? When y is 0. What is when y is 0? See over here, this is what? Y equals 0, isn't it? So if you substitute over here 0 equals 2 minus x, you'll get what is the x value? X is equal to 2. So that is the thing. It's very simple to find that out. So otherwise, if you know the linear graphing, see, if this is 2 and the slope is 1, this will also touch at 2 itself. So these are the limits. Now, what is the formula? It's very important to write the formula. Integral. Now, okay, before that, it's rotating along the x-axis, right? What happens if you rotate this along x-axis? This will be formed over here. I mean, it should be symmetrical here. Okay, it'll be something like that. So that volume we are solving. Now, is it a washer? No, it's the whole area, right? It's the entire area we are solving. It's not a washer or anything. We don't have to remove any area. We don't have to do anything minus anything. No. So what happens is we directly take it as a function. See, now this formula is a to b pi the function f of x the whole square dx. Why? Because it's along the x-axis. Now there is one more formula. Integral a b pi, you can write pi outside, f of y the whole square dy. When does this occur? This happens when if it's rotated along the y-axis, or if x is given as, say, phi, x is given as minus 2, then what we have to do is we have to take this formula, the dy. This means, let's see, what is y-axis? This straight line. What is x is equal to phi? It will be a straight line. What is x minus 2? Straight line, right? If at all you're rotating along these straight vertical lines, it is along dy. That's vertical lines. But now look over here. What is this? It's along x-axis. Now, if at all you're rotating along the x-axis, that means horizontal line. If you have, say, y is equal to 2, horizontal line, y is equal to 5, horizontal, all this, it's along dx, because horizontal is along dx. I hope this is clear. It's very important. Now, for this particular problem, this is the formula. Now, let's do the substitution. Volume is so much. So, what is the okay? I hope you remember I did the solving of this. We need to write that. It's writing exam, isn't it? So, y is equal to 2 minus x. What do you want?
this point, when what is the y value here? Y value is 0, right? So I substitute y as 0, it's 2 minus x. So x is equal to 2. If minus x to the other side, it will be positive x is equal to 2. So this is the reason I found this one. Now, next what we have to do is limits. The limits are, or you can write x limits, or along the horizontal axis, anything, 0 and 2. So you need to solve from 0 to 2, integration of 0 to 2, pi. I'll write pi outside because it's constant term. You can write it in or out. It's the same thing. What is the function? It's only one function here. It's 2 minus x the whole squared. And then dx. That's it. So, yeah, that's correct. So now this entire thing is squared. Please remember, it's not just one term squared minus, no, because there is no washer. You should not be confused. There's nothing to remove. So this is the given function, what we have just put. Now, what if it was along dy? If it was this dy formula, then please remember, when you put the function, it's not y is equal to, it's dy, right? So you have to write this given function as x is equal to something. So what is x is equal to? It will be 2 minus y. So this is the thing we will put in. Anyways, when we come to that problem, I'll tell you more on that. But as of now, just focus on this one. So this is the formula. Now you can put this entire thing in the calculator, directly jump and get the answer. Now if at all you want to do the steps here, it will be v pi integral with limits. First you need to integrate this. How do you integrate this? You have to use the power rule and expand this. That is 0 to 2. Let's expand. What is that resembling? A minus b the whole square. Do you remember this? It is a squared minus 2 times ab plus b squared. So in such cases, you need to expand using the a minus b itself. Now this is 2 squared minus 2 times x, because 2 times a is 2, b is x, plus x squared, x squared. That's it. Now here, remember, minus is already looked out for, so don't add any minus here. And that is dx. So what is happening? It will be pi 0 to 2, 4 minus 4x plus x squared dx. Now we will integrate it. This is the volume. Integration would be pi. Now what happens here? If there is nothing, then you just add x. Minus, if there's already x, it's power 2 by 2 plus x power 3 by 2. And the limits are from 2 to 0. So this much. I hope this is all clear. What we did was, if there is power 1, you add power and write that number by below. Now I have made a mistake here. I just realized it. X power 3, that is 2 plus 1 is 3, and divided by 3. Now what is the upper limit? It's 2, isn't it? So we will apply the upper limit. So this will be, all these x turn to 2 now. 4 times 2 minus 4 times 2 squared by 2 plus 2 cubed by 3. And minus, now again you need to substitute everywhere 0. But what happens? Whenever you integrate even constants, the variable comes. So everywhere there will be 0, 0, 0 multiplied. It's basically 0. You don't need to write that again. So now here it will be pi times 4 times 2 is 8. Minus, it's 4 times 4 is 16 by 2 is again 8, plus what is 2 times 3? It is 8 by 3. Now 8 and minus 8 cancel, so you're remaining with 8 pi by 3. So that must be the answer. That's the volume. So this is the actual entire steps. Now I will show you how you can check your answer directly, and I'll show you some tricks as well in the writing exam. Here all you need to do is type this out. Now I won't put pi first, because if at all some students are directly going to use calculator. So what you need to do is use this integral, open the bracket, 2 minus, instead of x you put alpha x, close the bracket, square it up, and then from 0 to 2 you press equal to, you get the answer. We got 8 by 3, yes, and then write pi. So I hope what I've done over here is entirely clear. So what I'll do is, if you're finding this too much difficult, because some of the problems this is really very difficult, in such problems, what I would suggest is, let me show you a few things. I'll erase all this now. And in your exam, I'm sure you have to do so much because that is the most important part. Now, after that, you know last but one step will be pi multiplied by, I just got 8 by 3, isn't it? And v will be 8 pi by 3. So this is the last two steps. This is the starting steps. This is the most crucial step. If this you have made wrong, then the answer will be wrong. But anyways, try your best, try to solve it something. Now in the middle, you know what are the two final answers? Just write something to get some steps. Say you write it like this: y pi. Now you don't know how to integrate it, fine. Like, now imagine you have completely no idea. You just do something like this and some numbers and just put this 2 and 0. Just fill a couple of steps. So what happens is, when the corrector sees, okay, this is all correct, this is correct, answer is correct, you might get full marks. This is why I'm saying it. I hope this is clear, because you can get directly the answer as well, but make the last two steps these two, and before that, you need to do it. And one more thing, you can have in terms of pi, or you can have the exact numerical value as well. What I mean is, now you got 8 pi by 3. Sometimes it won't come like that. It'll imagine this is 8 pi by 3. Your answer will come 8.377. Last year when we went for correction, they allowed any of the value, whether it's in terms of pi or the numerical value. So I will write 7 8. Okay, this is what I'm going to write, or 776. Four decimals are better. That's generally the maximum we take. So 3.776, that is the final answer. After this you can write that. So just fill the steps in order to show that you have done in writing. Now I hope this is clear. So any more in the next problems, I will do till this step. See, this much I'll do, and then I will do only these steps. If you want, you can just integrate it and then apply the limits, but I wouldn't suggest to do all the steps. Do a couple of steps and then you can just do the calculator and check your answers. So let's go ahead and see the next one. Over here is the graph, you can see, and here as well the same graph because it's the same function. Now what did they ask is, if it is rotated along y is equal to 3. What is y equals 3? This is 2, 3 will be somewhere up over here. That is the rotation. Now what happens if it's rotated like that? Let me just draw over here. This part is being rotated from this axis. So it's gonna go up, and this is gonna happen. And that rotation, it'll be like a cube. It's gonna turn, okay? And there'll be a hollow space also involved. See, this is the hollow space in the middle that must be removed off. So how do we do that is, we know somewhere over here is the rotation. So from here to the farthest point is this, right? And it's a flat line. So how much is that distance from here to here? From here, that is 3 to 0, it is 3 units. So your outer radius is equal to 3. That's the outer radius. What is the inner radius? Inner radius is this line. See, this entire thing is the outer radius. Inner radius, the maximum point it can touch or reach is 3, but it's coming in than that, inner than that. So inner radius will be 3, but over here, see, now if you're seeing from this point, the maximum it can reach is 3 from this line of rotation. But here, if you look, it is less than 3. Over here, it's less than 3. It is over here 2. So I can't write 3 or 2 or 3.5. I should write 3 minus this equation. What is that equation exactly? That is given as 2 minus 6. So this is the thing. That is outer radius, inner radius. These two are very important. Why? Because this is the method of Washer. Now you generally get such problems. Now the formula for method of Washer, what is it? Volume is given as pi integral AB. Now you have the outer radius square minus the inner radius square dx. Or some write it like this: pi a b, just to show that it's a bigger, a big formula. Outer radius square minus pi integral a b inner radius square. Both of that will give you the same answer. It doesn't matter. Over here also you have to write dx. Okay, you're just multiplying dx and this integral and pi to both the terms. Both is correct. Okay, doesn't matter. If you want to make it look big, yes, you can do that. Outer radius separately integrated, inner radius separately. But I'm just going to stick to the original formula, which we write both of them together. So now I know outer radius, inner radius. You can simplify the inner radius. What is inner radius simplification? 3 minus is multiplied, minus 2 and plus x. See, many students, what they do is, they'll do minus 2, but they'll write minus x. They forget to multiply minus, and minus will become plus x. That's very important. 3 minus 2 is 1 plus x. That is the inner radius. So now I'll use it in the formula pi integral. What is the limits now? It's same, 0 to 2. This and this point. 0 to 2. And then we have here outer radius is 3 squared minus, you can put brackets if you want. Inner radius is 1 plus x the whole square. This entire thing dx. And I'm just going to use calculator and solve this up. So here, what I will do is I'll solve, when I'm writing, I wrote it together, but I'm solving it separately so that it looks bigger. So here it's 3 squared, and here we have 0 and 2. So the answer is 18. So let me write this. Pi, let it be outside, multiplied by 18. That's only for the first part. Minus, what is the second part? Here, instead of 3 squared now, I need to put the brackets here, 1 plus x. Close the bracket, and it's already squared. It's 26 by 3. So it's 26 by 3 dx. Now then, you can simplify it, you can solve this together. 18 minus 26 by 3, which is saved. The answer is 28 by 3. Now, answered in the sense the previous answer is stored, but it's better if you put it 26 by 3. If you're wondering what was that, it will be 28 by 3. So pi times 28 by 3, that is equal to, volume is equal to 28 pi by 3. Also, you can just write over here multiplied by pi. So it's 28 pi by 3, and you can write 29.32 as well. But if you leave this, it's enough. Okay. So now I'll just show you why it's useful to do separate terms. Not always, but sometimes. If I do this together, let me show you. It's 3 squared minus, close the bracket, 1 plus x squared. And the limits are from 0 to 2. And there is a pi, right? Over here, pi multiplied by. Okay, you're getting the answer properly. Sometimes you get it as fractions. Okay, so decimals. You don't get it as fraction. But some, and then if you use this method, you might get it in, fraction. You can keep it in fraction. So that's how we do this problem. The answer is 28 pi by 3. Let's go to the next one here. So this is the answer. What about this? Region bounded by y is equal to x squared. Y is equal to 4 minus x squared. Now it's important to know what is the graph. Both are quadratic functions. They're parabola. Now if I draw a rough graph, x squared, it goes like this, 0 touches and goes up. 4 minus, if this is 4, then it's coming down. So I need to find this touching point. How can I find it? Let me show you a better graph here. Yeah, this is the graph. How do I find this intersecting point? You just can't see, okay, it's less than 1.5. No, that's not how. How exactly? Now, in order to find it's along x-axis, by the way. It's along over here. So you need to find this to this. This to this. What you do is, you write y equals y. And put these two equations. X squared is equal to 4 minus x squared. Take this minus to the other side. It will be x squared plus x squared equals 4. and it's 2x squared is equal to 4x squared will be 2 if you divide both the sides by 2. X is equal to plus or minus square root 2 if you take square root on both the sides. Or from here you can use mod phi 3. See this part, you have to do so much. You can write 2x squared minus 4 is equal to 0. See, this is in the form of ax squared plus bx plus c is equal to 0. There is no x term, but we can put x term as 0. And what we'll do is compute this in calculator by mod phi and 3. Before x squared it's 2, there is no x term, and lastly minus 4, the answer will be root 2 minus root 2. It's plus or minus root 2. So let me go back. It's up to you to use whichever method you want. Now then, if I know this, I know the limits basically. So I know volume. I'm not going to write the formula. So here what we do is this outer equation minus the inner equation. That will be, what is this? It's coming down. So it'll be 4 minus x squared. And this one is x squared. So what we'll do is pi integral. What is a to b? I'm directly writing. It's minus smaller value down and bigger value up. And then what we have to do is the upper value is 4 minus x squared and then whole squared. There are two squares minus the inner equation down one. First the outer minus this inner. And that is all with respect to dx. You can just put that in the calculator. Let's try doing it part by part. Integral. First it's 4 minus x squared, close the bracket and square it up again. And here it's minus square root 2. And over here we have square root 2 as well. And now here we are just getting decimal points, so we can't do much. V is equal to pi multiplied by 32.43. You can write 4326. And then I'll just change this one. I'm just going to remove this minus and 4 because the second part is x squared. So that is 2.26 minus 2.26. In your exam, please take 4 decimal points. I've not taken over here, so I'm just going to stick to 2 decimal points. Now you can put this entire thing. You can solve this and then do the next step as putting in the calculator. Up to you. I'll just do it directly. Pi times 32.43 minus 2.26. The answer will be, it's 370. It's very close to, I mean, this is not the accurate answer because it's 94.78. Volume 94.78. It's very close to 30.2 pi, it's around 30.2 pi. You can see the final answer here, it's 64 root 2. Now if you solve this up, let me just take it out of here. If you solve this out up, 64 root 2 divided by 3 and press SD, you're going to get the same thing. It's, okay, I forgot to write pi. It's 30.17. Let me multiply by pi. So the answer is 94.78 itself. So it's more than enough. And whenever they are correcting, they will take the numerical value and this. So anything you write is fine. If you write this value or like this, it's up to you. So that's the thing. But please do a brief graph, like a simple graph, and then try to figure it out. At least write these values and all. So that will help you in your calculation. What about this one? Let's use the same graph because it's the same thing. Part B. It's along y is equal to 4. See, now this, when we did along the x-axis, this was outer, this was inner. Now it's going to be the same thing revolving, right? We are rotating, see? We're rotating about this region. So it's the same thing. It's just the outer and the inner, but the area or the volume will be the same. So let us see why. Because here the outermost will be plus minus square root 2, square root 2, pi, I'll write it outside. What will happen, it is, now here, see this one, how much is the distance until here from here to here? It is 4. See, the outer radius is 4. But then this is curving inside this parabola. So it'll be 4 minus x squared. Okay, that is 4 minus x squared. Minus, what is this? This is going out. Like it's opposite of the other one, so it'll be minus. If this was minus x squared, this will be plus x squared dx. This is it. Now what you need to do is basically put it in the calculator, and this was literally the same. You're supposed to get the same one. Whatever the answer you got, it's same, literally the same. So you can write the exact numerical value also, that's fine. Now another problem. So we have about square root. What is square root x? The graph is something like this, isn't it? And what about y is equal to 2? Okay, now this is a little bit important. X is equal to 0 is very simple. This is the graph, this one. Y is equal to 2. It's somewhere here, right? Y is 2. But where does it touch? Now, let me draw it. And it touches somewhere. Of course, it will touch somewhere. What is that point? How can you find that point? I know this is 0. This is 2. This line is 2. And this part is being rotated now. Along which axis? Y axis. So it will be something like this. Okay, this side. That volume we need to find. Okay, this part is being rotated to the other side. How can we find this? Is basically, see, a y equals square root x. Now I know what is the y value. What is y value? It's 2, right? 2 is equal to square root x. So can you square on both the sides? It'll be 2 square is 4 equals square root goes x. So this must be how much? 4. So this line is 4. So that's how we get it. But in this case, you don't need, because it's along y-axis, so the limits are just 0 and 2. The limits will be 0 and 2. So you don't need this actually. Anyways, let's see the graph, which is more accurate over here. See, this is the thing. It touches at 4. I hope this is clear. It's the same thing what we have done, but it's more accurate and to the scale. Now we are rotating along this axis. Now what do we do? Here, volume is equal to, directly I'll write pi. Now do we need to add outer radius, inner radius and all? No. Why we don't need that? Why? Because look, there is no part to be removed. Now this is rotating like this. It's the entire thing, right? Only when, say, imagine you're rotating like this from here, and then it'll come down like that. Sorry, let me get back over here. See, if this was the case, and then you're rotating like this, then yes, there is outer radius and inner radius, because this is changing, right? This must be removed. But here it's not like that. We need the entire thing. So all we do is we find this particular equation with respect to, not like this, not y is equal to, we have to write x is equal to, what is x is equal to? Square on both the sides. It'll be y square is equal to x. So it's y power 2. So that is the graph. Now then, integral a to b. What is the limits? It's 0 to 2. It's given already, 0 and 2. And because this starts from 0, so it's pretty obvious. We have y squared, the whole square, and it's with respect to dy. Now in such cases, do some steps. It's pi, okay? Now pi over here, it'll be 0 to 2. It'll be y power 4 dy. See, if it's such simple problem, do the integration. It'll be y power 5 by 5, and then use the calculator and solve it up. Now I'm going to use the calculator directly here. So here we have integral. You don't have y, you have to take it as x itself. Now if you're directly going to substitute this instead of converting to 4, then please put the brackets y square to the power square, and then it is 0 to, the answer is 32 by 5. So what I write is pi times 32 by 5, which is equal to 32 pi by 5. That is the volume. Hope this is clear. And here we go, it's 32 by 5. Or you can just try directly doing it as power 4. Not this 24. Okay, it's like this. And close the bracket, you will get the same answer, 32 by 5. But remember, pi is also this, so it will be 32 pi by 5. Now the same question again, but when x is equal to 4. So what they want over here is, sorry, let me go back. What they want over here exactly is, at this line, if I rotate it along this line, it's going to be that side, right? So that is what they want. Now in such case, it will be outer radius and inner radius. From here, from this as the center of rotation, how much is the outermost radius? It's a flat line. So RO radius will be 4. What is the inner radius? Ri will be 4 minus the inside one. It will be 4 minus, what is this part with respect to y? I mean, x is equal to, what is it? Y square, right? So it will be 4 minus y square. These are the two radius, outer radius, inner radius. So now I just put it in the formula. Pi integral. What are the limits? It's from 0 to 2 itself, doesn't change. Outer radius is 4 square minus inner radius is 4 minus y squared the whole square dy. And then we just put that in the calculator and there we go. That will be the answer. Here integral. You can do part by part. I'm just going to do it together all together. 4 squared minus, open the bracket, 4 minus x squared and close the bracket and square it up. And here we go. It will be 0 to 2. That is the answer. It's 224 and then you have to write multiplied by 224 by 15. That is B. And then write it as 224 pi by 15. So that will be the final answer. So here 224 pi by 15. Again, similar problem. Now we have y is equal to x squared. Let's draw this one out. Y is equal to x squared. It's a parabola from 0. And we have x is equal to y squared. That is also a parabola, but it goes right side, isn't it? Like this. This is the graph. And they have not told any other points because this is the intersection points. Now this is what we need to solve for. So let's see the figure which will be more accurate. You can see this is the graph. This is one parabola. This is one more. See what I've done. One parabola, one parabola. But only this is the region which we want. So they're only focused over here. Now what exactly do we do? It's rotated along the y-axis. So this will come this side like this, right? So that rotation is required, okay, along the y-axis. So that'll create the rotation. But first we need to find the intersecting point. Over here it's given 1, but if it's not given, how do you find this? It's very simple. You need to just make, you can find both y point and x point. So what you need to do is first make both in terms of same thing, like y is equal to x squared. What is y over here? Take square root on both the sides. X is equal to y. Square root x is equal to y. So y and y we know. Now make them equal. X squared is equal to square root x. How do you solve it? Square on both the sides. X power 4 is equal to x. Now you can put this in the calculator. It should give you the correct answer. But just think for a minute. X power 4, when you raise something to the power 4, it must be equal to its base. Is there any number that stays same even when you raise it to the power 4? It's only 1, right? So that's the thing. And minus 1 is out of the domain. So we don't go to minus 1. It's only 1 because 1 to the power 4 is 1 and x is also 1. Yes, this stands. Same thing with the other thing. X we know is y squared. What about this one? We can write it as square root y is equal to x. So x is equal to square root y. Let's make them equal to each other. Y squared is equal to square root y, or y power 4 is equal to y. Now only 1 power 4 is equal to 1 because if you put any other number, 2 to the power 4 is not equal to 2. It doesn't make sense. Only 1 can withstand this property. So that's the answer. Now here then we can understand easily 1 and 1. So a limit, that helps us to give a limit. But now they have told about the y-axis. So 0 to 1. This is the point. 0 to 1. Oh, sorry, about the y. Yeah, correct. About the y-axis, isn't it? Now let's do it. V is equal to pi integral 0 to 1. We just found out that. Now, which is the outer radius? From here, which is the outermost? It's the first one, isn't it? But remember, y-axis means it's with respect to dy. So I need to write x. This is y square root is equal to x. And this is in terms of x, so it's fine. So x is equal to square root y. X is equal to square root y. And this is x is equal to y square. These are the two functions. The outermost, outer minus inner, right? So I'll have to write square root y the whole square minus y square already and then the whole square. Now just put that in the calculator, you should get the answer. See, getting this equation, this is the most important thing. You will have marks for each of these terms. So you might have 1, 2, 3, 4. So getting the limits is very important. These will have marks. Writing these two terms, then getting the answer. Integral. Now here we have square root, but we can't write y. We have to write it as x itself. Press next, close the bracket, square it up. Minus y square. Let's close the bracket, open the bracket and close the bracket. And now square it up. It goes from 0 to 1. The answer is 3 by 10, but that means it's 3 pi by 10. So v is equal to pi times 3 by 10. That is equal to 3 pi by 10. Or you can directly write 3 pi by 10. So this is how we solve this problem. Let's check the answers. Yes, that's it. And what if it's along x is equal to 1? Same question, but over here they have told x is equal to 1. This is the point. It's not along the y-axis anymore. It's along this point. Now here, everything will remain same, but there is some little changes. Let me tell you in a minute. But before that, let me write this equation first. X is equal to square root y and x is equal. Why I'm writing this? Because again, even it's along x is equal to y, it will remain dy. Volume will be pi and everything, and it's dy itself, isn't it? And what about this? X is equal to y squared. So now from here, this point, how much is the distance to this line? See, from this to this line, outermost radius. Outer radius, it is not 1, but it's not just this equation, it's the outer radius 1. See, the distance is 1, isn't it? And then it's coming in. 1 minus 1 square. That is what is the outer radius. But what about inner radius? Inner radius is also 1. See, that's the same thing. 1, but minus the square root y. Look carefully. This much is the outer radius, and then it's coming in. So inside. So minus y squared. And here also the same thing. It's coming inside only, right? It's not, if it was going out, then we have to plus. If it was going out, plus y squared. But here both are minus and minus. One is y squared, one is root y. So here the formula would be 0 to 1, the limits, the same just like the previous part, that is part A. We got 0 and 1. Now here we'll have 1 minus y squared the whole square minus 1 minus square root y the whole square. And what next? So you just put in the calculator. You can do few steps because it's writing exam. I'll directly do it in the calculator only over here. It'll be 1 minus no y, so we use y squared, close the bracket and then again square it up, minus, close the bracket, 1 minus square root x, close the bracket, square it up, and over here we are getting 0 and going to 1. So the answer is, will we get in fraction? It's taking a bit time. Don't worry, even if it takes, just leave it like that and you will get the it might take 30 seconds, just give it some time. So it's 0.3667, and if you multiply by pi you'll get the final answer. There is one thing I want to just show you. Let me just write it out over here. V is equal to pi into 0.36667. Whenever it's recurring like this, if you write the answer, okay, it's not working, but you write it by yourself, 0.3. If you write a lot of sixes, you automatically get 11 by 30. So it's 11 by 30 pi. Or you multiply this 0.366 times pi, you get 11 by 30 pi, or the answer is 1.51. Both are correct. V is equal to 152, or you can write it as 11 pi by 30. But it just takes more time, like doing this. And also you can just leave it over here or even write this. It's up to you. The answer has to be either one of this. You can see here it's 11 pi by 30. So the next problem here, we have e to the power x. This is an interesting problem. Why? Because in the terms of e to the power x, we don't start from 0. You shouldn't remember e to the power x graph. It's exponential growth. It'll come like this and then it'll go like that, right? So this is important. It'll be 1 year. I hope this is clear. Now then, if it's 1, then what about this upper line? Let's see what is given to us. It's y is 0, okay? Y is 0. That is this line. Let's just see what is known. X is 0 and X is 2. Okay, so these are few things. How can we find this point and this point? They have told along y-axis. That means in the formula, it'll be some limits. It'll be with respect to, not like this, you should write x is equal to and with respect to dy. So here the limit will start from 1. The lower limit will be 1. Why? Because exponential function, it's from here, not from below. So from here, and it's along the y-axis. So this is the axis we are rotating. How do we find this point? And how do we know it is 1 exactly? So what is this point along x-axis? It's 0 and this is 2. They have clearly told x is 0 and 2. So I'll show you in calculator these values. Look here, shift e to the power, x value is 0. So what is the answer? It's 1. And now what about e to the power 2? That is for x is equal to 2. What will be this value? It will be 7.39. But let's take it as e to the power itself. Why? Because you'll get more accurate answer. So this is e to the power 2. Why? Because x is 2. Function is ex. Now one very important thing. Y is e to the power x, but I cannot write y. I need to write x is equal to whatever I get after I rearrange it. How do we solve this up? It's exponential and natural logarithmic functions. So let's solve it by multiplying natural log on both the sides. It'll be ln y is equal to ln e to the power x. This cancels. You'll have ln y is equal to x. So this is basically x is equal to ln y. Now here it's 1, 2 what? E to the power 2. Now what are the what do we have to integrate with? See, this is from the axis. It's not from other point. It's not outer radius, inner radius. It is just that which is the outermost line. It is 2 square minus the inner line, right side, right equation minus left equation, isn't it? That is ln y the whole square dy. That's it. You just have to put this in the calculator and you'll get the answer. Here let us use integral 2 square minus, open the bracket, natural logarithm, x, close the bracket again, and then square it up. It's 1 to e to the power 2, and the answer is 12.778. Okay, I forgot to write pi. It'll be pi times 12.778, and that will be multiplied by pi. This answer itself, you can just write multiplied by pi, that is shift and this symbol here. It's 40.14. That is the volume. V is equal to now, V is equal to 40.14. Now you can check the values. Here, let's solve this up and check. It should be 2 pi e squared minus 1, close the bracket. It is 40.14 itself. Yeah, that's the correct answer. Similarly, we can solve this one as well. Now I will use the graph which is given to us. Here y is equal to minus 2 somewhere down, and okay, it's minus 2. It'll be over here itself. This one, this line, and then this is the rotation. That's how it's rotated. Now here it's along y, it's not along the y-axis, it's a different thing. The formula will be in terms of dx now. Let me show you here, let me write it out. Integral, the answer will be in terms of dx. So I have to use this equation itself. So what is this equation? E to the power x. But the issue is we are away from the axes. So this is the extra part, it's 2 extra. So what is the first equation? From minus 2 till over here, and then this equation, right? So the outer radius will be 2 plus e to the power x. That's it, because we are 2 away. It's not from the axis. If it was from the axis, we directly take e to the power x, but we are away from it. That's the outer. What is the inner? We have to just remove this hollow space, right? This hollow space, that's 2. 2 is the hollow space. So let's write here pi, outer equation is 2 plus e to the power x, the whole square minus 2 square dx. And now we just put that in the calculator and we'll solve it. I'll put it all entirely together. So here we have pi, I'll write pi as well, then integral, open the bracket, 2 plus e to the power x. and then close the bracket and square it up, and then we have here, okay, what are the limits? Now the limits are not 1 to anything, it is this one, it's along the x-axis. Now we are not bothering about 1 and anything, it's the entire thing from 0 to 2. The limit is from 0 to 2. So therefore we just have to worry about this equation. All this is required. And until wait, see over here, it's clearly mentioned. See, this is the part. This is the rotation which we want. This, this, and this. See, this much will be rotated down like this. It'll come a little up, then it'll go down, and this is the straight line. So we need all this, but okay, no, it'll come down. Okay, it's not over here. This entire thing will be translated down exactly. It'll come like this something. So this region is not required. That two regions, see, this two region must be deleted. Therefore, we write this minus 2. Now, I said that, but I forgot to write minus 2 here. So let me write it out. Here, this much minus 2 square. So the answer is 164.48, you can tell. So the volume is 164.48. Now you can do one thing if you want to write in terms of pi. So after doing that, just remove that thing. So here we'll get V is equal to pi times 52.355. So this is how we can also do it. And here we go, the answer is, okay, now let's try and check the answer. We should get 164.48 pi multiplied with e to the power 4 divided by 2 plus we have 4e raised to 2 minus 9 by 2 is 4.5. You can write 9 by 2 as well. It's 164.479, that is 48. And here we have one more with regards to secant x. Now the thing is, how many of you remember secant x graph? I'm sure many of you don't. If you recall, secant x has some conditions. It's only from minus pi by 2 to pi, I guess. Let me check the graph. Okay, yeah, it's minus 1 point. Yeah, it'll be minus pi by 2 to pi by 2. And it does not come more than 1. It's always like this. But at the left side, you will have, so like this, so that's the graph. Now here they have given us the limits, and along y is equal to 2. So y is 2 is this line. Along this line we are rotating it. Now so we need the limits along the x-axis, right? What are the limits? It's pi by 4. So this is the one, minus pi by 4 and pi by 4. So when we use the integral, volume is equal to pi integral, it's easy, minus pi by 4 and pi by 4. So that's given. And what else? Now you need to see, this is the axis. What is the rotation exactly? What is the outer radius? What is the inner radius? See here, from this line, y is equal to, what is the axis? See, this entire thing has to be rotated, right? See, how much is it? It's 2. So R outer is 2. That's easy to get. What about the inner radius? Inner radius is Ri. It'll be 2. Then this is inside. It's cutting in, right? 2 minus secant x. That's it. So let me write it out. It's going to be 2 squared minus, again, 2 minus secant x the whole square. That entire thing dx. I hope you're getting a hang of this. Don't think, okay, this is a unique problem. No, nothing like that. What are the regions they bounded by? Y is equal to 0. See, from here y is 0. These are the two, pi by 4, minus pi by 4 and pi by 4, and this is the region. So this is being rotated. See, this part, right, is being rotated like that along this axis. So it'll come over here somewhere. So that is the region, the volume we need to solve for. Now then, this is along dx, and we'll just put that in the calculator. The thing is, how will you put secant x? We don't have secant x in the calculator. See this here, 2 square minus, open the bracket, 2 minus, secant x is 1 by cosine x. So it's not shift, it's just cosine alpha x, close the bracket, and then we will close the bracket again, and then square it up. This entire thing will be squared. And what are the limits? It's negative pi by 4. So it's pi by 4. And here we have pi by 4 as well. Now, please don't use degree mode. Now, this is in degree mode. If you can see here, it's D. Shift mode 4. Now you'll get the correct answer. Okay, something is wrong. Uh, okay, what is the mistake? Okay, I've opened the bracket, but I've not closed it. So I'll just not, because it's 2 only, right? So no need of this bracket. Okay, now it should be all good. Yeah, it's only one bracket that's closed. The answer is 5.05. Okay, now what I'll do is first I'll write pi here multiplied with this. The final answer is 15.868. 15.868. Above you can write pi times, just remove that pi now, 5.05. 5.051. That's it. So this is the volume for this particular function. I hope that's clear. You can see, okay, it's a numerical value itself because it's tan and all. It's very difficult to get in terms of pi. It'll be numerical. What about this along the x-axis? Again, the same graph, but it's just that we are rotating it along x-axis only. Now, if this is the case, see this. I'll just highlight the region. This one, it's going down like this, okay? That is the volume we are finding. Are we having any outer radius and inner radius? No. Do we have to do 2 minus? No, because we are literally doing along the axis. So this is the region. It'll be rotated just below like this. So you can easily do, or easily just use that secant x. That's it. Along the x-axis, this is the limit, minus pi by 4 and pi by 4. Let me show it. Pi times minus pi by 4 to pi by 4. And here, it is just secant x the whole square dx because there is nothing to remove here. That's it. Just put that in the calculator, you'll get the answer. Now it's good that we have not removed anything. If we had cleared, we have to type everything again. So I'll just remove this. Secant x the whole square is 1 by cosine x the whole square. So here, that's it. Answer is 2. So pi times 2, it'll be 2 pi. So it'll be pi times 2. It's 2 pi. That should be the answer. Let's just double check the answer. Yes. I hope this is clear. If it's along the axes, even if it's y-axis or x-axis, it's very easy and simple. But this one, since it belongs both the side, they'll just give you along x-axis like this, along the horizontal line only. Now, what about this one? It looks a little bit scary, right? But still, you know it's a square root function. Only the thing is the values are very hard to find. Say, for example, I know this is something like this. But it's just not 1, 2, 3. It's not easy values. It's complicated values because it's a rational function within a square root function. So for this, you need to have graph. But even without graph, you can, guesstimate the values and try. You can use the table mode 7 method also. But instead of that, what I'll do is I'll just use this graph. It's much handy. What is the value you need to consider over here? At about x is equal to 1. See, this is the line. Can you see the red line over here? Till there. So till there we need to consider. Now that's a very crooked line. Now basically you're rotating it along x-axis. See, along this axis. Now this much is rotated along the x-axis. So it's just going down like this. So it's very simple. Why? Because there is nothing to remove or add. It's literally the entire thing, isn't it? Just like the last problem. So here the formula will be, what is it along the x-axis? 0 to 1. So the limit is 0 to 1. The entire thing, x by x squared plus 2 the whole square dx. This is it. So these are very simple when it's on axes. So here we use this integral symbol. Open the bracket. It's square root fraction x divided by x squared plus 2. Close the bracket. Go see, you need to, after this, if you press right, it's still inside the square root. Again, you need to press right and then close the bracket and square it up. The limits are 0 to 1. Here we go. The answer is so much, but I'll write it as pi times. Okay. So that's the final answer. It should be V is equal to 0.6369. Another easy problem. Now 0.637. Why? Because 69 is 67. That's the exact value. What about y is equal to 3 again? Let's look into the graph. Here we have y equals 3. That is somewhere down. Okay, somewhere up. Somewhere over here it's being rotated. Now you have to do outer radius and inner radius. What's the outermost radius? It's 3. RO is equal to 3. What is the inner radius? It's same thing. 3 minus the equation. That is square root x by x square plus 2. Why? Because from here to the outermost it is 3 itself. But then you're subtracting whatever it's coming in. Because it's along this particular line, that is at y is equal to 3 here. Now I'm just going to write the formula. It's pi times 0 to 1. And now the outer radius 3 squared minus 3 minus square root x by x squared plus 2, the whole squared dx. Now I just put that in the calculator. It's very simple to put in the calculator, right? But you need to understand, this is the most important thing. See the limits, the outer radius, the inner radius. And then what we do is just do this. And if you want, you can also follow this, but use some dummy values, like dummy steps, and then write the final answer. Okay, I've missed something. I've opened a bracket here for no reason. So it's taking a bit longer. The final answer must be 7.47. So here you can see that they have done integration and then apply the limit as well, but the answer is the same. Or what you can do is, instead of this 7.47, you can write it in terms of pi as well. Whatever the answer you get, it'll be something like 2.3 or something. Just divide this by pi, you'll get the answer. It's better to divide rather than remove that and do the integral. Anyways, you can write this pi times 2.378 and then the final answer as 7.47. It's the same thing. Now we have again an exponential and x is equal to y is equal to x squared. Now here as well, the graph is a little bit tricky, isn't it? Because we have this parabola with exponential. See, if you know about graphing, then you realize this graph comes like this. It varies, but it comes something like that. Let's just look at the graph. This is a simple parabola, but look at this. It comes like a wave. So here we are rotating along what? Along the x-axis, along this axis. Here's the rotation. Now it's not outer radius minus inner radius, it's just the outer equation minus the inner equation, because we're dealing with the axes, right? So here we need to write v is equal to pi integral, but what are these values? Okay, this is very important. These intersecting points can be found by equating y is equal to y, that is e to the power minus x squared is equal to x squared. Now, there are some approximation methods to find this, table methods and all, but the easiest is the calculator method. Let's type this out. It's shift and e to the power minus x squared equals x squared. Okay, it's x squared. I don't know what did I type. Equals is alpha and equal to, and over here you press alpha x squared. Shift and solve. Equal to won't give you the answer, and that's the answer. It's 0.753. Now, here you can write x is 0.753, x is equal to 0.753, but it's plus or minus because it's squared, right? You will have positive and negative. So it's, it's symmetrical, both the sides. So pi over here, it's minus 0.753. Here it's plus 0.753. And then it's very simple. The outermost equation from the x-axis, what is it? It is the e power minus x squared. And here what is this? It's parabola x squared. So it's e power minus x squared the whole square minus x squared the whole square dx. That's it. Now you put this in the calculator, you will get the answer. So integral of e to the power minus x squared, close the bracket, and then square it up, minus x squared. You need to use a bracket over here, or you can write power 4 if you are confident with it. X squared whole square will be x power 4, directly you can write it. and this is it's minus 0.753, and over here also it's 0.753. That is it. You will get 0.99, but this is with pi multiplied by 0.99, but multiply pi will be less than 3.14. It's 3.1131. This is the final answer. As you can see, it's 3.113. Similarly, we'll move the next one. Here you can see again the same equations, but they have told minus 1. Let's see the graph. See, this is 1, positive 1. It's minus 1 somewhere down along that axis. So now there's outer radius. From here, what is the outermost radius? We don't take that equation directly. What is this distance first? Distance is 1 plus the outer equation. What is that outer equation? 1 plus e minus x squared. That is our outer. What is our inner? So that will be, now here, you're going to add both the equations. See, this much, and then you're adding this equation, right? And even the inner equation, so much, and then you add this parabola because it's going away from it. If it was coming inside like this, then you do minus, right? But no, this much plus the outer equation, this much plus the outer equation, both the inner equation, sorry. So it'll be 1 plus x squared, that's it. So we will do the formula. It is v is equal to pi integral. Now I hope you remember it was 0.753. Yeah, 753. 0.753, how I remember is it's 753. That's how I remember. But anyways, let's just check it, double check it, because when I was typing I saw it was 753. Yes, it was 753 itself. So yeah, just erase it. And what we have here is outer equation, that is 1 plus e to the power minus x squared the whole square minus the inner equation 1 plus x squared the whole square dx. And just put that in the calculator and that will be the answer. Here I'm just going to edit this. So I'll write 1 plus, then the same thing, squared minus 1 plus, it's not along the axis, so that's why the additional distance. The answer is 9.266. That's it. And now we have a problem where they have given us the graph. So I hope in the exam as well, they give you the graph, it'll be easier to understand. The equation y is equal to 4 minus 2x, that's the equation. And it is revolving, and the axis, y and x axis, they have told it's bounded by what the axis is. This and this, the x and y axis, it's already there here. We need to revolve it along y axis. So it's going to come something like that. So that's it. Here there is no two equations, it's only one equation. Why? Because it's along the axis itself. So how is it going to be? It will be, okay, first of all, it's not this one. You should change this, right? Because you should have with respect to y, that means x will be equal to, it will be 2x is equal to, take it to the other side, 4 minus y, x will be equal to 4 minus y by 2. So this is the x value, or you can simplify it further. What I'll do is 4 by 2 is 2 minus y by 2. So you can write it like that. Okay. Now that is the equation. So it is pi integral. What is the limits here? This is very important. The limits will be along the y-axis. This one, 0 to 4 only. 0 to 4. So 0 to 4. The equation is 2 minus y by 2 the whole square dy, because it's along the y-axis. Now put that in the calculator, you should get the final answer. Integral 2 minus y divided by 2. We don't have y, so we use x squared. Here it is 0 and it goes until 4. 16 by 3, but don't forget the pi, it should be 16 pi by 3. Yes, there we go. What if it's along the x-axis? The same thing. Now here rotates along the x-axis. That's fine because this left side is not there. So this is not there, but it'll be like this. Now again, it's a single equation itself, but take this original equation. For b here, it should be pi. Now what is the limit? It's 0 to 2. 0 to 2. pi is already there, 0 to 2, and we have 4 minus 2x the whole square dx. This is the equation. We can't change this. Let's write it anew. Sorry. Integral 4 minus 2x, close the bracket and square it up, and it's from 0 to 2. And here we go, it's 32 by 3 pi. It should be 32 by 3 pi, or 32 pi by 3. What if it's y is equal to 4? Same thing. Here, y is equal to 4 means this line. Now there will be outer radius and inner radius. What's the outer radius? From here to here, it's 4. RO is equal to 4. Inner radius here, 4 minus the thing, right? Ri will be 4 minus this equation. 4 minus 2x. I'll write it properly. Outer radius RO will be 4. Inner radius Ri will be 4 minus the given function 4 minus 2x. But what if we simplify this? It will be 4 minus multiplied both the terms. It will be minus 4 plus 2x. 4 minus 4 is 0. Just write 2x. Positive 2x will be the answer. So let me use the rule now for the C. It will be pi integral 0. Again, it's along the x-axis, the limits. It's 0 to 2. And 4 squared, that is the outer radius, minus the inner radius is just 2x. I'm not going to write 4 minus. It'll be 2x the whole square dx. Now we put that in the calculator and we should get the answer. So again over here we can little readjust and write. So it's 4 squared minus 2x the whole square. It should be 64 pi by 3. 64 pi by 3, that's the correct answer. What about the D? It's minus 4. So instead of this above 1, y is equal to minus 4. That means we go down over here. Minus 4, y is equal to minus 4. And here, see, this much hollow space is created. Even over here below also hollow space. And then you will have something like this. Okay, that's revolved. So there's a hollow in the middle and that must be removed. So again, we need outer and inner radius. So the outer radius over here, what would be the outer radius? Since this is exactly, now inner radius is easy. Look at from minus 4 to over here, the axis, x-axis, you can see that is a flat line. So basically the inner radius, Ri, is a flat line. That's 4 distance. That's it. This is 0, isn't it? That's 4. So minus 4 to 4, it's inner radius. That's it, 4. But let's look at the outer radius. From here to here, how much is that? 4 plus 4 is 8. Outer radius is 8. But then this equation is coming in, isn't it? So what we have to do is 8 minus the equation, that is 4 minus 2x. So let's simplify this. It will be 8 minus 4 plus 2x. Plus 2x. So it's going to be 4 plus 2x. That is the inner radius. Now there's one more way to write this. See, this is, let's try both. Okay, so option D would be from here to here, it is 0 to, now it's along the x-axis, 0 to 2 itself. And then we have outer radius of 4 plus 2x minus 4 square, both are squared, dx. Or, so what we can do is, see here, this is the given equation, right? That is 4 minus 2x. We know this inner radius will not change, it is 4 itself. But what about the outer radius? RO can be written as 4 plus this equation because it's going upwards, right? This much is for sure 4. And then add this equation up. What is the equation? 4 minus 2x. So what will be the answer? It will be 4 plus 4 is 8 minus 2x. So even if I try that out, it should give me the correct answer. Same answer. Let's write 2 minus 2x the whole, 8 minus 2x the whole square minus 4x 4 square dx. Let's try both of this. See, whether you take 8, total 8, and then minus the equation, or you take this 4 and then add the equation, you should get the same thing as long as you're following the correct rules. So let me do it over here. Integral, first equation was 4 plus 2x close the bracket and square it up. Minus 4 squared, that's the inner radius. And the limits are 0 to 2. What is the answer? It's 128 by 3. That will be 128 pi by 3. Yes, that's absolutely correct. Now here we must get the same answer even for the second one. Let's just rearrange this one. Here it is 8 minus 2x and everything else is the same. Is it correct? Yes, 128 by 3 pi. So this is how you can easily see that whichever values you write, as long as you follow these rules, you must get the correct answer. I hope that's clear. That's it. Okay, there's still more. Let me clear it out. At x is equal to 2, that is this line here. Now it's along dy integral. It'll be with respect to x, that is dy. You should rearrange this and write x is equal to, it'll be 2x is equal to 4 minus y, and x is equal to 4 minus y by 2, or you can write x is equal to 2 minus y by 2. That's up to you. Now then, if you're doing this, what's the outer radius? So outer radius over here would be just 2, isn't it? Because from here to here it's 2. So let us write 2 as the outer radius. Let me write over here RO is 2. What is the inner radius? Inner radius 2 minus this equation. Inner radius is 2 minus the equation. What is that equation? Don't write this equation. We are right in terms of y. So it'll be 2 minus y by 2. So let's multiply this minus sign both sides. 2 minus 2 plus y by 2, that is equal to y by 2 itself. So it is minus y by 2 the whole square. What is the limits? It's 0 to 4. So that must give us the correct answer. Here we have integral from 2 square minus y, that is written as x by 2 the whole square, and the limit is from 0 to 4. And the answer is 32 by 3 pi, and we can check the answer. It is 32 by 3 pi. Now what if you have written like this itself? See, 2 minus. Before I was writing it like that, doesn't matter. You can write this entirely. 2 minus, see the inner radius is 2. 2 is total. Minus this equation. Minus, but you need to add another bracket. 2 minus y by 2 the whole square, and close the bracket, and then the whole bracket, and then square it up. The answer must be the same. See, it's the same answer. And f over here asks us minus 2. So minus 2 is somewhere over here, right? From here now. From here, just like a couple of problems ago we did, I think so it was D. There are various ways to solve it. I will just stick to the simple one. From here to here, how much is it? 2. So R inner radius is 2. R outer radius can be written 2 plus the equation. What was the equation? That was, we had simplified and written it as 2 minus y by 2. So this is it. If you have written so much, if you have simplified or not simplified, whatever you have, just write it out. In the calculator we're going to put it, and let me write it in terms of 0 4 integral. Pi is always there. What is the outer radius? First we write the outer radius. That will be 2 plus 2. I can write 4 minus y by 2, or your choice, you can write this entire thing, the whole square. Then minus 2 square, it's with respect to y, dy. Put it in the calculator now. The limits are same. I'm just going to rearrange it over here. So it is 4 here. That is going to be 4 minus y, and I'll remove one bracket. That's done. And this entirely will go off because this is the first term. First term is done. Now minus 2 square. This is the outer radius minus the inner radius is, it's not 4, it's 2 square. Or you can write 4 directly. 2 square is 4. 64 by 3 pi. Now 64 pi by 3, or you can write pi separately. And wait a minute, there's some error over here. It shows, let's just double check this. Let me just check my values. It's 2 plus this equation I have done, and yes, this was the rewritten form. And in a radius, no, this must be correct. This is correct. It's
from here the distance is 2. Yeah, let's see what they have done over here. Is it correct? Let us do integral. Is this let us check this. So they have written 8 minus y. The reason being they've rewritten this as 2x is equal to 4 plus y, sorry, minus y, and then x is equal to 4 minus y by 2. So this is what they have done. And then what they have done is basically uh, they have added the 2 here because the outer radius is correct 2 from here to here. The inner radius is 2. The outer radius will be 2 plus this equation, isn't it? 2 plus 4 minus y by 2. Let's do this. Here you can multiply 2 and 2 will be 4 by 2. 4 by yeah, 4 by 2, because you multiply and divide by 2, plus 4 minus y by 2, and here then we will have 2. 4 plus 4 is 8 minus y. Yeah, that should be correct. So let's try it in the calculator now. So it should be integral. First one, it's this one, 8 minus x. Okay, I should write fraction 8 minus x and close the bracket and square it up, minus 2 square, and it is from 0 to 4. Let me write out pi here. The answer is 64 by 3. This is this correct. The starting one, what they have written is correct, but the solving is wrong. The answer is wrong. This is the correct answer, 64 by 3 pi. I hope this is clear. That is what we had got initially when I had written the steps and done it. Here, even if you take it differently by fractions, the answer will remain same. Doesn't matter what. Now we have another problem. They have given us the region bounded by y is equal to x square and y is equal to 4. So it's a parabola and at 4. So let's use the figure over here. It's a simple figure. Parabola and 4 you have a linear line. And now they are asking us the solid formed by revolving r along y is equal to 4. So along this line itself you're rotating it. So what's going to happen? So this is where you're rotating it. So it's going to be from here to here. Now this is having outer and inner radius. Why? Because this is not on the axis, isn't it? So what will be the outer radius? Outer radius is total 4, right? Minus this equation. So let's do, so you can ignore the outer and inner radius because outer radius will be total 4 from here minus this given equation. What is that equation? It is x squared. Why? Because it's y is equal to 4. It's along with respect to x. Here in the formula, you'll have dx. So that is the outer radius. What's the inner radius? Inner radius is 0 because this line, right? There's nothing. So I'll just have to write this one. So it'll be pi. What are the points of intersection? How do you get that? That is by solving this. Y is equal to y, that is x squared is equal to 4. Take the square root on both the sides. X is equal to plus or minus 2, or you can use mod phi 3 in calculator. That'll bring this 4 to inside. It'll be x squared plus 0x minus 4, but it's very simple, square root, right? Remember, when you take square root, you will have two values. It's minus 2 and plus 2. And then you have the outer radius, that is 4 minus x the wholes. It's x squared here, that the whole square. And it is minus 0 squared. That doesn't matter, ignore that. You don't need to write it as well. So outer radius was this, and let's use the calculator and solve. Here it is integral 4 minus x squared, close the bracket and square it up. I hope that's clear. It's x squared and then another square outside. And let me write 0 squared as well, but that's just gone. Over here the value upper limit is 2, lower limit is minus 2, so the answer is 512 pi by 15, because you have to multiply by pi as well. So here we go. Now what if it's along the y-axis? So again, the same graph. Let's do this quickly as well. Okay, that's by mistakenly shown. Now y-axis is this line. It's along this axis. So here when you look at it, you're rotating along this axis. But what is the graph formed?
It's not x squared. We have to write it in terms of y. X is equal to square root y, because you should take square root on both the sides, right? X is equal to square root y. So along the axis, the limits will be 0 to 4, and it's along the axis, it's only one term. It'll be square root y squared dy. This is it. And pi is there. Now I will write the next one. Let's go to the next. No, let's solve it up because it's each page has one question. Let me solve this. So let me write pi integral. It is square root x and then square that up. Because it's a single term, I didn't write the brackets, but it's better to put the brackets. And 4, this is it. It's 8 pi. What happens here? These are all simple problems. Again, y is equal to 6. That means above over here. Now it will be outer radius and inner radius from 6 till here. Outer radius will be 6, but it's coming in. So 6 minus x squared. That's the outer radius. What about the inner radius? Inner radius is just until over here to here. It is 2. Ri is 2. Why? Because we are dealing from 6 here, right? This is 6. From here to this is the flat line. This entire thing is the solid in consideration, right? So this is only 2. So what we do is limits. Now which limits are we considering? It's along the x, it'll be minus 2 and plus 2. So it's minus 2 to plus 2. And here we have 6 minus x squared, the whole square, minus 2 squared dx. This entire thing. Now let's put that in the calculator and check. Here we will have 6 minus x squared, the whole squared, minus 2 squared. And here we have minus 2 to the top 2. It should be 384 pi phi, yes. What if it's minus 2 now? Here we have, again, minus 2. That's somewhere over here, and that's being rotated. What will be the outer radius? RO will be from here till this point, and then we can, oh sorry, now first outer radius is a flat line here, right? See, it's a flat line. The lines are going crooked. It's been a long video, so exhausted now. From here to here, it's gonna be 6. What about the inner radius? Inner radius, see, from here to here, it's all flat. 2 plus, what is that? X squared. That's it. So your answer must be minus 2 to 2. It'll be outer radius is 6 squared minus 2 plus x squared, and that's it. See here. This is the outermost line. From there, when you see, it's a flat line. So yes, outer radius is that much only. The flat line over here, it is 2. Till over here, that's the extension. From the axis, it's going in. So till the axis, it is 2 plus this equation. That's why we do. Now, we can easily solve it in the calculator. Here we will just change what is this. The first one is 6 squared. And over here it is 2 plus x squared, then the whole squared. And the limits are from minus 2 to 2. So the answer is 1408 pi divided by 15. What about if it's x is equal to 2? And here we have the line, that's this one. Now from here, what is the limits? It is 0 to 4 because it's along the y. With respect to y, it will be dy. What are the outer radius? From here, see, now look at this. This is a part, it is x is equal to square root y, right? This is 1 square root y and this is 1 square root y. If you see square root x, it's like this. So here you need to be a little careful. So much we know is 2. Okay? So for the outer radius, all you need to do is 2 plus this extra part. So outer radius, RO, is 2 plus extra part, that's square root y. For inner radius, all you need to do is 2 minus the square root y. Why? Because it's coming inside. So it is 2 plus square root y, because from here it's to the axis it's 0, but it's extra, right? That's plus square root y. Minus 2 minus square root y the whole square. Why? Because this is coming inside. And the limits are from 0 to 4. So let's put that in the calculator. Let's write it out. It is 2 plus square root y. Now go next and close the bracket and then square it up, minus 2 minus square root x, close the bracket and square it up. And here we go, it is 0 to 4. And the answer is, let's see the answer, it should be 128 pi by 3. It's taking quite a bit time. Okay, here we go. That's the correct answer. We have to multiply this by pi. And the final and the last question here. Now they have told along y is equal to minus 4. So, sorry, x is equal to minus 4. I can't even read properly now. This is the line. It's rotating like this. So let's count what is the radius. See, over here again, from here to here, it is how much? It's not minus 2, it's minus 4. So it is 4. Distance is 4, right? So the outer radius RO will be 4 plus add the square root y. Inner radius minus the square root y, just like the previous one. Here we have 0 to 4, pi is outside. 4 plus square root y, this is square root y. The whole square minus 4 minus square root y, 4 minus square root y the whole square dy. So that's it. You put that in the calculator. Since I've been recording it as a straight video, I'm just now not able to focus. I'm zoning out. Anyways, here we have to just change this to 4. And then we have over here 4. And that must give us the answer. It should be 256 by 3 pi. It's taking a while now because we have the square root functions, right? So that's why it takes a while for computing the square roots. And here we go, it's 256 by 3 pi. And that is the end of this lengthy question. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will solve real world problems involving velocity. Here they have asked to show that an object dropped from a height of h feet. They have not told exactly in numerical value, they have just told us to take the constant h feet, will hit the ground at time t is equal to 1/4 square root h seconds with the impact velocity given over here v equals minus 8 square root h feet per second. They have not told much, but we can easily take that there is certain height involved. So what's the given? We can write the given over here. That is y of 0, the initial height, that is h. What about the initial velocity? It's been dropped, right? It's falling from up to down. They have not mentioned any velocity already in the object, so it is y prime of 0, that is equal to 0 because that is the initial velocity. There's none. Now, how can we start solving? All these problems can be started by acceleration due to gravity because there's always minus 9.8 meter per second square of acceleration due to gravity. But here you can see it is in terms of feet per second. So we can write minus 32 feet per second square. That is the acceleration due to gravity. Now acceleration is given as y double prime or double dash of 0, and that is minus 32. Now then, what is velocity? Velocity is obtained just by integrating this. If you integrate on both the sides, you just have to integrate y double dash of 0, that is equal to integration of minus 32. So what will be velocity? It's going to be y prime. So now here I've made a mistake. It's not with respect to 0, it's with respect to time t. With respect to 0 means it's the initial velocity. Now over here we are just taking the general form. So it's with respect to time t. Here will be minus 32t plus a constant value c, which we do not know. Now what we can do is, instead I'll solve over here how exactly to find the c value, but for the other problems I'll directly tell you how you can figure out what is the c value from the initial conditions. Now here for this one, this is also with respect to t. Now we know that y prime of 0 is 0. So let us take this with respect to 0, the initial condition. That is v of 0. You don't need to write this v of 0, not required. But this will be y prime of 0. That means what is 0? T becomes 0 plus c. Now what is y prime of 0? It's 0. That is equal to 0 plus c, or c value is, sorry, not 32, it's 0. So c value is 0. So now what will be the velocity with respect to time t? It is just negative 32 times t. So this is how we get the velocity. Now then what can we do next? We can find the position by integrating it. Now the position function, or the height, okay, position or height is equal to y integration of y prime of t. That is integration of velocity. That will be integration of minus 32t. And here it will be y of t, and that is equal to minus 32 t raised to power 2 by 2. Why? Because we're integrating t, right? This is constant. When you integrate t, it will be t squared by 2. Now it's not over, there is no other term, so this much is over, but you need to write plus c. This is very important. Now what is this c? Here again I'll do it in detail. You know the initial value, so what happens? The initial height, when it's 0, it is h. And then over here what happens? This entire thing becomes 0 squared by 2 plus c. So c value is h. So the position is y of t is equal to only this much you have to write. It'll be minus 32 divided by 2 is 16. I'll write over here minus 16t squared plus c. Instead of c we write h. So this is the position function. We got the velocity, we got the position. Now this much usually is the same for all the problems. Why? Because you will be given some value, you just have to substitute over here and solve it up. Now bear with me for this problem because I've used these steps, but these are not required. You can directly get the equation. See, I'll tell you why. You know the initial velocity is 0, right? That means in the velocity with respect to time function, the c value is 0. I can directly skip that and write minus 32t. What about the position? It is given as h. So here the position function was minus 32 by 2 is minus 16t squared plus, instead of c I write h. So I can write it directly as well. Now what about the other things? They have told us to, see the impact velocity. They have given the impact velocity over here. So what exactly is impact? Impact means when it touches the ground. So here, whenever at impact, the position is 0. This entire thing, y of t, is 0 because it touches the ground. So now what I will do over here is use this impact velocity. At impact, y of t is equal to 0. And let me see, now this, I'm going to use impact because they have mentioned the impact velocity. That's the only reason. So let me find the time of impact first. Let me find the time. At impact, y is equal to 0. And if I substitute 0 in this equation, I can find the t squared, isn't it? Let me show you now. This is going to be 0 is equal to minus 16t squared plus h. I'll take this minus 16 to the other side. It'll be 16t squared is equal to h. Let me divide both the sides by 16. It's going to be t squared is equal to h by 16. And now take the square root. It'll be t is equal to square root h by 16. But did they give, okay, they have given us time. Is this correct? Yes, it's correct, because now if you split the square root here, it becomes square root h and square root 16. What is square root 16? It's 4. So it's square root h by 4 or you can write it as 1/4 square root h. This is correct. We have got this impact time. Now this is true. Okay. Now let's find the impact velocity. What do we do for impact velocity? This value of t, we just put it in the velocity equation. Now here y prime of t is known to be minus 32t, right? I'll just substitute. This is what we have to solve. Velocity, that is at impact, that is y prime of t, that will be minus 32 times square root h by 4. Now what happens here? 4 1 time, 4 8 times, so it is minus 8 square root h, and you can see that is correct. It is all in terms of feet, so it's feet per second. Over here time is in seconds, here it is feet per second. Yes, both of them are true. This is velocity and this is time, and you can see it matches with the values. So yes, we can tell this is true. That's the first part. Let's see the next part, what they want. See over here, the same thing is done. Here they might have skipped the steps. Now in the next problems, I won't do so many steps because all this still over here position can be done in just 3 to 5 steps. Okay, so we will do it in a shorter way. Now here the next one, they have told show that an object propelled from the ground with the initial velocity of v naught will reach a maximum height of v naught squared divided by 64. It's just that they have given us initial velocity this time. Initial velocity is known. Now look at these problems. It's all vertical problems because they have not mentioned any horizontal component or anything. There's no radian or degrees involved. So we just have to deal with the y dash or y prime. So what is the position? The height, sorry, the initial height. They have not given anything about height. So given over here, what I'll do is y of 0 is 0. Y prime, that is y prime of 0 will be equal to v naught. Next, that's it. That's what's given. We need to solve this. So let's start solving it. I'll write what is acceleration. A is y double prime of not 0. It's with respect to time t. Here as well, see, it is with respect to feet. So it is minus 32 feet per second square. Its units are feet per second square acceleration. Now here then I'll write minus 32. And now I'll just integrate both the sides, and then I'm going to get velocity, that is y prime of t, that is equal to minus 32t. Now I can write plus c and do the extra steps, but I'm not going to do it. I'm just going to write directly what is the c value. What is the initial velocity? Instead of writing plus c, I'm going to write v naught. That's absolutely fine. Now what is the height, h, or position? Okay, that is y of 0. Now what happens here? It will be minus t squared by 2. I'm just going to write it directly. See, it's the same like the last problem. This does not change. And here we have v naught, that's the change, multiplied by t. Now what is plus c? It is plus 0. I'm not going to write that. So these are the three equations. Now in the last problem, we took 1/2 of the page just for these three things. But you can directly write them and it's absolutely fine, because your main thing is in the next parts, not this one. Now what do they want? Will, if this is the velocity, will reach a maximum height. You're basically proving this. Okay, what does maximum height mean? So now, for example, object is propelled, it's from the ground, it's going like this and come down, right? Okay, it'll generally be a parabola, symmetrical. So imagine this is the thing. If I draw a straight line, what happens at the maximum height? The derivative is always 0. Derivative of the tangent line, that is derivative of this particular function, y prime of that particular time, is equal to 0. Why? Because only when the derivative is 0, it will reach the maximum height. That is, my voice is breaking. That is what what happens when we reach the maximum height. So here we will take this at maximum height, y prime of t is equal to 0. This is what we are mentioning. Why? Because they are clearly mentioned is to find the maximum height, and then we know the derivative of the position, the height, that is the velocity, will be 0. So now what is the velocity function here? We have been given this, right, velocity function. So let me use that. Here in this part, this is 0 is equal to minus 32t plus v naught. What is the time? When it reaches the maximum height, I can find the time of that from this velocity function. So that will be, I'll take this 32 to the other side, 32t equals v naught. And then take the 32 to the other side, t is equal to v naught divided by 32. That is the time when the maximum height is reached. This is time at maximum height. So you can just, if you understand this, it's fine. You do not need to write it, but if you want, you can write it as well. So this is the time when maximum height is reached. You can write to be a T max height, or you can just leave it like that. That's fine. Now put this time in the position because we need to get this maximum height. That is height equation or position equation. This one, last derivative. We integrated, right? The last function we got. So here y of 0. Now what is, sorry, y of t, not 0. See, I'm realizing at times I'm writing 0 instead of t. This is all with respect to t. Only the initial value is 0, okay? Whatever is given, initial height or position. This is equal to, now what is the time t? Here we know minus 16 into t must be v naught by 32. Or you can even write over here the same value. That is v naught by 32. Because that is the time which gives you maximum height. So here and here, that's plus v naught again, it's v naught by 32 times t. So let us simplify this. Here what do we get is 62, it's half. Now here I forgot to write the square. This is important. Now it's better to use calculator. It's huge numbers, isn't it? So I'll use the calculator to solve this. Here it's minus 16, so it's minus 16, not plus, multiplied by, I'm not going to write what's v naught, I don't know that. I'm just interested in the numbers, right? Divided by 32, close the bracket, square it up. Leave v naught because I know v square of v naught will be v naught squared. But these numbers, it will be minus 16 times 1 divided by 32 squared, right? That is equal to minus 1 by 64. Or you can even leave the minus sign, just do the numbers. Here it's 1 by 64 v naught squared. And then what do we have here? Plus, now okay, you can see here I have written this wrongly. I just realized now t is v naught 32. So over here, let me rewrite this properly. See, this v naught remains. What is the t value? T value is v naught by 32. Now this v naught multiplied by v naught is v naught squared divided by 32. So we have minus 1 by 6. It'll be, yeah, it's same 1 by 64. Yeah, that's correct. See, now what happens is it's 1 by 64. I have to remove that answer. See here, this minus 1 by 64 plus 1 by 32. 1 divided by 32. It's positive 1 by 64. Why? Because this is greater. This is half of it. It's like you're subtracting half, 1 minus half. You'll get half, right? The same thing. So here, why are we doing this? Because it's v naught square and v naught square. That's the same value. It's like x and x. You can subtract. If it's 2x minus 1x, you can subtract it, right? The same way we solve these because the coefficients of the same terms over here, variables are same. It will be positive 164 v naught square, this is. And look at the question. Yes, that is what we are getting, right? That is v naught squared by 64 feet, but only in feet because that's the maximum height. And therefore, we have got the correct answer. So this is how we solve it up. The graph and all is not required. This diagram is just for understanding. This is also not required. But whatever I've written is pretty important. The sentences may not be required over here. At maximum height, this is not required. But the solving is very much important. So here we go. So here we have an interesting problem. According to legend, Galileo dropped two balls from the Leaning Tower of Pisa. When both the heavy lead ball and the light wood ball hit the ground at the same time, Galileo knew that the acceleration due to gravity is the same for all objects. Air resistance would affect such experiment. Taking into account air resistance of 6-inch wood ball would fall at this particular equation, and it's in feet in t seconds. So while a 6-inch lead ball would fall over here, these two equations are according to the account of air resistance. So they're not going to fall at the same time. But now imagine you have two objects, doesn't matter which are the two objects, you drop them, say a feather, a light feather, okay, that's like a leaf, like a feather, and a ball, like a wooden metal, not a wooden metal ball. They both literally will fall at the same time if you leave them, at once. Why? Because the acceleration due to gravity acts at the same time. It's minus 9.8 meter per second square, right? For both. Now, this will happen only in a reserved experimental lab or something where there is no air. The air resistance is not there. Now, feather is very light, so the resistance of air is too high, whereas this one, it's less air resistance, so it will fall quicker in real world. But if you have an experiment done, they will both fall at the same time. That's what he's saying. But then he has taken into account the air resistance and then the equations are formed. So here they have given is where cosine hx is also given. What is the value? From a height of 179 feet, find the height of the wooden ball where the lead ball hits the ground. So now over here, what you can do is you can substitute this cosine h of this value and do it. But let me show you your calculators. Here, if you see this hyperbolic function, if you click on hyp, there is cosine h. That is hyperbolic. So we will just use these functions. If you want the inverse, there is inverse hyperbolic as well. So I'm just going to use this directly rather than substituting these as this, and it'll be much more complicated. Okay. Now here, let's understand this. Let me just draw a simple figure. Imagine the height of 179 feet. So from here, they're going to leave the balls. Let me take this as the wooden ball, and this, which is fully filled, is the lead ball. Now, when you're dropping this from this height, and this is the ground, imagine this is the ground. This is going to fall first. Okay, it should be a straight line, but this reaches the ground earlier than the wooden ball. Why? Because the air resistance higher, right? They already told it over here. From a height of 179 feet, 179 feet, find the height of the wooden ball when the lead ball hits the ground. That means the lead ball will touch the ground. But where will this be? I'm sure it'll be very close to hitting the ground, but not exactly hitting the ground. So we need to find this height. So first, what we can do is, I know if I substitute over here 179 in the lead ball equation, see, not this one, the lead ball, where is that? This equation, I can find the time at which it touches the ground. So the first step what I'll do over here is, instead of g of t, I'm going to take 179. Why? Because that is the height to touch the ground, isn't it? And this is equal to 12,800 natural logarithm of cosine h of 1 by 20 times t, and then close the bracket here. So now what I did is, I'm just substituting this height in this equation. And now when I solve for the time t, what do I get? I'll get the time at which the lead ball touches the ground. Here now we can take this to the other side and simplify. But before that, I'll show you we can use our calculators directly to get the answer as well. So here it is 179 equals, I'll just write this as equation 12,800 natural logarithm cosine hyperbolic, that is hyp2, and then we have 1 by 20, and t is what we require. See, we are going to use a calculator no matter what for hyperbolic. Alpha x, close the bracket twice, don't press equal to, you will get an error, press shift and solve, and then equal to. Here we go, the answer is, see, now here the answer is coming minus, but you need to take the time only as positive. But I did it in my physical calculator. You will take a long time. It takes about like 50 seconds to give you the answer, but you will get the correct answer itself, and it was positive. So that is the answer, 3.35. Now, even if you simplify it here, say You take this 12 to the other side and take exponent on both these sides. It'll be e to the power 179 by 12,800. That is equal to this. Why did I take 12,800? Simplified. Divide both and then exponent on both these sides. So this is dissolved. Ln is gone. We'll get cosine h of 1 by 120t. So let me type it out. E raised to the power 179 divided by 12,800. That is equal to, press next twice, and now equal to, cosine hyperbolic is hyperbolic, option 2. And this is, it's 1 by 20. My bad. I've written 120 here. It should be 20. And let me just, this is 1 by 20 times t. So here we have 1 by 20 times t, that is alpha x. Shift and solve, press equal to, here we go, that is 3.357. Now whichever form you do, it's fine. You can even stop over here and put in the calculator. It'll just take more time. Or you can also go ahead and take the cosine inverse of this. If you multiply cosine inverse hyperbolic, it'll be cosine inverse h of e to the power 179 by 12,800. That will be equal to 120 by t, and take 20 to the other side. That is equal to t. You can put it at once in the calculator. All this will lead you to the answer saying t is 3.35. Next, what do we do is, we found the time it will take for the lead ball to hit the ground. That is the time t for the lead ball. Now, where is the wooden ball at this particular time? We can't find it because they have told find the height of the wooden ball when the lead ball touches the ground, right? So I'll use this time t here in the first equation and find what is the height. This f of t is what I'll be solving for. It is 7225 divided by 8 ln cosine hyperbolic of 16 by 85 times 3.35. And here we go. We'll put that in the calculator and we will check what is happening. What is the height? So we will type this right side as it is. It's fractions. You can see up over here in the screen. 7225 divided by 8. Now natural logarithm is ln over here. Cosine is hyperbolic, option 2. We have 16 divided by 85 multiplied by 3.35 and close the bracket twice, and the answer is 168.78. Now please remember, use the exact values. Double check your values after you type it out, to make sure it's correct in your exams. So the height over here, f of t, is equal to 168 point, you can take it as its nearest, let's take 8 itself, only one decimal point. So this is the value because it'll be 0.79. It's almost equal to 168.8. That means, let's look over here. What was the total height? It's 179, isn't it? So this ball will reach up to nearly 169, nearly 10, you can say, 168.8 feet when the lead ball is already touching the ground. So what is the difference between these both? So 179 was the total height, but you are just reaching 168.8. So it's nearly 10.2 feet of difference. It's away by 10.2 feet. That is what you can say. You can just do over here 179 minus 168.8 and 10.2 feet. It still has to cover 10.2 feet in order to reach the ground. That is what it sees. Now you can see here it's not 10.2. Maybe the reason is they have taken all the 4 decimal values. I'll just show you. It's 3.3526. I mean, it's absolutely fine. If you get this value also, 68.8, and then you write 10.2 feet, that's absolutely fine. You're taking only 2 decimal points. If you're taken 4 decimal points, see here, 3.3526, then you would have got 169.03. That's absolutely fine. Don't worry about that. This is almost same value. Okay. Now the same thing, question B, if a theoretical production wanted to show the ball of part A landing on the same time, at the same time, how much earlier would the wooden ball need to be released? Okay, now this is interesting. Why? Because we are to use the same equations. They want both of them to be touching at the same time. So here, this ball also has to be touched at the same time, when both are touched at the same time. So what it means is we need to leave the wooden ball a bit earlier, right? What is the time? So here then, what we can do is we just have to find the time it takes. See, not this time, this is already there. The lead ball will take 3.35 seconds. We need to find what is the time wooden ball will take to reach down over here. Of course it'll be more than that. It should be about 3.4 something. I'm not sure how much it is. Maybe, still 10 feet is to be covered, so it's more than this for sure. So let's find this time. How can we find that time exactly? So where are the equations? Okay, both the equations over here, so we don't need to go back over there. So what I'm going to write is, let me find the time. This has t, provided the feet total distance is 179. See what it is? 179 is equal to 7225 divided by 8 ln over here cosine hyperbolic 16 by 8 phi times t. This time is required. Sorry, this t is inside, not outside. That'll make a different term altogether. It's multiplied by t, isn't it? Let me just go back. See here, it's within that bracket. It's cosine hyperbolic, all these terms. So this time I need to find for the wooden ball. Let me just put in the calculator and find it directly. Here then, 179 is equal to 7225 divided by 8. You have natural logarithm of cos hyperbolic, that is hyperbolic at option 2. And then we have 16 divided by, it should be 16 divided by 85 multiplied with the unknown variable x. Close the bracket twice. And now don't press equal to, that's error. Press shift and solve. Okay, not that as well. What did I press? Here we will have to, okay, 179, shift and solve, and then equal to, this gives us, it should be more than 3.35. Let's see what it is. If you're using it in your physical calculator, it takes about 50 seconds, guys. Okay, please wait. Now this is 3.45. I'm just going to take 2 decimal points because I stuck with 2 decimal points over here. Okay, this is the value. This is the time it takes over here. So what is the time this must be released before the lead ball? So, 3.45 minus 3.35 will give us 0.1, right? So 0.1 seconds. So if you leave the wooden ball 0.1 seconds earlier, then you must leave the lead ball. They both will reach at the same time. This is what it means. See, this is the time which is required. Why? Because we have to have ground touching. The both must touch at the same point. But we know from here to here, it takes 3.45 seconds. This one only 3.35. So if at all you allow this 0.1 second more, then it'll already cross 3 point, somewhere over here. So from there to there, it'll just take 3.35 seconds. So then both will reach at the same time in the ground, on the ground, sorry. So this is what it means. I hope this is clear. It is a lot of understanding what's happening to the balls and everything. So that's how we did that. And over here we can see it. Now again, why? What's the difference here? They have taken 4 decimal points. We have just taken 2. And it's almost same. It's 0.1, right? It's almost the same thing. Now, though this example problem is not mentioned in the EoT, the next problem, let me just go to the next EoT problem, requires this particular problem. So you can see this question, the answer is over here, but this one requires you to compare it with example 5.4. So what I'm going to do is I'm going to solve it over here itself. I'll solve the 5.4 and then let me go to the next one. So here they have given you angle theta, and the figure also was given. Let us look into the figure once so you'll get better understanding. Can you see this figure? So object is launched at that particular angle, and that is the velocity. The initial velocity is 98 meter per second. This is the angle pi by 6. Now what I would do is generally I convert this pi by 6 to degrees, but then make sure your calculator is in degree mode. Or if you're using radian, please always use radian itself. I'll show you both the methods, but what I do is I just convert this so it's easier for me to understand, analyze. Now this is having an angle, so you need to resolve it along the horizontal and the vertical components. So this is the original angle, but that'll have a horizontal force of V naught cosine theta and V naught sine theta. So we need to resolve them both components and then we will have to solve. Here it's not only the velocity along the vertical position, even the horizontal position will be considered. Let me solve it up over here. So what is pi by 6? How do we convert that to degrees? First thing, if you are converting it to degrees, it is 180 divided by 6 plus equal to, that's 30 degrees. Now I realize that you need to change to degree mode, but usually we always stick to the radian mode in these problems. So I'm going to use it as pi by 6 itself. It's fine. Okay. But you know it's 30 degrees. There's an inclination of 30 degrees. So first thing is the initial values. What is known? Given theta pi by 6 or it is equal to 30 degrees, just for your understanding, that's enough. And here V naught, that is equal to 98, it's meter per second. Let me just look into the, yes, it's meter per second. And then what do we know about the initial height? Is there any initial height? Now there is no initial height. Here they have mentioned it's horizontal, but we know acceleration due to gravity is always vertical. So we have to do vertical and horizontal components. So now here, vertical height, is it mentioned? That is y of 0, initial height, y of 0. There's nothing, it's 0. But what about the horizontal height? Is it mentioned? No, that is also 0. Because there's vertical, horizontal. Vertical is y, this horizontal is x. What about the velocities? We have to find the initial velocities, but it is not 98. I'll write it out over here. See, the vertical velocity will be equal to sine. Always the vertical, here you can write h, but y means it's vertical. Sorry, not h, it's v. Or y means vertical itself. Only for the first problem, I'm going to write this v. It'll be v naught sine theta. That is equal to, let me write it down over here, it's 98 sine theta is pi by 6, and I'll put it in the calculator and find it in a minute. But there is also x prime of 0. This is the horizontal. What is that? It is v naught cosine theta, and this is given as 98 cosine pi by 6. So here we go. We'll have to use our calculator and find the initial velocity in the vertical and horizontal sections. Here, make sure it's in radian mode, shift mode and 4. And now we will type in 38 sine pi by 6. Shift and this symbol here, pi, divided by 6. Close the bracket. The answer will be 49. So that is the vertical component. But we can just change this here for the horizontal component by cosine. The same thing, only change it. It is 49 root 3. So here, y prime of 0, that is the velocity in the vertical section, is 49 feet per second, and horizontal is 49 root 3. So now what do we have is all the given values. Now we can start. Here when we start, let's do two components, vertical and horizontal. So vertical component, you can directly start writing, but now for the first problem, I'm going to write vertical component and start solving. Here, since it's in meter per second, I'm going to use the acceleration y double prime of 0, not double prime of 0, it's of t, is equal to minus 32. So y prime of t will be equal to minus 32t. Again, I did a mistake. What is that? I should take minus 9.8. I saw it is in meter per second, but I took minus 32. That's for feet. Here, minus 9.8 t plus c. What is the c value here? What is the initial velocity along the y? It's 49. So I'll write over here directly 49. And then lastly, the position over here, that is minus, now, minus 9.8 t squared divided by 2, isn't it? What is 9.8 divided by 2? It is 4.9 t squared plus 49t plus c. What is the c value? The constant. Initial height is 0, so I'm not going to write anything. This is it. And here again, I did some blunders. Please make sure these silly mistakes are not done. Acceleration will have y double prime of t. That's minus 9.8. The velocity will be integration of the acceleration, it's minus 9.8 t, plus the constant along the vertical component is 49. The position is given as y of t, that is integration of the velocity, that will become minus 4.9 t squared. Here it will be t squared divided by 2. That gives us 9.8 divided by 2 is minus 4.9. 49 times t, because there's nothing. So if it is just a constant, you multiply the variable x, but in this case it's time t. And then what is the initial position or the initial height? It's 0. So I write plus c, that is 0, but I'm not going to write 0. 0 is nothing. So I'm just not going to write it. These are three vertical components. What about the horizontal components? I'm just going to write it over here. Horizontal components. For all these problems involving angle, this is required. See, now I have shortened the writing methods. You can keep on writing long things, substitute everything in detail. But as long as you've written this, you will get the marks, However you write it, these all will include marks. So x double prime of t. What is the acceleration along the horizontal? There's nothing, so it's 0. And then what happens is derivation of this will give you only constancy. There's integration of 0 is nothing but only c, it's just a constant of value. Because imagine there is any constant 3. When you derive this, answer is 0. You can have a constant 5, it'll be 0. So this is any constant. When you integrate 0, it's any constant, that is c, which is equal to, what is the derived over here constant? The initial value, it is 49 root 3. Integration of 0 is c, that is equal to over here 49 root 3. Now then, what is the position? X of t. That will be equal to 49 root 3 t plus c, but the horizontal and the vertical initial heights are 0, so I don't write that anymore. Now, we finished vertical, we finished horizontal. Now let's look into what is to be found out. Doesn't matter what problem, this much needs to be found out when we have an angle. Here they want the time of flight and the horizontal range. Now look at this position function in the vertical component I'm talking about. What is this? The parabola negative will be something like this. Now what exactly this means? If I launch this vertically, because it's moving up and down. Initially, when I launch it, what is the time? Or what is the over here, the variable t? It's 0. This position is 0 at 0 because you're starting over there. And it'll take some time on air and then it'll fall down over here. I don't know what is the time, but this y of t must be equal to 0, isn't it? The position, the height, this is the position, that's the height, isn't it? So that'll be 0. Why? Because when the height is 0, it touches the ground. So here, if I take y of t is equal to 0 and solve this up, that is minus 4.9 t squared plus 49t, what should I get? I'll get the 2 times when it touches the ground. One will be the initial position, one more will be when it reaches the ground after its time of flight. So that's how I can easily find the time of flight. Let's use mode phi 3 in the calculator and solve. Here, let's go to mode phi and option 3 for quadratic. Now we have x squared, that is t squared, x, but the constant is nothing, it's 0. So I'll type in minus 4.9, next one is 49, last one is 0. The values are t, 10 and 0. So of course it should be 0 at this point. What is this? It took 10 seconds. So t is equal to 0 and 10. Now the time of flight, therefore time of flight is 10 seconds. That's the answer. But we are not over. We need also to find the range, that is the horizontal distance of the projectile. How much distance did it cover? What is this distance that covered? What is that given by? X of t, isn't it? That's the horizontal distance. So here I know it took 10 seconds. So let me just substitute over here to find the x of t. X at t is equal to 10. Let's do 49 root 3 times 10. So this is the equation for the height or the horizontal range, And we know the time it took to, total time on air was 10 seconds. If you substitute over here 10, you'll get the total distance. You just put in the calculator. It'll be 490 root 3. The exact value will be, it's 490 root 3, or you can type in 49 root 3 times 10. It's 848.7. That must be the final answer. You can see the detailed method is also there. The final answer, here we go. The landing time was T, and that is the horizontal range, 848.7. So whatever I've written over here, right, this is very important time of flight, and I'll just write it out over here, 848.7. That's the horizontal range. Horizontal. You don't need to write a lot. This much, whatever is done, is more than enough, more than sufficient. Write the given, find the initial conditions, vertical component, horizontal component, and just solve it up. So that's how we did the 5.4 example. Now here, they have told the same situation again, but the angle here you can see is pi by 3. In the first problem, example 5.4, we had pi by 6. So it's the same thing. Now I don't need to, okay, I need to do it again. Why? Because this changes here. So I'll do this entire thing again. But what happens, instead of pi by 6, I should take pi by 3 because 98 is same. And then we'll compare to the previous one. Okay. So given, what's given here? Again, the given, most of it remains the same. Theta only changes to pi by 3. That is, see, pi by 3 is 60 degrees. That was 30 degrees. Then what about the initial velocity? It's the same, 98 meter per second. And then we have initial height, the vertical height. It's not given, 0. Horizontal height is also 0. I just write over here the velocity, initial velocity on the vertical axis. It is V naught sine theta. It is 98 sine pi by 3. I'm just going to write the answer directly, but in the exam, please make sure you solve it up. And over here, then the horizontal, that is V naught cosine theta. Here we go. It is 98 times, first I'll write sine for the vertical, pi shift and over here divided by 3 this time. Answer is 49 root 3. You can see the difference. Last time we had got 49 here. Now we have 49 root 3. The horizontal was 49 root 3. Now this will be 49. But let's double check as well. So if I change this to cosine, it'll be 49. So this is given. Now, what about the vertical component? I'm not going to write vertical component and all. I'm just going to directly start over here. This is with respect to t, that is minus 9.8. Y prime of t will be equal to minus 9.8 t. And what is the c value? That is plus 49 root 3. And the position over here with respect to t not 0 will be minus 4.9 t squared plus 49 root 3 plus 0. What about the horizontal? Here with respect to t will be 0. So we will start with the velocity with the constant value. It's c, the constant value is 49. And lastly, we get the position, that is 49t plus c, that is 0 again. Now then, what is the time of flight? We just make this y of t equal to 0. I've explained in the previous problem why do we make this 0. We'll directly make it 0 and solve for it. 4.9 t squared plus 49 root 3. We just put in the calculator. See here, I forgot to write one important thing. This will have t here, okay? Because if you don't write the coefficient and then you put in the calculator wrongly, your answer will be completely wrong. Here again, mode phi and then option 3. It's minus 4.9. Then we have 49 root 3. And then we have 0, 10 root 3 and 0. So now, of course, when you start, it will be 0. But what is the 10 root 3 value? It will be more than 10. It's 17. So we have two values. But let's take it as 10 root 3 itself. That will be the time of flight. What is the horizontal range? Now the time of flight, t will be 10 root 3. The x of t, the horizontal range would be just 49 multiplied by 10 root 3. That's 490 root 3 what is over here? Mode 1, 10 root 3 multiplied by 49. It's the same thing. Why? Because we also got 490 root 3 in the previous one, 848.7. Now, let's compare. What happened? The horizontal range is same, but the angle over here is pi by 3, over there it was pi by 6. If you see carefully, in the first attempt, okay, let's make it a little bit proper. Okay, here it was 30 degrees, so it went flat, shot, and fell down in 10 seconds, but it covered the same ground. Why? Because it was flatter. It went flatter. Now, for this problem, it's 60 degrees. That means it's more than 30. It goes up, up. But the end point is the same thing. It goes up like this and comes down. The distance is same, but you can see the time it takes is more. It's 17 seconds, 7 seconds more. Why? Because it's going more higher. So it covers same ground but more time, and then it falls up. So you're just going up with the more time and then fall. But if you put an angle of say 30 degrees, it goes quicker because it pierces through a smaller angle and takes the same amount of horizontal range. So the distance covered is same, but the angle plays an impact on the time it takes. So if you want the projectile to take more time on air, then it's better to have a bigger angle, so it'll go more up and then falls down. But if you want quicker time, then the angle must be low, and that's how we get it. So that is what we can compare and understand. So here is the answer. Now the next one, find the time of flight and horizontal range if it is launched at 30 degrees with initial speed. See, now 30 degrees we are done. Just now we did 60 degrees. We have to repeat this twice, but only change is the velocity. So guys, this is the same thing over and over. I'm sure you might be confident by now. You can try it by yourselves, but I'm going to solve it anyways. You can skip this and move ahead to the next problems now. So what happens? Let me just go back here to what we had written. All the given and everything is there. So what I'll do is I'll just edit this one here. Only change is V naught, because we have to do it for 30 and 60, right? I'm just going to do it for the 60 first. So this values will also change. Is that okay? How about I'll do it for both together? Now what I'll do is I'll do 30 degree and 60 degree together. So this will be for 30 degrees, and this side I'm going to do it for 60 degrees. So let's take calculators and find the initial velocities. So we have sine, that is velocity is 40 degrees. Let me write it out over here, 40 meter per second. I'm not going to write the same thing here. I'm just going to solve directly. But you need to have, very important, y prime of 0 and x prime of 0. Here also, y prime of 0 and x prime of 0. And this is given as, the y component is given as v naught sine theta, x is given as the horizontal component v naught cosine theta. So v naught is 40 times sine, that is over here 30 degrees. So now it's not 30 degrees. What should I take in terms of radian? That is pi by 6 and pi by 3. But since they have given in degrees, what I'm going to do is shift mode and 3. 4 is for radian, 3 is for degrees. Now look at the answer. Yes, this is correct. The initial velocity over here for 30 degrees is 20. And now I'm just going to change this to cosine. And the answer we get is 20 root 3. That is equal to 20 root 3. Now this one changes. It'll just swap. These two values will swap over here. But anyways, I'll show you. Now I'll change this to 60, and that is going to be 20. That's horizontal. See, cosine. This is 20, and this is going to be 20 root 3. See, over here, the y value will be the horizontal. That's the only swap. Let me show you. Sine 60 is 20 root 3. Next, these things will remain same. What changes is these particular values. So over here, I'm just going to change that constants. And here as well. It is minus 9.8. It's in meter per second. Then you add up the y naught, that will be 20. And then over here you have 20t plus c, because the initial values, the initial height is 0. And then over here again, we will do this in a minute. It'll be 20 itself, and this also changes. Now, what about the horizontal line? This one over here will be 20 root 3, and then what do we have is 20 root 3 times t. In the same meantime, I'm going to solve for the 60 degrees, okay? It's going to be, this is going to be the same thing, only the changes I'm going to write, because it's the same thing repeated. So y dash of t for 60 degrees would be minus 9.8 times t plus, what is the initial value over here? It's 20 root 3. So if you look over here, it was just 20. Over here, it's 20 root 3. Same thing here. Y of t, that is the position, will be minus 4.9 t squared plus 20 root 3 t. And no need of adding 0. It'll be, that's it. What about the horizontal? It'll be x prime of t, that is equal to 20, and x of t will be 20t. How do you find the horizontal range and the time of flight? For this, you need to do mode 5 and 3 and then solve it up. It'll be minus 4.9, and then we have 20, and lastly it's 0. And the answer is 4.08, and it must be 0. So the time over here, let me just change that, is 4.08. I'm not going to write 0 because 0 is the initial time to start with. Now the same thing here in the 60-degree problem. What do we have is minus 4.9 is same thing. It's 20 root 3. Close the bracket. And then 0. So it's 7.06 in this case. 7.069. I'll take it as 7.07 and then 0. So it is, time is 7.07. Now, how do you find the horizontal range? It'll be 20 root 3 times 4.08 in this case. Here it's going to be t is equal to 20 times 7.07. Now, any guesses? I'm sure by now you might have guessed both these horizontal ranges will be same, only the time will differ. Let's look at that. 20 root 3 times 4.08. That gives us 141.34. And let me do it over here as well. 20 times 7.07, it'll be the same thing. See, now 141.34 and 4, the reason is we are taking the decimal points. Not to worry, it's practically the same thing. Both have the same values of 141. I'll just take it as 4 for both. The horizontal range is 141.4. Now, what is happening? Here, imagine this is being launched at 30 degrees with this velocity. 30 degrees, it covers this much. The velocity is 40, same for both, but the angle is 30 degrees. So the time taken is only 4 seconds, and it covers a ground of 141. Here at 60 degrees, it goes up high, but it'll cover the same ground because the angle is more, it covers more ground, it goes more time in the air. So that is what we did, practically the same thing in the previous problem as well. I hope this is clear. We'll move to the next problem now. Next type of problem. And here we go, see the time over here. And if you do it again for the 60 degree, it'll be the same thing. Here we have a problem on tennis. Venus Williams, I'm sure you know the name if you know about tennis, has one of the fastest serves in women's tennis. Suppose that she hits the serve from a height of 10 feet at an initial speed of 120 miles per hour at an angle of 7 degrees below the horizontal. So here, she's hitting the ball 10 feet above the ground. So initial height is 10 feet. And then here the speed is given, the velocity, that is 120 miles per hour, and the angle, you can see it's going down. See, if this is the base, it's going downwards. So the angle is moving downwards. It'll be minus 7 degrees. This is very important. They have clearly mentioned below the horizontal will be minus. Above would have been plus. The serve is in if the ball clears 3 feet high net, that is 39 inches away, and hits the ground in front of the service line 60 inches away. Sorry, 60 feet. Now let me make this clear. 3 feet is given like this, whereas 3 inches will have 2 dashes over here. This is feet, this is inches. Now then determine whether the serve is in or out. It seems a little difficult, but let's solve it piece by piece. I'll come to these conditions in some time, but let me know what is the given. So I can see from here there is a lot of things given. The initial height, for example, y of 0, that is given. What is that? It is 10 feet here. It's 10. What about x0? The vertical, that is not there, it is 0 itself. Because we have to do the horizontal and the vertical. Why? The angle is involved, isn't it? So this is done. What about y prime of 0? That is, what is the initial velocity? Here we have been told 120 and angle is 7 degrees. So how do you convert miles per hour to, we are using feet, right? So feet per second, because we have 10 feet. Here, the conversion for miles per hour to feet is approximately 1.5. In the exams, generally they give this conversion, but the actual conversion is over here. Let me just show you. This is the actual conversion, 5280 by 3600. See, it almost corresponds to 1.5. It's not 1.5. It's about 1.46, I guess. Let me just show in calculator. So here, let me just put this 5280 divided by 3600, and we get 1.4667. Okay, so 1.467 is enough. So I'm just going to use this conversion factor, 1.467 times, what is the given value? It's 120. That will be 176.04. I'm just going to take 176 as a whole number. So this is the velocity. So I'll just write over here v naught is equal to 176 feet per second, ft per second. So that is in terms of feet per second. Now here then we have v naught, that is 176 multiplied by sine theta. Theta is minus 7 degree. Let's do it in the calculator. 176 times sine minus 7. Make sure it's in degrees. It is in degrees now. It's minus 24.45. Here we go, minus 21.45. What about x prime of 0? That is the velocity along the horizontal component. Now this will be just the same thing. Here instead of sine, we will have cosine. So here we go. It's 174.69. It's positive 174.69. So we have found the initial heights, we have found the initial velocity along the vertical and the horizontal. Now what else do we need? We will just start solving the horizontal and vertical components directly, and then I'll go to the cases. So horizontal component y double dash of t is equal to minus 32, that's feet per second. Y prime of t will be given as minus 32t plus c. But now here you can see y prime, the velocity, initial velocity is minus, so I'll write minus 21.45. And then we have the position y of t, that is equal to minus 16, because 32 divided by 16, 2 is 16. T squared, here will be t squared by 2, right? I'm just going to write the answers directly. 4, 5. And now don't forget, this is in terms of t plus 10. This is very important. Why? Because the initial height is given to you. This is the first equation. Now here this t, this is plus t. Okay, this is it. Now then we have to also do the horizontal position, right? Let me do it over here. X double dash of t is equal to 0. X prime of t will be equal to, here the velocity along the horizontal is 174.69, and lastly the position is given as 174.69 t, and we don't have any position or height along the horizontal, so it's 0. This is plus 0. It's not over. Now there are two cases. This is very important. The serve is in if the ball clears a 3 feet high net. So the first case, in order for the serve to be considered, case 1 is the height must be more than 3 feet, because if it's 3 feet or less, it'll touch this net and it'll fall down. It's not a proper serve. It's not considered to be a serve. Then here, this particular height, what is that? It is y prime of t. See this one. See, y prime of t, sorry, not y prime, the height is y. Only this y of t must be not equal, it must be greater than or equal. Even if it's equal, it's fine. But see, must be 3 inches. That means it's greater than or equal to 3, not inches, it's again feet. Must be greater than or equal to 3. Now everything is in feet, so I'm just going to write 3. That's fine. And what is one more condition? The height over here must be at this condition. What is it? At x of t, that is the horizontal distance, will be how much? 39. X of t is 39. So when you have 39 feet of distance, the horizontal distance, this one must be more than or equal to 3. Or you can write this first and second, or you can just write the sentence, the case one. Now let us solve. We know what x of t is 39. This we will do later. We have to find this, but we don't know what's the time, right? When it reaches 39, what will be the time? The ball will take how much time? We have to just solve this up. So here it will be 39 is equal to 174.69 t. Let's take this to the other side. Just divide both the sides by 174 and you'll get the answer. Here we go. I'll directly do it. 39 divided by 174.69. The time it takes is 0.223. So I'm just going to take 0.22. So the time is equal to 0.22 seconds. Okay, that is fine. We know only the time. Now we have to put it back over here and see what is the yt value. Y of t, that is at 0.22. That means it is minus 16 times 0.22 power 2 minus 21.45 times 0.22 plus 10. So let's put this in the calculator and see if the vertical distance is more than 3 or less than 3. So it'll be minus. See, what I'm going to do is rather than putting 0.22 many times, I'll write this equation as it is in terms of x. The t squared minus 21.45, again t, only t, sorry, not squared, plus 10. Calculate this at 0.22. What's the answer? It's 4.5. Yes, it's more than 3. So that is brilliant. We will write y of t is equal to 4.5, which is greater than 3 feet. Hence the condition case 1 is met. Yes, this is true. You can just write the ball crosses the net because it's more than 3 feet. Basically this same thing, you can just tell yes. Now there's one more case, and hits the ground in front of the service line. Look over here in this figure. This is the service line. It must fall inside. That means it must be less than 60 but more than 39. But we are mainly focused. We finished the first barrier. So now we are focused on where it is going to fall. So what we do is the case 2. I'm just going to write it. Case 2. Here, when it touches the ground, what happens when it touches the ground? This distance is 0. I mean the position, yeah, the height is basically 0, right? So we'll write y of t must be 0. That means it touches the ground. Okay, now what is the condition? At what happens here? See, now I should write this first. X of t must be less than or equal to 60, because if it's more than 60, that means it's outside. See, if it goes out than this, then that serve is not considered. It'll be a full. So it'll be out. So here at x of t must be less than or equal to 60. This is the second condition. Okay. So, or you can write x of t must be less than or equal to 60 at y of t. Anything, or you can just write the second sentence. Now, the first sentence clearly was the height at this particular time at x of t was 39. Say this is the distance, right? X of t. So when it was 39, what was it? Now we know it must touch the ground. So it will touch the ground. I don't know where, but I know when it touches the ground, y of t will be 0 because it's touching the ground. And that time the x of t must be less than 60. Let's find this out now. How can I find it? Here I know y of t will be 0, right? I'll just substitute it over there. So it'll be 0 is equal to minus 16t squared minus 21.45t plus 10. And let's put this in the calculator and solve. So here we have mode 5 and 3. It's minus 16. Then we have minus 21.45. And lastly, we have 10. And the answer is 0.366 or minus 1.7. I can't have negative time. So, of course, the answer will be zero point 0.3. I'll take it as 0.37. Okay, rounding off. T is equal to 0.37. You can write over here the negative time and then tell negative time cannot be possible, so we consider this value. Or you can just write one value, the positive answer only. Now, what is the distance? Let's see. X of 0.37 would be over here. We have this position function of the distance function horizontally 174.69 times 0.37. Now, if this is more than 60 feet, it's out. If this is within that, then yes, that's service proper. Let us check here. It is 174. It's 174.69 times 0.37, and oh, it's out. The serve is out because it's more, right? So it is 64.6. Let me write it. The answer is 64.6 feet, which is greater than 60. Therefore, you can tell the serve is beyond the service line. You know, the ball falls. You can write the ball falls beyond the service line, and hence, therefore, the three dots means therefore serve is out. That's the answer. We cannot tell this is the proper serve. Why? Because it fell out. This is how we solve it. See, I'll just recall quickly. We need to find all the given. We need to write the horizontal component, the vertical component, and then the two cases. Now, if both the conditions are met, then the serve was in. That's how we do it. And here the detailed method is also there. If you want, you can go through this later. And then we have the position, the acceleration, again of the horizontal. And then we use the cases, the first case and the second case. And here we go. First answer, the time. We substituted and found. Yes, the first case was true, but the second case did not hold good. So in conclusion, the serve is out because it's beyond the service line. Now we need to repeat the same example at initial angle of 6 degrees. Look here, the same thing. What changes is the initial angle of 6 degrees, and we need to do some trial and error method and find when the serve is end. This is going to take a long time. But anyways, we will do it. Now you can skip this part because I'm just going to repeat the previous problem with only some changes. So what's the first change? Here, this changes. Why? Because now I have a different angle. We had 6, that is, sorry, minus 7, now it will be minus 6. In the calculator, you need to write V naught. Now, see, the velocity is the same thing. So, what was the velocity we got? It was 176 over here. So, 176 times sine minus 6. It was minus 7 in the previous case. It was below the horizontal, but only the angle is changed over here. So now the value is minus 18.397 will be 4. Okay, and what about this? Over here we have from sine to cosine. It's 175. I'm just going to take 175. So let me go back here. It's 175. So what are the changes here? See, now I'm just going to change the color as well when I'm writing so you understand what's the changes. This is same. This changes. This is same. Oh, sorry, this changes. I mean, it's a small change. So here, let me write it out. The initial velocity is minus 18.4. That is the change. And here also 18.4. And here we will have 175, 175. It's the same thing like the previous one. Now, these are the two conditions. And the conditions are the same thing. That does not change, right? What changes is the values only, because the same problem they have told. And here as well, this will change time. I don't know what's the time, and I don't know what's the answer, but I don't even know whether it's true or false. Okay, let's do that in a minute. But what about over here? Again, this value changes in the mid, and this time will change, and then we need to find this as well. Okay, we need to find all this. Now I'm not sure whether it's out or in. So I'm just reusing the old problem. So I'm just saving a lot of time rather than writing it all again. So here, first thing, the height y of t must be greater than or equal to 3 when x of t is 39. So x of t is 39 equals 175t. And then we'll put this in the calculator and solve for the time. So 39 divided by 175 is equal to, okay, it's again the same thing, 0.22. I feel silly I erased all of that. But anyways, we didn't know that will be the same. Now here it's again 22, 0.22. But this value has changed, isn't it? That is now 18.4. So answer will change no matter what. This is 18.4. And now let's put this in the calculator and find out what is the value over here. Again, I'll write this equation first and then I'll just check by using the calc value. 16t square, or you can write over instead of x 0.22 square, it's fine, minus 18.4 alpha x plus 10. Now this is done. Calculate this at 0.22 itself. It's the same value. And over here we have 5.118. I'll just write 5.18. That is way above 3 inches. So it's 5.18. Now, I don't think it's going to be inside the service line. See, if you go back to the figure, let's just go back to this figure here. Where is that figure? It's way beyond. Okay, this is the one. Look here, we had just 4.5 and still it went out. See, when it was 3 over here, instead of 3 we had 4.5 and it went out. Now it is way above. It's 5.18. It's only 6 degrees, right? So it's going way above, and I'm sure it'll be more distance, way beyond the service line. So that you can just predict it over here just by that, so that's surely going to be beyond that. Now, which is the problem? It's the previous one. Yeah, this one. So now what we will do is we will just prove that same thing. Now I'll just take this off. Here, let's put this back. That is minus 18.4. Let's put y is equal to 0 and find the time here. So mod phi and 3 will give us this equation. We can solve this equation now. Minus 16 minus 18.4 and we have 10. Here we go, it's 0.4. So the time, t value, it's 0.4 seconds. When it touches the service line, it's 0.4. Now all we need to do is, instead of 0.37, we have to take 0.4 and solve it up. 0.4, that is x of t is 175 times 0.4. So of course this is going to be more than the last one, because last time it was 0.37. Here we have 175 times 0.4. The answer is 70. See, it was 64. Now it's 70 feet away. That's way away than the service, which is greater than 60. So no, serve is out basically. Or it's beyond the service line. Or you can just write serve is out. That is the answer. Here it didn't work with 6 degree. You can see this is what we did, and it's beyond the line. Okay, now they have done over here such that whichever you can input and do it. Now that is not required. They have not asked. They have found the t so that we can input different angles or times and then find it. Now what we can do is we can try, say for example, changing this. See, now they again asked over here trial and error, right? Find the largest angle. So what I'm going to do is, say I'm going to solve it for 10 degrees, okay? The same thing what I had over here. Instead of 6 degrees, I'm going to say 10 or 9, because I'm sure it's very, very close, So let me use 10 degrees and find. Here, this value is same, 176 sine. Instead of 9, instead of, how much was the previous, 6, I'm going to use minus 10. And let me change these values here. Now again, the values have changed. So only the the orange one, which I've just now changed, will be the change. So we can easily find it out. So these are the changes. Okay, here we go. It is minus 30.56. Now I'm assuming at 10 degrees. Because I feel, see, if you're going 6, it's wrong. We tried 8, that was wrong. I think so 9 might be, or 10 might be within the border. So let's try this. So we are 10, and then this is cosine. I'm not sure whether this is correct. I'm just assuming and going. If this is wrong, we will try with other values. 173.33. Now what we do over here is minus 30.56. 30.56, it's minus 30.56, and here we have 173.33, same thing, 173.33. Now first condition is here, that is having more than, at 39 what is the time? So 173.33, and let's do 39 divided by 173.33 is the same previous problem. All we are doing is we are changing a little bit. What are we changing exactly? The angle, that's it. So it's now I'm going to take the two decimal, it'll be 0.23. I hope this will work. And here now it'll be 0.23, and over here we have 30.56, 0.23. Now let's put that in the calculator, and it must work. I'm hoping it'll work. Minus 16 t squared minus 30.56, that's t, plus 10. I'll calculate it at, say, what is it, 0.23. And here we, oh god, no. See here, the first condition did not meet. Why? Because we got 2.12. That means the serve is not even, this angle is way too low, so it won't even touch the the net. It won't even go above the net. It'll just touch and fall down. So this serve is wrong. This is wrong. So what we'll do is, this doesn't work. So we'll take at 9 degree. I'm very very certain. I'm 100% sure it will work. I mean, it should work. So let's just try this out. Okay. So what I'm gonna do is just change this out again. I just want to get one correct angle, for this particular velocity. So here what we do is 176 times sine 9, that is minus 9, close the bracket. The answer is minus 27. Let me just erase all these what we are changing. So here we go. This also changes. All this is changed. So it's easy if you use a different color. I can erase it easily. And now we have everything what we need. So it's minus 27.53. And then over here, instead of sine, make it cosine. It is 173.83. Now that is 173.83 over here and over here. And also over here. And what happens over here, it is minus 27.53, same thing, minus 27.53. Here also it's 27 minus 27.53 and minus 27.53. So then what we will do is we will just see, now you can formulate a formula. Instead of changing all this, you can write these in terms of formula, and then we can directly get the answers and all. But now we have written the problem anyways. So here it will be 39 divided by 173.83. Let's look at the answer. It is 0.22 again. Okay, 0.22. Over here also it's 0.22 and 0.22. So now we will put this minus 16, that is minus 16x squared. And then we have minus 27.53. It's again x. And then lastly it is plus 10. And calculate this at 0.22. And here we go. The answer is yes. more than 3 point. It's I'll consider it to be 3.2. It's more than 3, right? Yes, this is correct. The serve is passing by the net. It's over the net. Now it's just over the net. That means now this is most likely going to work. Now let me solve this equation. Mode 5 and 3. It is minus 16, the first coefficient. Then we have 27.53 and it's minus over here. And lastly we have 10. And this gives us 0.3 because the other one will be minus. So let's take the first one, that is 0.31. So I'm just going to take 0.31 here and let us try. 0.31, that will be 173.83 times 0.31 mode 1. It's 173.83 times 0.31. And yes, it is within 60. So yes, this is a proper serve. Here you can see it is 53.89. It's 53.9. Imagine that's the feed, which is less than 60. It should be less than, right? Therefore, serve is in. So if she is using a velocity of 176 feet per second, then the angle must be 9 degrees and then the serve will be in. So this is the correct answer. It is 9 degrees below the horizontal, so it's basically minus 9. I hope this is clear. So finally we got answer. So that's the thing. Now they're asking to repeat the same problem again, but what is the difference? See, they're asking you to use 170 feet per second. So now this repeats again and again. There's nothing, not a big change. Only the thing is, the initial velocity changes. Uh, I'll do it anyways. I'll do one of this, but I'll not do the trial and errors because the trial and error. What we do is we just change the velocity a little bit here and there and we check whether it's correct or wrong. So here a lot of things change. This will change. All the values will change here. Why? Because this given question is not about degrees now, it is about velocity. And what is the angle to take? Angle we take is the initial one, not this, at 7 degree, what we had initially chosen, 7 degree, right? Because the example 5.5 used 7 degrees, but only the velocity will be changed now. Now, anyways, we will solve it. Let's use our calculators. So here the first thing is 170 multiplied by sine 7 degrees, that is minus 7, close the bracket. Here the initial velocity is minus 20.72, and then the vertical, sorry, this is the vertical, the horizontal will be cosine, deleted and cosine, and it's 168.73. Now then this is minus 32 over here, it will be minus 20.72, and same thing here, minus 20.72, and this one changes to 168 because the vertical velocity is given as 168.73, 168.73, 168.73. Now then the conditions are same. This is not going to change. This will be 39 equals 168.73. So let's just divide 39 by this horizontal velocity. 39 by 168.73 is equal to 0.23. So here we get t is equal to 0.23. So I'm just going to substitute over here. That's 2 and 3. Over here also 2 and 3. And this value changes completely, like it's 27 and 2 here. Okay. So now let's put that in the calculator and check. So here I'm going to use minus 16 t squared minus 20.72 t, that is alpha x, plus 10 calc at 0.23. What's the answer? Yes, the serve is high. That means it's gonna pass by. But I don't think so the height will matter because we had done a problem similar to what? 4.5 and the serve was out. So let's try this one. It is over here 4.4, you can say. This is true. But what happens in the next condition here, right? Again, this time, and this really is important, whether it's greater than, if it's greater than 60, then the serve is out. If it is less than 60, the serve is in. So let's try it now. Here we go. This is minus 620.72. So we use mode phi 3 in the calculator here. It's mode phi and 3. And then type in the coefficients. It's minus 16, minus 20.72, and lastly it is 10. It's 0.37, and the other one will be minus. So I'll just take minus 0.37 here. Sorry, it's positive 37. So 0.37 is multiplied with what? 168.72 times 73. 0. Yeah, it's 73, 0.37. Now let's check whether it is inside or outside one. Let's go back to mode, computation mode, mode 1. 168.73 multiplied by 0.37, or you can write 0.37. It is just beyond the service line by just 2 feet. So here you can see this is no, serve is out. So you can do some trial and error methods like how we did in the previous problems. Change this, say you can try with 160, then you can try with one. If it is way out again, then try it with 180, and then you'll get the answer. Now I feel if you see this problem, you can even do it by closing your eyes. You must be so thorough by it. You've done this so many times now. So that would be the thing. And over here, you can see at different velocities. They have chosen different velocities and found it out. Now we'll move to the next problem. Here, it's about a baseball pitcher. Again, you can see there's horizontal and vertical. Let's see what it is. A baseball pitcher releases the ball horizontally, only horizontally, from a height of 60 feet with an initial speed of 130 feet per second. Find the height of the ball when it reaches the home plate 60 feet away. Determine the time of flight x equation. Okay, and use y to determine. They're asking y is the height, x is the horizontal. That's fine. Now, what is given to us? See here, I just realized the height is it's not 6 feet. It's not 60 feet. This doesn't make sense. 60 feet is way too much. 10 times than 6 feet. A human being will be around 6 feet, so he's releasing the ball at 6 feet, not 60. Please make that correction. So here we have y of 0, that is the initial height is 6 feet. And what else? What is the initial velocity? See, they have told horizontal velocity. There is no inclination, there's no angle mentioned. So this entire thing is x dash of t only. So I'm going to take the initial. By the way, is there any initial velocity vertically? Y dash of 0. Not mentioned, it's 0 because it's only going horizontally. So x prime of 0 is 130 feet per second. And then this much is done. What we need to do is we need to find the height when the ball reaches 60 feet away. So this is the height. Okay, this is the distance, sorry. This is x of t given to us 60. We need to find at this particular distance. So that is the given conditions. Now then, as usual, we do vertical and horizontal. So vertical, it's y double prime of t is equal to 30 minus 32, and then v prime of t will be minus 32t. Now it's plus 0, so let me write it out properly. Now what happens with the velocity? It is not there, right? So it is minus 32 here. It's minus 32t plus 0. So I'm not going to write anything. The height over here will be minus 16t squared. Why? Because t squared by 2 will be 16, then 32 by 2 squared. Then plus 6 because we have been given here. At the same time, I'm going to do the horizontal as well. That is x double prime of t is equal to 0. But x prime of t is equal to 130. That's given in the question itself. And lastly, x of t will be equal to 130 times t. So this is almost the same thing repeated, only some values changed depending on what is given in the question. Now, you need to find this at what? At x of t is 60. So we'll find the time here at x of t is equal to 60. What is the time here? It will be 60 divided by 130. That is equal to the time we are looking for. Because we need to find what is the height at this particular time. That's it. So here 60 divided by 130, that is equal to 0.46. So the time is equal to 0.46. Oh, it's better to write it in terms of fraction. It's very simple, no need of calculated 6 by 13 because we'll get the exact value then, okay? Because it can be written in fractions here. So here now, we need to find the height, right? So minus 16, I'm going to write it as x squared plus 6. Calculate the x value to be 6 divided by 13. Now what is the answer? It is 2.59 or 2.6. The distance, the height will be 2.6. So here y of 6 by 13, that will be equal to minus 16 times 6 by 13 the whole square plus 6. So that is equal to 2.59 feet. So what they wanted was to find what is the height of the ball when it reaches, right? If the ball is thrown at this particular conditions straight away, the ball will of course bend down. Why? Because of gravity, because gravity is pulling it down, so it won't travel in a straight path, though it is thrown away so horizontally. Because of gravity it eventually comes down, okay? Though the release point is flat, there is no vertical component at all, it falls down eventually. So after 60 feet it's having only a height of 2.5 feet from the ground. So that is the answer. Now here it's the same thing what we have done. This is also here they have skipped some steps I believe, but whichever you're comfortable, just follow that. The next one is same like the previous one, only change is we have to use the initial speed of 80 feet. If you recall, the previous one was 130 feet per second. Here it is a speed of 80 feet per second. So let's solve this up. I'm just going to use the previous one over here. So what I'll do is I'll just change this up over here from 130 to 80. And let me just rewrite this all. Entire question remains the same. Here this is 80 now. It'll be 80 and 80. What about this one? This is the same thing. If you go back to the question, let's see over here. The question is the same thing. They want the home plate at 60 feet itself. So over here, what do we have to do? At same thing, at 60 feet, that is x of t. Now we'll solve it. It's 60 is equal to 80 times t. So the t will be equal to 6 by 8 or it's 3 by 4. You can just do it in the calculator. Now then here, this value changes, that is to 3 by 4. So let's see what is the answer here. It's 3/4. You can just put in the calculator and check the answer. So what I'll do is I'll use this equation itself first, and then I'm going to type in the value of t. So it's minus 16 t square plus 6. Calculated at 3/4, that is 0.75 or 3 by 4, and you get minus 3. So what does this answer say? It's negative 3 feet, right? Minus 3 feet. So you see that when the speed is slow, now imagine E3, let me go back to the figure and it's easier to explain here. See this, the ball was thrown over here, but the speed was low. This was the home plate. It don't when the home plate was at 60 and the speed was 130, we reached 2.69, that means 2.59. It came over here. But now since the speed is low, the gravity is pulling down and it's going to fall down somewhere over here and it's going to be down. So this means that minus 3 would mean it touched the ground even before reaching 60. So that speed is way too low. That is what it means. So carefully interpret the negative answer. That means here when he threw the ball at 80 feet per second, it was not able to reach the home plate at 60 feet. It touched the ground way before even reaching the home plate. That's what it means. So that's the answer. And here, yeah, that's what it says as well. So that minus is under the ground, but basically, you can't go under the ground. It touched the ground and that's it. It'll stop over there. Another problem. Again, a baseball throws a ball towards the first base, which is 120 feet away. The ball released from a height of 5 feet within the initial speed of 120 feet per second at an angle. So now the angle is given. There's no figure, but only thing is you will have velocities in the horizontal and vertical directions. You use that V naught sine theta. And they have told this 5 degrees above the horizontal. What does that mean? That means it's positive 5 degrees. Find the height of the ball when it reaches the first base. Just like the previous problem, only two extra values, that is, I'll show you here. First of all, what is y naught? They have told 5 feet, right? So it's 5 feet here. What about x naught? Is there any value here? There's nothing, so it is 0. And then what else do we have is initial speed, that is v naught is equal to 120 feet per second. Theta is 5 degree. This is positive 5. And we can find y prime of 0, that is v naught sine theta, and x prime of 0, that will be v naught cosine theta. I'm going to directly put in the calculator, but in the exam you can write the formula and then do it. So here V naught is 120, sine theta is 5 degrees, and the answer is 10.45. I write 46, two decimal points. Let's round it off over there. And then just change this from sine to cosine. And it's 119.54. 119.54. This is all in terms of feet per second. But it's the value that's very important, not the units. But you can write the units. Whenever we have position or height, its feet, velocity is feet per second, and acceleration is feet per second square. Now then, we'll do the horizontal components. Y double dash of t will be equal to minus 32. Why minus 32, not 9.8, is because it's in feet per second. Y prime of t will be equal to minus 32t plus, and write this 10.46. I'm not writing c and everything, I'm directly writing the answers, the equations here. It will be minus 16t squared plus 10.46t plus 5, because it's mentioned here it's at 5 feet. And then you leave this over here. What about the horizontal direction? This is 0. Velocity will be equal to, you're given 119.54, and lastly the position or the height, the distance you can say in this, will be 119.54 t. And what about the value for c? That's 0. And now what is the first base? At x of t is equal to 120. It's not t or this whole thing, it's not the t value, it's x of t is 120 feet. So it'll be 120 is equal to 119.54 t. We can just divide both the sides by 119.54 to get the time. Here it's 120 divided by, in the denominator, 119.54. And here we go. It is 1. I'm just, I think so. It's better to take 1.004. Okay. Even 1, it's fine, I believe. Let's just take this as, for now, time as 1.004, because I'm sure they'll take 4 decimals, right? So the value will be varying. Now here, this time, just put it over here, and that's the height. So let's put this over here. It'll be minus 16, that is minus 16x squared plus 10.46 x plus 5, and calculate this at, I'll calculate it at 1. It is minus 0.54. Let me calculate it at 1.004. See, it's way too different. I mean, it's 0. From 5, it's a big variation, right? So I'll take it as 0 minus 0.63 feet. So here, y of t, so y of t will be equal to minus, at t is equal to 1.004, it is minus 0.63 feet. So this is gonna happen. So when it reaches 120 feet away, it's gonna touch the ground before that. That's what it means. Minus means it's going inside the ground. That means it's touched the ground before reaching 120 feet. Here also they have taken this. See, it's minus 0.62 feet. But if I calculate it at 1, it's difference, nearly 0.1 difference. So This is the thing. But in the exam, if you have taken this answer as well, it's fine, because when we correct, we will look into different variations of the answers, 2 decimal point, 3 decimal point. So no worries. But it's better to stick with 4 decimal points. That'll be the most accurate. Okay. I remember during my engineering studies, we were told to set the values. If you go to mode, sorry, not mode, shift and mode, and then we do fix 6 and 4. Now all the values, see, when I do this division, 120 divided by 119.5, I remember for math and certain calculations we always took 4 decimal points. So this is the value we directly took. So we always assumed 4 decimal points whenever we calculated, and we took like this and then solved it up. So you can stick with this, or you can, if you don't want that, just clear your calculator. You can just take 3 or 4 decimal points. That's okay. Now this is again the same question. You can see the refer the question 23. The same values and everything. They just want a catchable height of 5 feet. Basically, what they want is the answer to be in terms of 5 feet. So you can do trial and error. There are various ways. You can just try, whichever the answer gives you, 5 feet, you can just stick to that. So that'll be, say, what is the answer? If you use an angle of 7.7 degrees, that is what you'll be getting. So you can try over here. See, now we used 5 degrees right at the beginning. Yeah, that was 5 degrees. So you can try 10 degrees. I'm sure that'll be way off. And then maybe middle of that 7.7 degrees will give you exactly this answer. So you can try the same thing by just varying this angle. Okay, just vary this angle and then try it. So we'll go to the last one, because the trial and error, we have done plenty of them. Same method. See what we have done over here. Just change this theta. If you change this to 7.7, you will get this. Or you can keep on changing to different values, and then you can, trial and error means try different values, isn't it? Then you will get the accurate answer. Here we have a daredevil that plans to jump over 25 cars. If the cars are all compact cars with the width of 5 feet and the ramp angle is 30 degrees, determine the initial velocity required to complete the jump successfully. Okay. Repeat the takeoff at an angle of 45 degrees. So now initially the ramp angle, see, now when you're jumping, now so what is happening is he's jumping here, like this. The ramp is going, so he'll drive from here, then he'll jump the cars, and then he'll fall. So over here there are about 25 cars lined up, so he has to reach over here. So what is the velocity requires at 30 degrees? So that is what we want. Okay. And then after this, what if the angle was 45 degrees and he's going way too high, right? So what is how to satisfy this condition? And then over here they have told, in spite of the initial velocity, reduced initial velocity requirement, why might the daredevil prefer an angle of 30 degree to 45 degree? So now they are asking to do for 30 degrees, this is over here, and 45 degrees. The velocity required at 45 degrees is less, but why will he choose 30 degrees rather than 45 degrees? It's a bit, common sense, right? Why? Because see, 45 degrees is way too steep and it's dangerous. You'll have more flight time, you'll go more higher because of the angle, and it's more riskier, because in reality, because of all the air resistance and various other things, you tend to crash when it's a bigger angle, rather than if it's a 30-degree angle, it would be more smoother. Though the velocity is more, it'll be a more smoother and more safer jump. That's the reason for this 35 rather than 45. But now we will solve which velocity we have to do. Okay. So what are the initial things? Now first thing is, we have been told the horizontal distance 25 cars and width is 5 feet. So that is x of t will be 25 times 5. That is 50, 100, 125, right? 125 feet. Okay, that's x of t. We know theta is 30. Before that, okay, let's write the v naught is not known. This is what we have to find, but theta is given as 30 degrees. So what will be the horizontal, this velocity, initial velocity, y dash of 0? What is this? It is v naught sine theta, right? So we have to find that. And then what about the horizontal one? X prime of 0 is V naught cosine theta. So here theta is 30 degrees. Let's substitute, but V naught we do not know. We'll write it as it is. Let's write the constant V naught as just V naught, but we'll find what is sine theta and cosine theta. Here we will just put sine 30, that is root 3 by 2. Okay, what I'll do is I'll also do 45 degree now itself, because I know we have to do it for 45 degrees as well later. And this will be sine now. Okay, I wrote wrong. Cosine is this below 1. Let me put the sine and then change it up. It's half. So here it is 1 by 2, and this is root 3 divided by 2. This is at 30 degrees. So let me do it at 45 degrees as well. So what's going to happen? This is the next part. They have told two times, right? The same problem two times for different angles. So here it's going to be 45 degrees. That's a root 2 and 2. And 45 degrees is the same thing. Y naught of 0 will be V naught. See, this is multiplied by V naught, both. Only sine theta we know. V naught root 2 by 2. And then we can write it. And X prime of 0 is also equal to root 2 by 2 V naught. They are same things. Because 45 degree, it will be the same. Cosine and sine are equal. Here we go. Then what is the, okay, I did not do y of 0. What I mean is, what is the initial height? Y of 0. So that is whatever is the ramp height and the, okay, over here there's ramp and the cars. So we'll take it as h, okay? Let's just take it as h. And then let us take x of 0. This is 0 because they have no horizontal distance. Initial horizontal distance is not given. They've just given the total distance. So now let's start solving it up. What do we have to do? Y double dash of t is equal to minus 32, because it's in feet, isn't it? They have told clearly it's 5 feet. This answer we have is in feet. Y prime of t will be equal to minus 32t plus the constant. What is the constant here? The first one, half v naught. I'll just write v naught by 2. And now the position will be minus 32. It's not minus 30, it will be minus 16 t squared plus v naught by 2t. And what is the initial height? That's h. I'll write plus h. Same thing, I'll do it for x, the horizontal direction. It's gonna be 0. X prime of t is gonna be this value here, root 3 by 2 times t. And sorry, it's not t, this is v naught. I don't know why I wrote that. Now in the position, that's the height, which is, again, I'm doing many blunders now, maybe just very tired. It's a long video, continuously recorded. It's x of t, that is equal to square root 3 by 2 v naught times t plus 0, because the initial height is 0. I mean the horizontal distance is 0 initially. Now we got these two. Okay, what do we have to find? We have to find this distance at 125. We have to find at, because when he reaches over there, right, when he reaches the jump over here, the end point is 125. He must pass 125. So over here what I'm going to do is 125 is equal to square root 3 by 2 v naught times t. So I can easily find what is t. What we do is we'll take this to the other side and v naught also to the other side. So time t is equal to 2 times 125 is 250 divided by square root 3, that goes down, and divided by v naught. This is the time. Now we need to find the distance, the y of t at this time. So here what I have to do is I have to put this as t, and then we have to simplify it. So I'll show you. I'll just write this entire thing here. Let me just change the color so you understand. This one now I've written over here. It's y with respect to the time 250 by square root 3 and v naught. That will be equal to what? It'll be equal to minus 16 times 250 divided by square root 3 v naught the whole square. No, v naught then the whole square. Sorry, this is just v naught. There's no square over here. That is the first part. Then plus V naught divided by 2, and then we have 250 by square root 3 V naught, and lastly plus H. Now here there is one very important thing. Uh, you can see this H is there, right? And this, what is that distance? So look here, this is the ramp, and he jumps like this and he touches down over here. So here it starts and it touches over here. Whatever is the height, this much. The initial height, that H, I don't know that where is the ramp situated, right? Because there are cars. So the car height, wherever the car is there, that from there he is jumping. We have to assume that he's jumping from there. So here, that is not exactly zero. Even if you consider zero, it's fine. If I consider it to be H, this is the distance. When he reaches, that will be the same distance. So basically, this value and this value are same. Or you can consider it to be the base itself, that is the zero value, the ground level. So that will be 0 and this will touch the ground. We want from here to wherever, whatever is the H value there itself. So this and this goes off, or you can consider them both to be 0. That's fine, considering that to be the base. So now here what we have is, we'll move this to the other side. This is 0, so minus will become plus here, 16. Now what I'm gonna, it's all multiplied and divided. So it is 250 squared by square root 3 square is 3 multiplied by V naught square. That is equal to, over here this V naught and V naught cancels off. So you have 250 divided by 2 root 3. You just put that in the calculator. Like, you can take this to the other side or just put it as it is. You will get the answer. So what I'll do is, you can put this first equation. I'm just going to put the second one because I've already written it 16. We are taking this minus to the other side. It becomes plus. Don't think it goes to the numerator denominator. Plus first, whatever is minus becomes plus. So it's the same position. Numerator is numerator, denominator in the denominator itself. You can write 250 squared divided by, you can write square root 3 squared. That's just 3 times velocity is what we are solving for. This is squared. That will be equal to what? It'll be equal to 250 divided by 2 root 3. And then you can't press equal to, it will be a math error. You need to shift and solve and then press equal to. The answer is here. So you can see the answer is, okay, this is the correct answer. X value 67.9. It's 68. I'll just take it as 68. So the initial velocity over here will be 68 feet per second. If you have initial velocity of 68, then it's a 30-degree ramp. He will successfully jump. His car will go through all the cars and he will reach safely. Now we will repeat the same thing for 45 degrees. We have these initial values, so I'm just going to change a few things here. That is this one. These coefficients will change, and even over here this will change, and that's in turn going to change the value. And this also will completely change. Whatever is taken over here, right, that's going to change. So we will look at it now. We'll just solve it up. And they have told here the reduced velocity, initial velocity. So the velocity must reduce. So we got 68, right? Whatever the answer we get now must be less than that. It might be 65 or 60. I'm not sure. We'll solve that now. So here what we do is use these two values which we found a while ago. And y double dash will be same thing. Over here we'll write root 2 by 2, that is v naught. And then we will write over here root 2 by 2 v naught times t plus h. And what about this? It's again root 2 by 2 itself, v naught and root 2 by 2. And this is 125. And we have over here square root 2 by 2. Now this goes to the other side. So it'll be 2 time will be 250 times 2 divided by square root 2. So this is the answer. And then v naught also down over here. That will be the time. This is time t. So here in this particular equation, we put 250 divided by square root 2 v naught. Same thing here, 250 by square root 2 v naught. And what is the coefficient over here? It's root 2 by 2 v naught already. And then we have 250 here, square root 2 v naught. This v naught and this v naught cancels. H and h cancels. So you will have positive 16 I'm just gonna write. You can write it like this itself. It's fine. You can put it in the calculator as it is. It's absolutely fine. The whole square is equal to square root 2 by 2. And here we have 250 by square root 2. Now this can be cancelled off, square root 2 and 2. So it'll be 250 by 2 itself. And let's close the brackets. Now just put this in the calculator. Please refer to the screen for the details over here. It's a little crumbed up. Now we have, what we have to do is 16, that is 16 multiplied by 250. So you can see the values are over here. 16 times 250 divided by square root 2 multiplied by, that's the term we need, alpha x. You don't need to put multiply, you can put alpha x directly as well. Close the bracket and square it up. That is equal to what? It is equal to, see this root 2 cancels. You can just write 125, but I'm just going to write, yeah, 125 is fine. Shift and solve. The answer is 63.24. Why 125? Root 2 cancels, 250 by 2. Or you put this entire term, the answer will be same. So yes, it's correct. It's lesser than 68, right? 63.24 is the velocity. V naught is 63.24 feet per second. So now this is the velocity that is for 45 degrees. But in spite it is lower velocity, the risk involved is way too much high when it's 45 degrees because you're more steeper. So you go more time on the air and it is more riskier in real world. So a 30-degree slope is much safer, and the daredevil who is attempting this jump will use a 30-degree slope rather than that. But he has to go at a initial velocity of 68 feet per second. That is what we found. So here we go. That's the answers. The first one was 68, that was for 30 degrees. And then we repeat it and we find that it'll be 63.24.
Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will use integration by parts formula to compute integrals. Here we are being asked to integrate cosine inverse x. Now, if you recall, we have the derivation for cosine inverse x, which is minus 1 by square root 1 minus x squared. But we do not have a direct formula for integral of cosine inverse x. Now we need to do this by integration by parts. You might have come across this formula I equals, that's integration by parts formula. You need to rearrange this term cosine inverse dx as u and dv. Now this is v and this is u. The formula is given as u and v, uv minus integral v and du. If you're asking why do we use u and v, you can use any other thing, m and n, a, b. But generally in formula, in the textbooks, the formula is given as u and v. Now then, which do we assume it as u and which is dv? This is very crucial. The simple thing is whichever can be easily derived is u, because over here we are going to derive du with respect to dx. Okay, this is derived. Now here this will be integrated. So integration happens to this term and we will get v. So what can I take here? Can I take x? No, it's cos inverse x. It's a single term. Should I take cos inverse x? Let me see over here. Is it better to integrate it? No, not possible because we do not know how to integrate cos inverse x. So here cos inverse has a derivative, so we have to take it as u itself, cos inverse x. And what about dv? What is remaining? Only dx, isn't it? That is nothing. That's 1 dx. So this is what's remaining. So I'll write again dv, integrate both the sides, and what do you get? Integration of dv will be v only, and integration of dx is x. And what about this? Du by dx is 1 minus 1 divided by square root 1 minus x squared. Now here, du by dx, right? Let's take this dx to the other side because u terms, what exactly is du? That's what we want, right? We have to substitute entirely the substitutions in this formula. It's not u substitution. We are not putting it back over here. It's not possible. We are putting it over here. So
du will be equal to minus 1 by square root 1 minus x squared dx. Now, henceforth, now this is the first problem, so I'm writing in detail, but you can skip certain steps. Instead of writing du by dx and then moving dx, you can directly derive this. Instead of u will be just du. Cos inverse is minus 1 by square root 1 minus x squared, and directly write dx because you're doing it implicitly. Du is separate and dx is separate. Or if you want to think this is with respect to x, it'll be du by dx, and then we are just moving it. It's fine. Anyway, it's the same thing you're getting. Now integrating dv, you'll just get v over here x. So this is how it is. Now what next? Look at this formula. Let me substitute. I'll write I is equal to, now what is the first term u? U is cosine inverse x. What is v multiplied with? V is x minus integral. What is v again? X times what is du? Du is here, that is minus, I'll write a bracket, minus 1 divided by square root 1 minus x squared. Close the bracket, and then we have dx. It's all with respect to x now. So let us try solving this here. So here, now if you look carefully, what is happening? This minus sign can be removed out. This side, left side, it's done. X cos inverse x is done plus integral. This x can be multiplied up over here. What happens is you will get x divided by square root 1 minus x squared dx. Now, do we have any formula directly to solve this? No. But there is something called U substitution method. What is U substitution method? There is a relationship here. See, I know if I take whatever is inside this square root as U, then I can simplify. Otherwise, it's a very complicated term. Like integrating of 1 divided by square root. No way, that's not possible. Okay? So now what we do is this much is done. Still there's a continuation here. Only this part now. I just change the color. Now this part is what I'm solving for. Here I will be doing u substitution, which is the complicated term. Inside the square root, if I have u, it's easy to solve. So I'll just do 1 minus x squared is equal to, u is equal to 1 minus x squared. Okay. So what is du? What I do is I'll derive this. Du is equal to 1 is 0 minus 2x, and with respect to x will be dx. Implicitly I'm deriving both the sides. Now then, what is known here? Dx. See, I'm entirely going to change this in terms of u and v and then solve it up and then put it back, whatever I have assumed. So what I'm going to do is, here, let me keep dx at one side and everything else to the other side. So it's going to be du divided by minus 2x is equal to dx. So I know this inside the square root term is going to be u, and then dx is going to be so much. Let me substitute. Now I'm just going to do it over here. So it'll be integral x, write it as it is, divided by square root u. Why? Because I've assumed it to be u. And then I have dx as du divided by minus 2x. Now here this x and x can cancel off, and I'm having minus 2 in the denominator. So I'll remove it out. Negative half is out. Integral 1 by square root u du. Now, what is this? This is 1 by u to the power half. You can use power rule here. So minus 1 by 2. Take this up. Now see, it's all changed to with respect to u. So we can solve this normally, okay? So over here it's going to be 1. It is going to be u to the power minus half. I'm directly writing because 1 divided by u power half. When you bring it to the numerator, the sign changes in the power. This is actually 1 by u power half. Bring the denominator up, the power becomes negative. And now let's use the power rule. So what happens when you use the power rule? Minus half, it's outside. It's going to be u power half. That is negative half plus 1, right? Negative half plus 1 is positive half. So I'm writing plus 1 and divided by half. Now see, this half is in the numerator outside. This is down. This can cancel, or you can just write this as 2u because this 2 comes up in the numerator, right? Or you can just put it in the calculator, minus half into 1 divided by 1 by 2. This and this cancels. Now I'm going to write plus c at the end. Now I'm just not going to complicate it. It's going to be minus u to the power half. So this is the thing. What was u initially? What did we assume u to be? U was 1 minus x squared, isn't it? So that is what we will substitute back. This is equal to minus square root. Half, power half is basically a square root, isn't it? 1 minus x squared. So this is what we get. So now we will have to see, this is a detour from the this part because we can't continue further. We have an integration over here, and that's, not simple integration. We have to do this, and now we will put this solution back here. So this term, whatever. Okay, let me change the color again. What I'll do is this one. Now the entire thing, what is there, I'll continue out over here. That is going to be x cosine inverse x plus, but it's minus here, isn't it? Why? Because we got minus. So I'm just going to plus into minus. It'll be minus square root 1 minus x squared. Now plus c, after the entire integration is done, we can just write this plus c. So now this is the final answer. What happened? We did u substitute, sorry, not u, it is integration by parts, u and v, u and dv basically. We got them, and then we got what is u, du, dv was already assumed, and then we got v. We substituted in this formula, and then we got this. But when we tried solving here again, we got stuck because it became another complicated integral. So it's like a problem within problem. But this problem doesn't require integration by parts. All it requires is u substitution method. Because it looks a little complicated, just assume this to be u and then automatically see here. 1 is power 2. This will cancel off because whenever you derive this, because when you do u substitution, you derive it, you will get x. So that will go off. So that's where you can easily take this u substitution and simplify the right term, the integral only. We did it. See over here, whichever is mentioned in black, that is the thing. And that answer was minus square root 1 minus x squared. So then, now it's better you write it in order like up to down as you can go. Now this must be substituted back over here. And then we got the final answer, x cosine inverse x minus square root 1 minus x squared plus c. So this is how you need to write it out. You can see the final answer is, yes, it should be that. Let's just double, yeah, that's correct. Yeah, x cos inverse. Yes, that is what we have got. I hope this is clear. Now you can double check your answer using calculator. Once you did the correct answer, you can check it. How do you check it is very simple. You need a calculator. Here, first you need to check whether this is in radian mode. It's already, but if not, it is shift mode and 4. Now it's in radian mode. Now what I'll do is, you can choose anything first. But let me try this cosine inverse because cosine inverse has a restricted domain. Let's take shift cosine alpha x. And let me try 2 because usually I take 2. It doesn't work because it's not within the domain. If you take 0.5, it will work, anything less than 1. So here you get 1.047. So whenever you have cos inverse functions like this, the domain is restricted at times. Even if it's a square root, and certain times we can't take any negative numbers, right? Similarly, here the domain, so whenever you see cosine inverse and all, if try 2, like take 2 first and check it's a math error. If you take 0. Let me go here, 0.75, sorry, it's not over here, calc, and then let me type this. You're getting an answer because it's within the domain. Anything minus 1 to 1, it's fine because the range of cos function, it's minus 1 to 1. You can even take negative numbers, but just take positive numbers. I'm just going to take 0.5 here. Whenever it comes to inverse function, I just take my 0.5. I got 1 by 3 or 1.0471. Now let me derive this answer. Only one correct answer which you solve. That must be correct. Now, if it is not, you will not get the same answer. Let's check this. X cosine inverse, again x, close the bracket, minus, I have not opened any bracket, only the original default bracket is there and it's closed. Cosine open and close, done. Square root 1 minus x squared here. Plus c, I'm not going to write. Why? Because it's a constant. See now, if I press 2, it's a math error. No, it's not going to work. Why? Because I assumed 0.5 here and it should be 1.047. Yes, absolutely, because this is the correct answer. That's how we check using calculator as well. Now I can be 100% sure this is correct. You can't directly do without the answer. So, if you did something wrong and you're getting a wrong value over here, that means you have done some mistake. So you can just go through the problem again. Now, moving to the next problem, tan inverse. Again, let's write the formula. I is equal to u dv. That will be equal to, sorry, it's not integral. It's uv minus integral v du. That's it. Now, what next? This is tan inverse x. Can I take it as integral as dv? No, you should derive this. U is tan inverse x. dv will be the remaining. What is remaining? It's only dx. So here it's going to be du, that is equal to 1 by 1 plus x squared dx. And here it's going to be v is equal to x, not dx. It's just x. Let's substitute in the formula. What is u term? U is tan inverse x. And what is v? V is x itself. Integral minus integral. What is v here? Again x. And what is du? It is 1 by 1 plus x squared. And then dx. So here again you can do u substitution, or if you recall the logarithmic rule. See, now I think so that will be a bit complicated. There are other tricks also, but if you want to go like a standard method, I'll just do u substitution, because in the first method I used u substitution. I won't do any other tricks. So I'm just following a uniform method, okay? So what this much is done. Let me just focus on the right side. Let me write it again. It is x tan inverse x minus x by 1 plus x squared dx. See, there are tricks. Directly, I can tell the answer is ln 1 plus half. It'll be, half will be there. 1 plus ln 1 plus x squared. But I'm not going to do those tricks because it's too many things to remember, right? So what we will do, this much is fine, but we cannot proceed further here. So what I'm going to do is I'm going to do u substitution only for this part. Now u substitution over here would be u is equal to 1 plus x squared. And over here we will have du is equal to 2x into dx. Now this, take it to the other side. It'll be du by 2x is equal to dx. Now only this part I'm going to solve. It is going to be x by u into du by 2x cancels off. You have integral of u, that is, take it to the up. It'll be u power minus 1 du. Outside comes half, because this is the denominator, right? It'll be half over here. Now what next? Oh, sorry. Can I take this 1 minus 1? My bad. Here it is not minus 1, guys. It is 1 by u itself, because integral of 1 by u is ln u. Okay? Don't know what I just did. It's 1 by 2 over here. And now we will write half natural logarithm modulus u plus c. But I'm going to write plus c at the end, okay? Because there will be lots of constants over here when we derive over here. So we'll write it together at the end. So that is half ln c. Now we will put this back here. See, this goes back up over here. So we will continue from where we left off over here, right? I'll just continue over here. It'll be x tan inverse x minus half ln modulus u. Okay, so this is it. So this will be the answer. Now, okay, I forgot to write a very important thing. What was u over here? U was 1 plus x squared. So this is what you need to substitute back. Here it will be 1 plus x squared, not u with respect to x. This plus c. So this is the final answer. I hope you're clear with it. This is the method. First, you need to do what is u and dv. Once you get that, put it in the formula. And once you put in the formula, simplify how much you can. And then if you're stuck, you need to do u substitution. Do the u substitution over here, which you're done. And then put that answer back. This is how we can solve it up. Now we will see the next problem. I'll be solving all the problems. If you're thorough with this, you can just skip ahead and go to the next problems by yourselves. Now this is a different type. Now if you understand this problem, you can try all the remaining problems by yourselves. So 43rd one is sine square root x dx. Now, how can you solve it? Because I cannot directly use integration by parts. I is equal to u dv, integral of u dv is equal to u minus v, so uv minus, let me just write it properly, uv minus v du. This is the formula, and this is integrated, the second part. I cannot take anything as u, because if I take this as u, it's just going to be a complex term. You need to derive it again and again. It's going to be a little bit complex when you look at this. Okay, why? Because it's going to be chain rule and integral will be 1. But if you integrate this, then it's going to be again very complex. So what I'm going to do is I'm just going to rearrange this and simplify this further. And that is done by the substitution method. That is u substitution. But here, since we are using u, I'm not going to write u. You can write any other letter. Some write it as t, some write it as w, which is very, very close to u. Or you can write it as a, b, or anything. So now here, because of my handwriting, W, U, it'll be looking similar. I'm just going to use A. Now let me show you what I mean. I will assume this square root x as A. What happens? It'll be sine A. Sine A is something easy we can work with, right? With respect to A, that will be, okay? Then we will get everything back to normal terms. We will now just assume this for a minute. But I have square root x. Now what I need to do is, let me square this up, because I need to, if I change this square root x as a, I need to even change dx. I need to write it in terms of dA. So that means I need to derive this, isn't it? So what I'll do is, rather than complicating it over here, I will square this up. It'll be this whole square. So it'll be x is equal to a square. Okay. Now if I derive this, it'll be dx is equal to 2a into dA. Now it's easier, right? Now I know what is dx. I can write it in terms of a, and then sine a it becomes over here. So this question, what we did was, we just rearrange this entirely into sine a multiplied by dx becomes 2a with respect to dA. Now we can write this 2 constant out. I'm just going to remove that 2 outside. That's out of the picture. A sine A dA. This is what we are to work with. We have to solve this now. You might see, in the textbook, W is written. It's fine. You can write anything, but just remember this is a variable, just a variable, another variable. So everything is converted with respect to A now. Now can we use u substitution? Absolutely, because sine A is simple to solve. It's easy to integrate. A is there. Yes, we can easily derive this. And this can be integrated. So here I will do u, I'll choose u and dv value. So what I'm going to do is u is equal to A, because it will be simpler. And dv is equal to sine A dA. Another thing is, you might be thinking, why didn't I just assume this to be u itself? Square root x is equal to u and u squared. Then again there is u, right? And you might be confused further. So that's why I avoided and used a different term. Now here when you're choosing, don't choose sine A as u, because you can derive it. Yes, of course, you can even integrate A. But when you integrate A, it will be a squared by 2. It gets more complicated. So your goal is to simplify both the terms. Now when I derive this du is equal to, it will be dA. And what is the integration of this? It will be v is equal to minus cosine A d, it's done. dA is gone, because you're integrating on both the sides. Now then I will substitute in the formula. The formula is u. What is the u term? A multiplied by what is v? Minus cosine A minus integral of what is v? V is again minus cosine A. And what is du? It is dA. So here I will write a little further. Minus sign outside, it's minus A cosine A. And what is minus and minus? Will be plus integral of cosine A. dA. Now it is minus A cosine A. Integration of cosine A dA will be, it's like cosine x dx, okay? Integration of that will be sine. So it is plus sine A. It's plus C. Now it's not over. It's almost done. But don't forget. Okay, I forgot two things. I just forgot completely. This 2 exists. Guys, yes, we are using the formula, but remember to apply this 2 here. So this was all multiplied by 2 because 2 was outside. That's absolutely fine, okay? This was 2. Now here as well, there was a term 2 outside, okay? This 2 was outside here. And here as well. See, now you can write plus 2c as well if you want, but then ultimately it's a constant sum. So you can just ignore that. I'm just going to write 2 here. Now what I'm going to do is I'll multiply this 2 inside. So it'll be minus 2a cosine a plus 2 sine a plus c. It's not over yet. Why? See, it's almost done. This 2 is taken care of. Everything is done. But we need to put back what was a. So here a is assumed to be square root x. So the answer will be minus 2 square root x cosine square root x plus 2 sine square root x plus c. So this must be the final answer. There's nothing else. We please guys don't forget this too. Uh, I remember before as well many students tending to forget this. They take this two out, yes, over here when they solve it, and they just completely forget it. They solve over here without this two. It's almost correct, but you're missing a multiple. Sometimes this number can be 3 or half. Please remember this. Don't do that mistake in exam. What I did was it's good that I did that mistake, so you don't do it in the exam. So that is the final answer. You can see here they have written 2 outside itself. That's also absolutely fine. Just like this, they have substituted back over here. However you write, you're right. It's a writing exam. However you write, whichever form, it's fine. Now, what about this one? Again, we need to simplify this. You have to do U substitution first, and then, now I'll call it as A substitution. So I'll consider square root x is equal to A. And now to make this easier, because I need dx, I need to derive it. Look, I can derive this as well. It'll be 1 by 2 root x into dx. It's just getting more and more complicated, right? So better way would be I'll square both the sides. It'll be x is equal to a square, dx is equal to 2a times dA. This is much simpler. And now here this becomes integral of e to the power a 2a dA. Now again we have a 2 outside and a times e to the power a dA. And this is what we get. Now what next? Again the same formula, integration by parts. So let me write over here I is equal to, I'm just going to write the formula. I'm not going to write integral u dv. Just that uv minus integral of v du. And how do we substitute? Now we need to first assume what is u and what is dv. So I'll use u as, see, if I use u as ea, it's not going to complicate it, nor it's going to simplify. But if we take a as dv, it's going to be a squared by 2. So just choose this as a. dv, let's choose it as ea, because this doesn't make a difference. It's the same integral and derivative of exponential to the power variable. It's the same thing. See, v is going to be ea itself. No change here whatsoever. But here, du is equal to dA. It became so easy, isn't it? If you swap these, then it's just going to be more complicated. Now, we will substitute in the formula. U is a, v is e to the power a. Now, what did I forget? I'll first write the 2 because I did forget in the last time. So here, this is what we are solving now. 2. Integral of this is using this formula. A e to the power a minus integral, what is v? E to the power a. Whenever you write this term, you can directly write it after integration. It's the same terms, cv and v. And du is dA. Now let's solve it up. It's going to be e power a, or you can write a e power a is the same thing, minus e power a. That's it. Plus c. Why I'm writing plus c out? You can write 2c, but I've told it's the constant term. You can just add at the end as well. Even if you don't write it at the end, just add a c. And now let's multiply this inside. It's going to be 2. I'll write a first. E to the power a minus e, again 2 e to the power a plus c. And what was a actually assumed to be? A was e to the power square root x minus 2 e to the power square root x plus c. So this is the final answer. It was a very simple problem. So this is it. Now you can write x to the power half as well, but now here we are writing square root x. Okay, I forgot one important thing. When I saw the solution set, I remembered. Look here, this is a. I need to substitute it back. All a's will be in terms of x. It should be all in terms of numbers and x only. Okay, so even this 2a, it should be substituted back as square root x. Now it's done. Or you can write it as x power half. X power half and square root x are same, up to you. That's how we do this. And now we get, I think so this is a little bit more complicated because it is natural logarithm x over here in the middle. Now why? Because ln, whenever you have functions ln, it recurs. When you use the integration by parts, you have to do it not only once. This formula is there, right? U v minus v du. This must be applied once again because another part will be stuck and then again you have to apply this. Now let's solve this up. So what are you going to choose a as? Sine a. So what is inside instead of sine x? It is ln x. So I'll choose a as ln x. Now here, remember, if I start deriving it, it's going to be 1 by x and it's going to be more complicated because I'll have an x term remaining. Now if you're thinking, why don't I do like this? 1 by x dx. Now yes, absolutely, you can do this. This goes to the other side. This is a wrong method because I'll show you why it is wrong. Now look here, integral sine a. Very good. What is dx? It is x times dA. Now this x is there. You can't solve that. That's unaccounted for. You can't solve with two different variables. We can only solve with one variable, right? So therefore, you cannot derive both the sides like that. So that is my intention, to make x alone. Now, how do you remove this natural logarithm? Take e to the power exponential on both the sides. Exponential and ln cancels. It's going to be e ln x. This cancels and x comes down, isn't it? E to the power a is equal to x. Now I'll derive both the sides. When I derive, it's going to be the same thing, dA, that is equal to dx. Now when I substitute it, it's going to be sine a ea dA. Everything is in terms of a. But if you choose otherwise, it'll be x and you cannot proceed further. I'm sure you might be thinking, what exactly should I take it as, u or dv? Which to choose? Here, remember, whenever you have e to the power x and sine x, choose e to the power a as u. I'll tell you why. We will see. You can try it by yourself, but let's see this as well. Now here, what I'm going to do is u is equal to e to the power a. This I'm going to derive du is equal to e to the power a and dA with respect to, implicitly we are deriving. What about v? That is dv is equal to, remaining term is sine a dA. So v is going to be minus cosine a. That's it. Now we have to use this formula. I'm going to write it over here in steps. So let me just change the color here so that you understand whenever we assume it will be over here. So u is e to the power a multiplied with, what is v? It is minus, I'll write minus outside, cosine a minus again cos, okay, this one integral, right? Minus is there in the formula and cosine is also having minus, so I'll just write this as plus now itself. Why? Because it'll be 2 minus and minus, it'll be plus. Minus already in the formula and minus, v is also minus. It becomes plus cosine a. And then what do we have is du, which is equal to e to the power a dA. I hope this substitution is clear. Now, let's substitute again. What are we substituting? let's rearrange, sorry, not substituting it. This entire thing is basically I. Is that okay? Because we are deriving with the I, right? I term. So this was the origin. What is I exactly? I is this term here, what we have. Okay? This is I. Now let me rewrite this a bit more clearly. No, not rewrite more clearly. I'm sorry. I need to see the right part. Integral cosine A e to the power A d. I'm stuck again. It's just like a question. But over here, instead of sine, we have cosine. So I have to do this again over here. Let me show you. Now I have to assume u is equal to e to the power A, du is equal to e to the power A dA. And what about dv? Instead of sine, we have cosine A dA, and then we get v is equal to positive sine A. Now let's substitute over here back. Now let me again change the color. Why? Because now this was the first substitution, and then we got this, and then again this right side was substituted over here. Now initially this was substituted first, second, and now I'm going to write left side is done. EA cosine A is done. Plus again this part will be used the same formula. U is equal to e to the power A. V is sine A minus integral minus sorry, it's plus now, plus sine A. And what is du? E to the power A dA. This was it. Now since it's just minus and plus, I do not need those brackets. It's no multiplication. If there was a term outside, these brackets are very, very important, but I'm not now going to just remove it. Why? Because it's not important. Next, what can you do? If you now if you're gonna go keep on doing this, it's just gonna recur. Next is gonna be again cosine sine. It's just gonna be the same thing. So what are you gonna do is look at the question for a minute. It is the same thing, and that is I, and this side is also I, isn't it? Now what I will do, I'll write this I is equal to minus EA cosine A, this is minus over here, plus EA sine A minus this integral. With this integral, this is just our question I, that is I, we are applying the formula for that. So I'm getting back recurring term as I'll keep on getting that. So I write it as I, that is what we had got. So we will take this to the other side, minus I to the other side will become I plus I is equal to this entire thing again, minus e to the power A cosine A plus e to the power A sine A. That is now this 2i, right? It's I plus I, that is equal to 2i. That is equal to minus EA cosine A. Now, in writing, you need to write in detail, isn't it? You can't just skip. You can write two inverted, like you can do mention like that, but it's better to write in detail. So then I will take this 2 to the other side or divide all the terms by half. So I will be equal to minus half e to the power A cosine A plus half e power A sine A. Now we are almost done. Now we will substitute back. I'll just change the color here. Now, if you're thinking, okay, e to the power A is what exactly we assumed? Ln x. You can do that and then it'll be cancelled. But instead of that, what is e power A? It's x. So here I will be minus half x. What is cosine A is? Cosine of ln x plus half x sine ln x. Don't forget the plus c here. All there'll be plus c. Once you did the integration, right, there'll be plus c. So this is the answer. So it is basically negative half x. Now you can write this minus half outside itself. It's fine. But these terms are very important. This term and this term. So this is how we solve it up. Here we had to do the integration by parts twice, and then we got the answer. So here we can see that is the answer. No, it's continued. Okay, this is the answer. Yes, half. Okay, now what they have done is they have written the negative part right side and sign positive part sign is written first. It's absolutely fine. Let's go further. The next one, it's similar to what we had done just now. You can try solving these problems by yourselves, but I will solve it anyways. You can pause the video now, solve it, and then continue watching to check your answers. Here again, first let us assume a to be 4 plus x squared. Now I'm not going to take ln ln of 4 plus x square. Why? Because here this is a term, natural logarithm is a single term. So I'll just take a as whatever is inside that. Instead of natural logarithm x, we have this term, right? So now here, see, I can see there is x. So in this case, I'm not going to rearrange, right, make it, or take the square root and all. No, if I derive this directly, because this is power 2, I'm going to get x over here. That'll cancel off. See, whenever you have x multiplied to it, strategically leave this right side as it is. Now I'm going to derive both the sides. dA is equal to constant term gone. It'll be 2x times dx. Now we want only dx. Take this to the other side. dA is divided by 2x. This is equal to dx. Now look at this rearrangement. X ln, what is this term? It is a. Dx is dA divided by 2x, and this x and x cancels off. You get to write this half outside. Integral ln a dA. Isn't that very simple now? Do you have any integral formula for ln a? What is integration of 1 by x? It is ln as, but we do not have any formula for this. So we have to do integration by parts. Let me write the formula here again. Integration by parts, I is equal to u dv, that is integration of these two terms, will be equal to u v minus v, this is integral du. So here we need to assume u and we need to assume dv. So I'm just going to write over here u is equal to ln a. Why? Because we know the derivation du will be 1 by x, sorry, 1 by a, not x, because we're writing everything with respect to a dA. This is the derivation. What is remaining over there? There is nothing. That is 1. So dv will be equal to dA, or v is equal to a. That's it. So I'll substitute over here. It'll be half, and the formula integration is gone. Why? Because I'm applying the formula now. What is u? ln a multiplied by v is a, minus integral of v is again a, into du is 1 by a dA. Now this cancels off. What happens? It'll be half a ln a minus, what is integration of 1? It's basically integration dA, or 1 dA. So let me write it again in the next step. Ln a, integration of nothing is, if there is just dx, it's x, isn't it? The same way we have a dA over here, so it'll be minus a. That's the answer. Now we can multiply this half inside. I'm just going to leave it outside. That's fine. This is the correct answer itself. So what was a assumed to be? A is 4 plus x squared. So here it's going to be half outside. It's 4 plus x squared ln, again 4 plus x squared minus 4 plus x squared plus c. Now here there are a few other things. You can even take the a outside and it will be ln minus 1. But see, it's writing exam. This is correct. This is enough. What I'm saying is, instead of this, you can write a and a common out. So it'll be a by 2 into ln a minus 1. And now you can just substitute a over here and over here. Absolutely fine. You can multiply this half. Everything gives you the correct answer itself. Even if you just substitute over here and over here a values, that's also correct. So it's up to you. This I just showed you another way. Now this is what we would generally write. And that's the answer, guys. Let's see how it's written. Okay, over here they have multiplied. No, they have not multiplied. Okay, yeah, half is outside. What happened here is minus and minus. See, they have multiplied this minus sign inside. It's minus 4 and minus x squared. That's the only thing here in the final solution. That's fine. You can stick to what we had written. Now we have e to the power 6x, e to the power 2x. Seems a little bit complicated, right? Now it is. It's not easy. We have to do twice, because over here we can see there's exponential and sine. The integration by parts will be 2 times. But how do we start solving it? Whatever is inside the sign, let's assume it to be a. So a will be equal to e to the power 2x. But now the issue is we have 6x. How will you get a relation for 6x from this? You can. If you cube both the sides, if you make power 3 both the sides, it will become a power 3, and over here, the whole power 3 times 2 will be 6. So it's e to the power 6x. This is how we do it. Now we can derive both the sides, because our main goal is, if you now derive this, this will be there and this can be cancelled off. We can simplify the equation. Now let me show you derivation. It will be 3a dA, 3a squared, sorry. 3 comes down, a power 2, dA is equal to e to the power 6x dx. Now what is dx? Just this moves to the other side. It's basically, okay, that's gone. I've written it down over here. So now let me substitute it back. The given question becomes integral e to the power 6x sine a dx is, here it is 3a square dA by e to the power 6x. Now this cancels off with this, and so it simplifies in order to become 3. I'll write outside 3 is a constant term. A square sine a dA. Okay, now it's a little bit easy. Okay, I thought, okay, it's not sine and e to the power x, so we'll have to do it only once, integration by parts. But then you can see the power is 2, so we have to do it twice no matter what. I'll tell you now. So this is the thing. And now whenever you see such things over here, let's assume over here, and I'll write it down over here. The formula is I is equal to u v minus v. This is integral du. Now I'm going to change the color. Why? Because we are to assume for this. What assumption do we take? What is u? U should be a square itself, and du is equal to 2a dA. What about dv? dv is equal to the remaining thing, that is sine a dA, and we get v is equal to minus cosine. This is minus cosine a. That's it. Now substitute back over here. It is 3 multiplied by, what is u? U is a square multiplied by minus cosine a. Then we have to write minus again. Now minus cosine, right? Integral of minus. So I'm taking this minus outside, it will be plus. Okay, because whatever minus sign, we take it outside the integral anyways, right? So I'll just change the sign now itself. It'll be cosine a. And what is du? Over here it's du, that is 2a. Now I'm just going to write 2 outside over here, outside the integral. 2a dA. So we have a 3 out, then inside again there is a 2 out, 2 over here. So you can do multiplication here and then, keep it, but I'm just going to leave it like this itself. Now what we will do is we will have to solve this part. See, from a squared we got a. Now if we solve it once, then we are just going to get a single term, constant term, and then we can solve it up. So here now, for the second time, that's going to be over here. What do we write? U is equal to a, du is equal to dA. And dv over here becomes cosine a dA, and v is equal to sine a. Now let's substitute. Let's see here. 3 is outside, and there is minus a square cosine a. Then we have plus 2. Now this integral, see, I'm going to use small brackets now. What happens? This integral is solved by u v, that is a sine a, minus integral. What is v again? It's sine a. What is du? Just dA. Now we can easily solve it up. Why? Because now no more branches. See, this one we put it over here, this one over here. Now we will solve it. 3 minus a squared cosine a plus 2. Let me write it outside itself. It will be a sine a minus, what's the integration of sine a? It is minus cosine. So again it will be minus cosine. That's it. But this minus and this one minus out, it will become plus. So I'm writing plus directly. So this is what we get. Now we can just substitute back whatever is a. Just substitute back, it is enough. You can leave it like this. But if you want the actual coefficients, I'll just multiply this 3 inside. So if I multiply this 3 over here, it's going to be minus 3a squared cosine a. So that's the first term. And then what next we have is, here when we multiply it will be 6. So it will be plus 6a sine a plus cosine a. Now you can even multiply the 6 over here and over here. Anyways, we'll just do that. Or we can directly substitute now because this is enough, I guess. It's just going to take more time. That outside brackets are not required anymore. Minus, what is now a squared? See here, you have, that is a, right? What will be a power 2? A power 2 will be e4x. So here, I'm just going to write 3. A power 2 is e to the power 4x. Cosine, what is a? E to the power 2x. 2x. That is the thing. Plus 6. Again, a only, that is e to the power 2x. Sine e to the power 2x. E to the power 2x. Plus cosine e to the power 2x. That's the final answer. Don't forget plus c. Okay, since we solve the integral over here, plus c will be added. I have done the derivation wrong. Look here, guys, I have missed this. But it's fine, only the coefficient is the change. I'll tell you what is the change. Look, what is the derivation? See, a3, I'll write it out over here. We have a3 is equal to e to the power 6x. Derive both the sides. It is 3a squared into dA, that is equal to e to the power 6x. Chain rule, 6x multiplied by 6 dx, isn't it? I just completely forgot that. Then we take it to the other side. It's going to be 3a squared dA divided by e to the power 6x multiplied by 6. So that cancels off and it's 2, 1 by 2. So this is basically a squared dA by 2 e to the power 6x. So here instead of 3 we must have divided by 2. It's half that has been multiplied. So the only change is you're multiplying throughout by half. That's the thing. Nothing else. So everything is correct. Look here, all you need to remember is this will become 1 by 2. Why? Because I forgot about that. I chose the coefficient wrong. This will be 1 by 2. I just edit it over here itself. It's 1 by 2. This is also 1 by 2. Everywhere 1 by 2. So now what we are multiplying is 1 by 2. And here when we multiply 1 by 2 inside, half multiplied by 2 is 1. So I should remove that. It's half. To re-record entire thing, I'm just tired now. That's why I'm just doing this error management, I can say. Half multiplied with 2, it's 1. So that's it. So here, this is the answers, and here we go. So that will be the final answer. It is negative half e to the power 4x cosine e to the power 2x plus e to the power 2x sine e to the power 2x plus cosine e to the power 2x plus c. Let's just double check it. And okay, we are over here. That's the correct answer. Yes, half. Yes, that's it. These two are positive. So only mistake, only error was the coefficient. When I derived, I forgot to do the chain rule. See, it's e to the power 6x multiplied by 6. Don't forget the chain rule. And here you go. This will be the correct answer. Twice we need to do integration by parts. Now then we have another similar, see, we have done similar problem. It's just that we, instead of a square root, we have a cube root. So that's fine. It's same thing. First, let's assume a to be cube root of x. Okay. Then what we do is to remove this cube root, because there is no multiplication by any cube root or anything. So I need to remove this. I need only dx. Let me cube both the sides. It'll be a to the power 3 is equal to x. 3a squared dA is equal to dx. Now let me substitute it over here and get this simplified. It's going to be integral cosine a dx will become 3a squared dA. Now let's rearrange and write this properly. The 3 outside, it will be 3 integral, what's remaining is a squared. I'm going to write first, cosine a dA. I hope this is okay. Now again here you can see it's a square and cosine a, so we will have to do it two times because once we'll dissolve it to power 1 and then second time it will be a constant. Now here let me do this. Here write the formula. It's uv minus integral v du. And what is u? U will be u a square here. So du is equal to 2a dA, and dv is going to be cosine a. See, now don't get confused. It's not du. Du is already found out. We choose dv, not v as well, because the remaining term must have the integration must be done over here. So it'll be v is equal to sine a. That's it. Now I'm going to change the color so that you can differentiate it. Now the next term will be over here. That's 3 multiplied by, now let me just double check the coefficient. Yes, it's only 3. Yeah, this time it's correct because I wrote 3 last time and that was supposed to be half. Now what is u? U is a squared times sine a. That's done. Minus integral. What happens over here? I'll just write the integral a little far away because we will have a coefficient, right? What is v? V is again sine a. What is dA? Du. Sorry, second part is du, right? This is the formula du. What is du? 2a dA. So I'm going to write this 2 outside. And what is remaining? A and dA. So now again I need to use this integration by parts. Now I'm going to use u is equal to a. See, it's reduced now. Du is equal to dA. Now it's a constant. I'm not going to have this recurring a variable. So I'll have a number and I can easily use the rule of integration and solve it up now. Now what is dv? It is sine x. Sine x d. It's not x, sine a dA. And v will become equal to minus cosine a. Now let me substitute back. Let me just change the color here. So when I apply the rule again only for the inner part, that is outside is same, sine a minus 2. Now this part over here becomes a times, see, it's minus because minus cosine, right? I'll write minus a cosine a minus integral, again minus, right? So I'm just going to write this as plus. Okay, I'm just changing the signs here itself because there's minus. I'm making this plus cosine a multiplied with du. What is du? It's just dA. Now this is it. So here, left side, all these terms are fine. It's already simplified. You can't simplify anything further here. Now you can multiply this 2 inside. What I'm going to do is I'm just going to do it now itself. Minus 2 multiplied here will be plus 2a cosine a. And then this minus 2 over here will become minus 2. What is integration of cosine a? Integration is sine a. That's it. Plus c. See, now this 2 minus 2 is multiplied to this term. What is the integration? That is sine a. So that's multiplied to sine a only. And now what I'm going to do is I'm just going to substitute whatever we assume a to be. See, now it's cube root. You can write it as cube root itself. But here there is a square. So let me take that for a minute. It is cube root x, right? So what is this? A is equal to cube root x can be written as 1 by 3. Anything over here root. If it's square root, it's 1 by 2. If it is over here 4, radical 4, then it's 1 by 4. Now let me square this up. If I square this up, what's going to happen? A is equal to x 2 by 3. Okay, that's the power. You can write a as x 1 by 3 or this cube root. Or if you want another way, sorry, this is a square, okay? Or a square can also be written as x square outside is cube root. Anything, you can choose this or this, up to you. This or this. So here 3 is intact over here. You can multiply this 3 inside. See, this I have multiplied because it'll be too many brackets inside, right? But I'm just going to leave the 3 outside. You can multiply n, and then this is going to be 6 and 6. It's up to you. If you want, you can multiply it inside. A square, I'm going to use this form. You can write x square by 3. That is also fine. I'm just going to use radical form itself, x square. So it's sine a is cube root x. That's done. Plus, see, this is not sine cube. It looks like that, right? Okay, so what I'm going to do is I'm not going to write that form because it looks like sine cube root x. That is absolutely wrong. So I'm just going to write 1 by 3. I hope you're understanding, because when I was writing sine cube root x, it looked like as if it's sine cube x. So that is the reason why I'm writing x power 1 by 3, because they are the same thing. 2. Again, x power 1 by 3 cosine x power 1 by 3 minus 2. Minus 2 is fine. Then sine, you can multiply this, remove the brackets, it's fine, it's a single term. X power 1 by 3 plus c. And you don't need this outer bracket. No, you need it. Sorry, why? Because there is 3. Okay. Over here also you can write, I'll write the same form every way. It's going to be x power 2 by 3. Or you can write any of this. So that will be the final answer. We have substituted back what was A. So here we go. Now, how did they get x? So here, yeah, they have written 3. Okay, 1 second. Let me just check this. 3u squared. Yeah, this is sine u minus 6. Yeah, this is what we have got as well. When we integrate, then this became sine. And all of a sudden they have put y to the power 3, which is wrong. This is wrong, I believe. So let's just double check it in the calculator, okay? What I'll do is, I'll check my calculator, because I'm certain my answer must be correct, because I think so this is an error over here. It should not be u to the power 3, it's u to the power 2. They by mistakenly wrote u to the power 3. So no worries. What we'll do is check both of these in the calculator. So here first I'll write this given question. What is it? Cosine. Now it's cube root, shift and this, or you can write this shift and this symbol, and then you can type in the 3 alpha x, close the bracket outside. I'll calculate it at different values. I'll just choose 2 and it should be 0.305. I'll just remember, I'll keep that in my mind. And now I'm going to derive this, shift dy by dx. Now this is 3 multiplied by alpha x to the power 2 divided by 3 multiplied with, okay, not over there, not the power, this one, multiplied with sine, it's sine xc. How you can write sine x to the power is, after writing sine x, just use the power, 1 divided by 3. Now you need to be very careful while closing the brackets. Okay, now it's closed here. Now whatever I open for 3, the first term, it goes until the end, so don't worry, I'll just close it at the end. See here, sorry, the first one is automatically closed. I'm talking about this, the next one, okay? It's closed at the end after all the terms are written. And then we have plus 2, x is over here, alpha x, not shift x, raised to the power 1 divided by 3. And then what do we have is cosine x raised to the power 1 by 3, close the bracket. And then we have minus 2 sine power 1 by 3, sine x, sorry, it should be sine x raised to the power 1 by 3, close the bracket over here. And then I'm going to close the bracket for the 3. And this is 2, it should be 0.3. Let's check. Yes, it's 0.305. If you do this solution, you'll get a wrong answer. Let me just show you over here. If I just change this, only that was the error, to power 1, because x power 1 is x itself. Look, it must be different, and that is wrong. So what we got over here, this is the correct answer. Please make a note of this. And now the 49th one, it's integral 0 to 8. This is definite integrals. Now we have to, rearrange, solve it by the methods which we used. We have to use integration by parts and all. But here the thing is, limits change. Now first, you can't directly, integrate by part. It's a complicated term. So let us assume this. Again, it's a cube root. Just now we did it, right? A is equal to this cube root thing, right? As A. So here A is equal to x power 1 by 3. Let me write that. And let us take the powers, both the sides as 3. So it's going to be a power 3 that is equal to x. Why? Because it will be 3 divided by 3, that's 1. Now let me derive both these sides. It's going to be 3a squared times dA that is equal to dx. Now let me substitute it back over here. This is going to be some limits because the limits are changed. I'll tell you in a minute. But this is e to the power a. What is dx? It's 3a squared dA. That's it. And what next? Next, now you can write the constant term outside 3. And then let me, just rearrange this. E to the power a and a squared dA. Now, how to write these limits? That is very important. Let me show you over here. Initially, the limits were 0 and 8, isn't it? So, what did we assume? We assumed this term, but let's take the simpler one, x, because we know this is with respect to x. X is 0, 8. So, what was x value originally? Assumed as x is equal to a to the power 3. So at x is equal to 0, why I'm taking x is equal to 0? Because this is the lower limit. What happens here? 0 is equal to, let me write this, 0 is equal to a to the power 3, or I'll write a to the power 3 is equal to, sorry, here a power 3 is equal to 0. I'm just writing this as first. What is that a value? A is 0 itself, because take the cube root on both the sides, it'll be a is equal to 0. But now what happens when at a x is equal to 8? Now this is the thing, if you see carefully, it's going to be a power 3 8 here. But luckily it's cube root. Let's take cube root on both the sides. Cube root over here, cube root here. If you put in the calculator, what is cube root of 8? It's 2, isn't it? So the new limits formed are 0 to 2, guys. This is how we get these limits. Now the most important thing is changing the limits. This is a very crucial step. Now this is what we will work with. Sadly here it's a power 2. So what happens? We have to do it twice, just like what we were doing it. Integration by parts twice. I'll write the formula here itself. It is uv minus integral v du. Now then, let me just change the color. So I'll assume for this one, u is equal to e to the, sorry, not e, it is always a to the power 2. So du is equal to 2a dA. dv will be equal to whatever is remaining, that's ea dA. That means v is equal to e to the power a. That's it. Now we will substitute 3 will be left outside. I'm not going to take it inside at all. And now see the limits when we're applying, I'll apply it at the end because we'll try and solve it up. Actually, you can write, I'll show you what way you can write it, the real way. That is, first, let's apply the formula. It's a squared e to the power a. Now you need to write over here limits 0 to 2 because we applied this rule, right? Integration rule. Then we keep on writing. But instead of that, what I'm going to do is I'm just going to write this entirely at the end. Then minus, what is this again? Integral. What is the limit again? It is 0 to 2, the new limits, not the old limits, not the limits of the question. Now, if you write 0 to 8 over here, then the answer will be entirely wrong. And now next what we do is we substitute the formula here. No, not the formula. Yeah, whatever is remaining, sorry. E to the power a into du is 2a dA. Now I'm just going to mark this as 2 and 0. So whatever happens, how much ever you solve, we have to just apply at the end. Or even if you don't write that, it's fine, guys. Okay, it's fine. Just at the end, you need to apply these limits at the end, right? That time if you do it, it's enough. But remember the newly formed limits. Now this is okay, but now again we are stuck with this. So this 2, I will write it outside. It's minus 2. I'll write it out and I'll remove it from here. Okay, I just wrote that 2 outside. And what next? Again, I need to assume over here that is u is equal to a, du is equal to 2a dA. In fact, we did the same type problem, just a while ago. dv will be again e to the power a dA and v is equal to e to the power a. Next, oh now, look at my sloppiness. It's only dA, it's not 2a. It's only dA. Now, this is going to be 3 times a squared e to the power a minus 2. I'll leave it as it is. And what happens? A times e to the power a minus integral e to the power a times dA. And the limits will be there. Now let me write out. You can multiply this 3 inside. This is going to be 6 here. In fact, I'm going to do it because anyway, it'll be too many limits otherwise. So now only I'll do it. 3a squared e to the power a minus 3 times 2 is 6. Because why I'm multiplying over here is because it's definite integral. We have to simplify the end. You can keep it out also, it's fine, but I'm just going to simplify it over here. And here we have 6a e to the power a, that is fine. That is, okay, let me put this bracket because this minus 6 is outside because these two terms are there, right? Let me solve it up. What is e to the power a dA? It's the same thing, e to the power a itself. And then all these terms, guys, will be having the limit 0 to 2. So there's upper limit and lower limit. And what next? I'll write these terms 3a squared e to the power a minus 6a e to the power a, and minus becomes plus 6 e to the power a. Not a, it's e to the power a. And the limits for all this is 0 and 2. Now, how do we apply the limits? When we apply the limits, it's always upper limit minus the lower limit. Now, whenever you have this variable, see, look at this variable a squared. Lower limit is 0. So what happens when the 0 is multiplied with a? It's 0 squared. This term is 0, gone. 0, gone. A is there. But here it's not gone because e to the power 0 is 1, so 6 will remain. So remember, don't just dismiss the below term because it's 0. You need to use upper and lower. So now I'll solve first. First is always the upper limit. Wherever a is there, you should put this 2. So 3 into 2 square e to the power 2 minus 6 into 2 e to the power 2 plus 6 e to the power 2 minus, now what happens here? Entire this thing is minus. The sign actually changes. Some of them don't put this bracket and all. They just write this sign change. Minus the lower limit. This minus will become plus and this minus. Now I'm not going to write everything. Why? Because it's 0. First term is 0. Minus again, second term is 0. But plus, what is this last term? 6 e to the power 0. Now let's simplify. It is 2 squared is 4. 4 times 3 is 12. E to the power squared. Then we have minus 12. Okay, this is going to cancel off. Plus 6 e to the power 2. Now this is cancelled. We have 6 e to the power 2 minus, because this plus and minus is minus, 6 e to the power 1 is 1. So answer, the final answer, I'm just going to write it out over here. 6e squared minus 6. That must be your form. And you can double check this in your calculator. Let's take our calculators. Over here, the given question is shift e to the power, let's take the cube root, shift and the symbol, x, dx is already there. The limits are from 0 to 8. What is the value? You get a numerical value, but that's fine. Whatever the value you get should match here. Now, it's not, you will never get like 6e. You'll get a value and then simplify this. It should match up. It's taking quite some time because the reason is there's a cubic function, the root functions, right? It takes time when there are root functions and stuff. So anyways, let's see. Here we go. It's 38.334. Now, what I'm going to do is just write this a squared minus 6 and it should be the same thing. It's 38.334. So this is how we can check. Yes, this is absolutely correct answer. Okay. So here we go. It is 6 e to the power 2 minus 6. So the 50th problem here now, again, it's the same thing. But looking at this term, I can see there are two terms. I'm not gonna, you can directly use this one, what is that, I is equal to formula. Why? Because I'm not going to simplify it further. It's already simplified. There's nothing you can simplify it with. It's tan inverse x. It's not complicated over here. You can't assume anything, like you can't assume tan inverse x as u. It wouldn't make sense. So all you do is do integration by parts. That's it. And directly you will get the answer. That is uv minus v integral u v du. That's it. So now here, let us assume what is. Now this is very important. Tan inverse must and should be assumed as u here. U has to be tan inverse x, because du is equal to 1 by 1 plus x squared dx. And what about v, dv? That is x. So now this is going to be it'll be little complicated. That's going to be v is equal to x squared by 2. Doesn't matter, we have done the assumptions correctly. Now let's substitute in the formula. What happens when we do it in the formula? I will be equal to u is tan inverse x, v is x squared by 2. That's fine. Minus integral. Again, we have x squared by 2. And what about this part? Next one is multiplied by du. That is 1 by 1 plus x squared dx. Now, this is where it gets tricky. Look, let me write this out. Tan inverse x, x squared by 2 minus, let me take this 1 by 2 outside, half is outside. What is remaining? It's x squared by 1 plus x squared dx. Now this is x squared, and down also we have x squared, but we don't have 1 plus. We can't split the denominator. Over here there is only one term in the numerator. If it was, say for example, 1 plus x squared by x squared, we can split it out. But that is not the case here. What you need to do is, see, I need to get 1 plus x squared. Fine, let's do that. I'll just focus on this term here. See, I have x squared by 1 plus x squared. I have to write 1 plus. That is the extra term. 1 plus. If I do that, how can I balance it? I've added 1, so I should subtract by 1 as well, right? Then it's okay. Basically, it's 1 plus 1 minus 1, 0. So it's x squared by 1 plus x squared itself. So that is what I'm going to do now. I'm just rearranging this as tan inverse x. This left side is the same thing. But here, minus half. What happens here? You do 1 plus x squared plus minus 1 divided by the entire thing, 1 by x squared dx. Now, can I write this as 1 plus x squared by 1 plus x squared minus 1 by 1 plus x squared? Absolutely, because the denominator is split to this and to the right side. It's nothing wrong in this, because this is just going to be 1 minus 1 by x squared, and I'm going to get the same thing. The answer will be the same if I simplify this to the original. But I'm just rearranging this. I'm adding and subtracting. I'm manipulating the given question, the numerator. And now I split it out. This is one single term. Why? Because this cancels out to be 1. And what is this one? It's 1 plus x squared. So that is my intention. So now what I'm going to write is tan inverse x squared by 2 minus half. Here, integration of two terms. Integration of which two terms? That is 1. See, this half is being multiplied here. I need to split it out, right? See, initially this will be like this. Now, I multiply this integration to this minus multiply this integration as well to both of these and dx. Okay, so I'm directly going to write this here. First part, it'll same thing. It'll be 1 integration of 1 dx minus, okay, now this is minus multiplied here. We are multiplying with minus, so first term will be minus, but this already has a minus. Can you see? I'm multiplying minus half, right? The first term will be minus half. The second term already has minus, so it's going to be plus half integral. So it's going to be integral 1 by 1 plus x squared. I hope this pen is not dying on me now. 1 plus x squared, and that is dx. So this is how to get the above transformation. Now we have 1 plus x squared by 1 plus x squared. Here that term becomes 1. Minus 1 by x squared, that remains. But we are multiplying with minus half integral, right? The first term becomes negative minus half integral 1 dx. Second term minus was already there, it became plus this much. Now, can we simplify it? Yes, we can simplify a few of the terms very easily. This is already done, x squared by 2 minus half. What is x? What is integration of 1? It's x minus half x. That's it. What about this term? Half, if you remember, it's tan inverse, right? Derivation of tan inverse is 1 by 1 plus x squared. But now we are integrating it. Integration formula is this inverse integration, right? It will be tan inverse x plus c. So now this is it. This is the final answer. But now what is the most important thing? Now I'm not going to write c because it's definite integral. We know the values of the limits, right? I'm going to apply the limit 0 to 1. I've not written anywhere limits up, but now I'll apply it. So this is tan inverse x, that is 1, tan inverse of 1, multiplied by 1 square is 1 itself, 1 by 2, half, minus, again, half. Why? Because 1 times half is same thing, plus half into tan inverse of 1. And then what we do is subtracted by what? Everywhere tan inverse 0. But now this is going to be 0 itself because I have 0 squared. It will be 0 minus again 0 half multiplied by 0 is 0. Now tan inverse 0 is important. It's plus half tan inverse of 0. I've applied the limit. We'll just put in the calculator now because it's inverse function, right? Now tan inverse 1, it might, because we are using radian, you might get in pi, or you can write in degrees, but it's better to use in pi. So let's use radian mode and solve this. So what I'll do is tan inverse, shift tan inverse of 1. Now it's in radian mode, the answer is pi by 4. Okay, now this is pi by 4. And what about tan inverse 0? Tan inverse 0 is 0, so this term is also 0 itself. Yeah, tan, okay, I didn't know why I did not write 0 directly. Now when I saw the answer, yes, I remember. It's tan inverse 1, that's pi by 4, pi by 4 multiplied by, the denominator is 2, so it'll be pi by 8 here. Minus 1, that's half. Again, plus pi by 4, and it's pi by 8, pi by 8. Why? Because this one over here, right? Plus half into pi by 4. 4 and 2 in the denominator, when you multiply, it'll be pi by 8 minus 0. So now you can just simplify this. This minus half remains. You can use your calculator, but pi by 8 and pi by 8, how do you solve it? Pi by 8 plus pi by 8. There are 2 pi by 8s. 2 pi by 8 will be 1 and 4. So whenever you have the same terms, it'll just be half of that in the denominator. It's pi by 4. So it'll be pi by 4 minus 1 by 2. So that must be the final answer. The answer is pi divided by 4. Pi by 4 minus half. Now this is in radians. So here, otherwise it'll be 45 degrees minus half. That wouldn't make sense. So write it in radians. You can see that will be the answer. Before moving ahead, a quick reminder and a humble request. Please do share my channel and my videos with your friends and to whoever that can benefit from it. And I also kindly ask you if you can hit the subscribe button and like my videos, it would mean a lot. In this question, we will integrate rational functions using the method of partial fractions decomposition. Now, when you look at this, here you can see it's a rational function, numerator and denominator with variables. Now, how can we simplify this? There's no way we can integrate it directly. There's a method that is called partial fractions decomposition. What you try to do is write the numerator as it is. We're not worried about that. The denominator, right? This is the issue. So that is, you can simplify it over here. You can remove the x term outside and it'll be x squared plus 1. So now what you're trying to do is write this as a sum of two fractions. Because this can be split up and written as sum of two fractions. Yes, of course. If you have, say, number 5 by 10, you can write it as sum of two fractions, right? Same way. Now here what I'm trying to do is, I will have this first part in one and one more over here. But I don't know how this will split up. So what I'll do is I'll just take it as a and b x plus c for now. Now, if you're thinking, can I split this further? You can't split this because it'll be an imaginary number. So therefore, we leave it like this. Now, what we can do is, see, we know this can be equal to this. But what is the numerator exactly? We do not know, right? So we are sure that we can split it out into two terms. The denominators are over here. How about we multiply throughout by the common factor? This will multiply it throughout in the sense this first term is multiplied by that. So it basically cancels off. But I'll write it out over here. See, minus 5x plus 2, right? Divided by x into x squared plus 1 multiplied by x into x squared plus 1. That is equal to over here a by x multiplied by x times x squared plus 1 again plus bx, sorry, this is bx plus c, and again multiplied with x and x squared plus 1 divided by this entire thing is x squared plus 1. Now what happens? You can see this x cancels, x squared over here cancels, this entire thing cancels. So I can simplify this further to write 2x squared, it's minus 5x plus 2. That will be equal to a times x squared plus 1 plus bx plus c times x. This entire thing will be multiplied with x. Okay, what happened? Our denominators are dissolved. So we don't have any denominators here. That's why we did it. We strategically multiplied the common factors. Now let's try and simplify this. So here it'll be ax squared plus a. I multiplied a throughout, and over here this will be bx times bax will be bx squared plus c times x cx. That is equal to 2x squared minus 5x plus 2. So we know that this term can be split up into two terms, but we don't know what exactly they are, right? But we know there'll be a plus bx plus c. So now here, what if I group up the x terms together? Say here a x squared plus bx squared, and let me write the next x terms and then the constant terms. So that is equal to 2x squared minus 5x plus 2. So here if I take a and x squared common outside, what is remaining? It's a plus b, and then we have cx plus a. So here we can see it's 2x squared minus 5x plus 2. Now can we relate it? Before x squared, what is the coefficient? That is 2 is equal to a plus b. And what is the next? Minus 5 is equal to c. And lastly, we have 2 is equal to a. So these are the three terms. But now we know a and then we know b. But what about this thing, a plus b? We will do 2 is equal to a is 2 plus b. That means take this 2 to the other side. B will be equal to 0. So we got all the three terms. Now we'll substitute back over here. So this is, it is a is 2 divided by x plus we have b, that is 0. So I'm not going to write that, only c value I'll write minus 5 divided by x squared plus 1. And this is same as the above term. So now you can split this out into like this. Now if you simplify it, you're going to get this answer itself. Here if you multiply the common factors and everything, you're ultimately getting the question. But we dissolved it, we wrote it in a different way. Now this is easier to be integrated because this over here integration is very difficult, but I can integrate this easily. Why? Because it's natural logarithm. So I'm going to integrate it over here. See this 2 divided by x, right? That is 2 ln modulus x, and it's minus 5. Now what is, if I remove the minus 5 out, what is it? 1 by x squared plus 1. That is tan inverse. Tan inverse x plus c. So that is the integration. Now if you know the rules of integration, it's simple, and we have done many integration problems, right? So here integration is not the issue. Getting this form is the main issue. So once you get in this form, you can easily get the answer. So it should be, this is the correct answer. Let's just look into the solutions. Here we go. You can just memorize this whenever you can't split into three terms where you have imagined numbers or anything. When x squared remains, you have to use this form here. You can memorize the above. And then we got these answers. And yeah, there we go. The answer is 2 natural logarithm x minus 5. Yes, that's correct. Similarly, you can try this one out. It's the same thing, but only the question is differing. So what we'll do is, now it's okay, literally almost the same. I'll do it again, but I'll do a few, a little bit fewer steps than what we had done a while ago because I did a lot of steps. Now here, I'll directly write this x squared minus 3x plus 4 divided by over here we have x into x squared plus 1. That will be equal to a by x plus bx plus c divided by the second term, that is x squared plus 1. So now, if you multiply throughout by the denominator, you're going to get 2x squared minus 3x plus 4. That is equal to, it's just this term over here, a squared plus 1 plus bx plus c multiplied by x. Now then, this multiply a inside will be ax squared and plus a plus bx squared plus cx. And here it's the same thing, so I'm not going to write it. Over here we can write it as a plus b as x squared plus cx plus a. Now we can relate this over here, minus 3x plus 4. So what is a plus b? A plus b will be equal to 2. Now c is equal to minus 3 and a is equal to 4. Right? Yeah. So now then we can simplify it. Let's put over here a is 4 plus b is equal to 2. So now what we'll do is we'll take this to the other side. 4 to the other side, b is equal to minus 2, sorry, not 3. That's the values. So now we can substitute everything back over here. How we do is, so a, what is a value? Okay, 4. 4 by x plus b value is minus 2x plus, it's minus 3, sorry, it's minus 3. That is divided by x squared plus 1. Now, how can we split it out? See, over here there are two terms. We can split this denominator easily, right? Now, it's not very complicated or anything. There are no two terms. It's just, if I have 1, minus 1, minus 5 divided by 3, I can write this as minus 1 by 3 minus 1 by 5, 1 by 3, 5 by 3, sorry. Same thing. I'm just splitting the denominator into both the above terms. So let me just show you over here. So here the 4 by x, it's sorted out. We know it's natural logarithm x. But here it's minus, so I'm going to write minus 2 by x squared plus 1. Then again minus 3 by x squared plus 1. Okay. So here then we can see, we will integrate it directly. This will be natural logarithm x, but don't forget the constant 4 minus. Now here you can see this is x squared and this is 2x. So this is logarithm. Look, the denominator, right? X squared plus 1. When you derive it, what is going to happen? D by dx. That's going to be 2x. And you can see the above term is 2x itself. So this is in relation. So when you derive the denominator, you get the numerator. Then you can write natural logarithm x squared plus 1 directly. You don't need to do any substitution or anything because it's exactly the derivative of the denominator. So it's natural logarithm. And then over here, it's 1 by, okay, now there is no x term. Now don't think over here it was tan, but over here it's not tan inverse because you have x in the numerator. But here there is no x, it's just a constant. So what can you do? 1 by x squared plus 1 can be written as tan inverse x. Then plus c. So that must be the final answer. You can see it's 4 natural logarithm x minus ln x squared plus 1 and minus 3 tan inverse. Yes, that's the correct answer. Now here you can write modulus or you don't write modulus, it's fine. As long as you've written the terms properly, that's more than enough.
That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next question. In this question, we'll find the general solutions of separable differential equations. Here they have asked us to solve the IVP, initial value point, explicitly if possible. So this is a differential equation. You can see y prime and the equation y given. Let me write it out over here. Y prime is equal to 3 times x plus 1 the whole square and y. You can see the function and its derivative exists in the same equation. So it's differential equation. And I've clearly mentioned these are all separable. That means you can group all the y's and x terms separately.
So let me move this y to the other side. Divide both the sides by y. It'll be 1 by y prime equals 3 times x plus 1 the whole square. Now for the first problem, I'll do everything in detail, but the next problems we'll do a little lesser steps. But if you understand the concept, that's more than enough. Then you can, skip few steps. Here, what is this y prime? Y prime means we are deriving. Now this is dy by dx because it's derivation of y with respect to x. So here I write 1 by y dy by dx. So that means this is equal to 3x plus 1 the whole square. See, all the y's are grouped and x's are grouped separately. Now what about this dx? Take it to the other side. It will be 1 by y dy. That is equal to 3 times x plus 1 the whole square dx. Now we have dy dx both the sides. We can integrate this easily. So when we integrate the left side, what happens is it will become ln y, that is equal to, here, look at this. We can do u substitution because it's more than one term. But if you do u substitution, you're going to get the answer, that is 3 into x plus 1 the whole square. Because this is a constant, I can directly write that. This power increases by 1. That's plus 1 and divide by 1. And then what happens is, this is it, plus c. Don't forget the plus c. Here now 3 and 3 cancels. That's good. But what we exactly want, we don't want ln y. We need y only. So as long as y exists anywhere, that's fine. We don't need to write y is equal to entirely the thing. We have to just get y explicitly, right? Just to get y with the initial condition. So now I'll take exponent on both these sides. That is e to the power ln y. That will be equal to e to the power. This is gone. It's just x. See, this is a single term. I have to take exponent for entire thing, It'll be x plus 1 the whole power 3 plus c. Now, what happens? This cancels off and y comes down. It'll be y. Because over here, y has to be positive. That's why we write this modulus symbol. Because y cannot be negative inside this, Then the ln function would be undefined. That's the reason we put these two lines. Now here what happens? We will split this out. We know the rule. If we have EA plus B, the power, we can write this as EA multiplied by EB. Or if these two are given, say the bases are same and the exponents are there, you add them up. Now I'm going to split them up. It'll be E x plus 1 the whole power 3 multiplied by e to the power c. See, they have given us an initial value. Why they give? Now you can remove this modulus because we have exponents on both the sides. That means the answer will be positive itself. Now, because anything raised to the power, even if you take a negative number or a positive number or 0, it'll be positive answer itself. So you can ignore this modulus now. Or you can write it up to you. Now y of 0 is there. That means if y of x this is basically y of x value is 0. If you put this x 0, what is this here? It'll be 1. So I'll write it out over here. Y of 0 is equal to, here it is, e to the power, this x is 0 plus 1 the whole power 3 multiplied by, now this is multiplied by EC. Now this is just a constant. Now I won't write it as C, but I'll write it as A. It's absolutely fine because whenever you've taken the constant of integration to the power, you just write it as A. Even you can write it as C, it's fine. That is the constant we are looking for. Now substitute. We have substituted. Now substitute this value. Here we have e to the power 0 plus 1 is 1. 1 raised to power 3 is 1 raised to power 3 will be 1 itself. So it is 1 here, okay? And then, or you can just do it, e raised to power 1 to the power 3, that will be 1 raised to power 3, that is 1 itself. And then we have a. So just take a to the other side. Now when you take a to the other side, it will be 1 divided by e, that is equal to a. So what we did over here is to find the value of this e to the power c or a, because here, let's just write e to the power c, we have taken it as a, or you can write it as e to the power c, it's up to you. So the final answer would be y equals e to the power x plus 1 the whole cube multiplied by 1 by e. So that will be the final answer. So that is also included. So this entire thing, this power, is the final solution. So we have to solve it, group it out, y's together, x's separately on the other side, and then we integrate it and try to find y, and then use the initial condition and find the constant value. Here we can see the answer is, now they have written 1 by e first and then e to the power. It's absolutely fine. So that's it. And they have taken this as k. Now I have written it as a, right? Or c e to the power c. That they have taken it as k. It's absolutely fine. Anything is correct. As long as you know what that means, that's okay. And what about this one? Now I'm going to do a bit fewer steps. See, I'm going to take this to the other side directly. It'll be y power 2. But I know y prime will be dy here and dx to the other side. So here I've just skipped the first two steps. Directly take it to the other side, write dy, and here x minus 1 dx. Or you can write y prime and directly integrate both the sides. That is also fine, because you can write the formula of y prime as integration of these two. It's okay. Now when we integrate it, what happens? It'll be y power 3 by 3, that is equal to, here now it's x minus 1. So here, don't think, okay, this is power 1 and it'll be power 2. That'll be wrong. Why? Because these are two terms. You have to integrate them separately. Integration of x minus integration of 1 dx. That's how we do it. Now, if you're doing this power 2, then it's wrong. Okay, that's not the true way. You need to first do it. Only when there is power, then you do u substitution. Now, we're not going to do u substitution here. We are going to integrate x. That will be x power 2 by 2 minus x, because integration of 1 will be x, plus c. Okay. Now I have got y, so I don't need to bother to take everything to the other side. Why? Because I can do it. You will get a different c value then, but it's just way too complicated. Why? Because you're taking to the other side 3. Then you're taking cube root. Rather, I'll just leave it like this, because they have told explicitly. I've just done it. Explicit differentiation is done. Now what I'm going to do is put in the initial value. I know y value will be 2 when x is 0. So I'm just going to substitute 2 here. Wait a minute. Let me just change the color here to understand. This is what I'm using now. 2 to the power 3 by 3 equals 0 power 2 by 2 minus 0 plus c. So that is what I did, the substitution. Now what is the value of c? The value will be 2 power 3, that is 8 by 3, that is equal to 0 minus 0. I'm just not going to write that. 0 and 0 is equal to c. So c is 8 thirds, 8 by 3. And what we do is we substitute back in the original function. See, this was the original value, right? So we write it over here. Y cubed by 3 equals x squared by 2 minus x plus 8 by 3. That is it. That is the answer. Now you can write the extra steps if you want, because there are only 4 steps, but this is it. These are the main important steps. You can, if you have understood this, you can directly write this and you should get the full marks over here as well. That is it. And what about this one? Again, it's similar. We take y to the other side. It's going to be y into dy. That will be equal to 4x squared into dx. Now what we do is we take the integration on both the sides here. It'll be y squared by 2. That is equal to 4 remains. It'll be x power 3 by 3 plus c. Now I'm going to substitute this here. It'll be 2 squared by 2. That is equal to 4 times 0 by 3 plus c. So what happens? 2 squared is 4. 4 by 2 is again 2 is equal to c. Now this is it. We substitute back over here. You need to write it in order. So y squared by 2 is equal to 4 times x. Sorry, it is no need of the bracket. You can just write 4x cubed by 3 plus 2. This is the final answer. Here we go. That's it. Now again, another simple one. So we'll take y to the other side. It's going to be y into dy. That will be equal to x minus 1 into dx. Integrate on both the sides. Remember here, when you integrate it separately, you need to do it. It's not x minus 1 as a whole term. It's integration of x minus integration of 1. So here you get y power 2 by 2. That is equal to x. We have done a similar one. Only the thing was, it was x power 3 here. X power 2, and then it became y power, it was y power 2 It became y power 3 by 3. And this is x power 2 by 2 minus x plus c. Now I'll just substitute what is the initial condition. It's minus 2 the whole square divided by 2, that is equal to 0 squared by 2 minus 0 plus c. So the c value will be equal to, what is minus 2 squared? It's 4. 4 by 2 is 2. Answer is 2c itself. So therefore y squared by 2 is equal to x squared by 2 minus x plus 2. It's plus 2, it's not minus 2. See here, minus 2 the whole square will be positive 4 and divided by 2 is positive 2. So therefore it is 2. And here we go. What did they do over here? No, this is wrong. They have written the answer of the previous one. See here, you put minus 2 the whole square. What we have done, what is the answer? You can use your calculator. It is not 8 by 3, it is 2. You put it in the calculator, you will get 2. This is absolutely wrong. Here it should have been 2. Everything else is correct. Please note here, the solution set answer is wrong. It should be plus 2. That's how we solve it. Okay, here now we can see it's not initial values like before. See here it was y of 0. We have got y of minus 2. But that doesn't make any difference. Only the x value will be minus 2 and whatever is the y value will be 1. That's simple. You'll solve it up. Y to one side. Look here, don't take the x to the other side. It's y towards the other side. It'll be y 1 by y. Y prime is equal to 4 divided by x plus 3. This is basically dy by dx. Let me write that. Here it is dy and over here we have dx. We need to integrate it on both the sides. Now what happens? What is the integration over here? See here, when you're integrating this, you can do u substitution, but when there's a relationship, look at the denominator. It's x plus 3, right? I'm going to use this property because it's very handy to integrate. Now, imagine it's 1 because you can take 4 outside. X plus 3. I'll write this out. 4 will be over here. Now, only I'm focusing on 1 by x plus 3. Let me write it over here. X plus 3 dx. Now, this side, it's very simple. Ln y. That's it. Now, here I'm integrating this. If the denominator, I derive this denominator. What is the derivation of the denominator? It is x plus 3 derivation, that is d by dx. That will give me 1. Why? Because derivation of x is 1 and constant is 0. Now, if the derivative is up over here in the numerator, then the rule is they are in relation. What relation they are? This function, if this is u and the below one is u prime. See here, if you have u, then u dash derivative, right? No, I've written it wrongly. U and u derivative dx, the integration for that will be ln magnitude u. So I can just write ln magnitude x plus 3 for this directly. So I'm going to write that over here, ln y, that is equal to 4 outside, and then we have ln x plus 3 plus c. This is what happens. Now I can take this 4 to the other side because the property of natural logarithm, before I remove this ln, the property says if you have a coefficient of ln, then you can take it as power. So what I will do over here is ln x plus 3 to the power 4. It will be over here to the power 4 to this x plus 3, not over here, plus c is equal to ln y. Now I'll take exponential on both the sides. What will happen if I take exponential? The ln goes, so I'll write e. Sorry, I'm not going to write e because that's just going to remove it off, right? So here it'll be y. And here what happens is you will have this c, right? So here e raised to the entire thing. Please remember when we raise it up, this is a single term. Yes, ln x plus 3 the whole power 4, right? Then we have plus c. So now this will be split up. How do we split it up? If you have e to the power a, e to the power b, this will be ea plus b. So now we have ea plus b, so we split it out into e ln x plus 3 the whole power 4 multiplied with e power c, and that is y. I'm not going to write because it's exponential. The modulus is not required anymore. But see, many of these steps can be skipped. From here, you can directly jump to this step. Why? Because when I look at it, I know the denominator, the integral is ln x plus 3. That's natural logarithm. And then from here, I can directly write this. Why? Because over here, when I take exponential on both the sides, now this needs to be remembered. You have to take it to the power 4. Then write y directly. And over here, I'll remove this and write, see here, I'm going to write this x plus 3 the whole power 4. Directly from here you can, because ln goes off. But here it's plus c, so therefore it will become multiplication of e power c. If it was minus, then you should write division. But here it's always plus c, right? That's why we write that. This is it. Now it's not over. We need to put up the initial values. What is the initial value we have considered? So for y of minus 2, that will be equal to it's y of minus 2. The value of x will be minus 2 plus 1 the whole power 4 into, you can take e to the power c as a. I was doing that before, right? Because like instead of e to the power c, just take it as a, it's easier. Now what is this minus 2? It's 1 equals minus 1 to the power 4 is 1 itself times a. So what is a value? A is 1. So what happens here exactly? Here, y is equal to x plus 3 raised to the power 4 times 1. But that is it. This is the answer. That is the final answer. Now you can write modulus. Okay, they have written the modulus. You can write, because the reason for that is there is still a variable x. X can be anything, right? So please have a mod. But no, you don't need to, because this is raised to the power 4. So it doesn't matter what, it'll be a positive number. So here the domain is satisfied. No need to write that. Or if you write it, it's up to you. So here we go. That is the answer. What about this one? This is simpler. Why? Because we take it to the other side. It'll be 4y plus 1 times dy. That will be equal to 3x dx. Now here we have 4y squared by 2 plus y, that is equal to 3x squared by 2. And next what we do is basically here simplify. Y squared plus, it's 2y squared plus y is equal to 1.5 or 3 by 2 x squared. Now I'll put in the initial value. Y value will be 4. It's 2 times 4 squared plus 4 is equal to 3 by 2. I forgot to write plus c. Apologies for that. And then here x value is how much? 1. It is 1 squared plus c. So here 4 squared is 16. 16 times 2 is 32. 32 plus 4 is 36 is equal to, here what is this? It's just 1.5 plus c. So I'll take this to the other side. It's going to be 34.5 is equal to c. So that is the c value. So what you can do is you can just write it out over here in this equation. See this one, the simplified one. 2y squared plus y. See, we have all in terms of y. We have done explicit difference. Explicitly we have solved it. So that's fine. 3 by 2 x squared plus 34.5. That must be the final answer. Here we go. Now they have written 69. Let's just do this. It should be 34.5 times 2 by 2. So it'll be 35 times 2 is 70. Yeah, 69 by 2. Yes, that's correct. It's the same thing. You can just use the calculator here. If you put 34.5 directly, you'll get 69 by 2. Or if you press SD after putting this, you should get 34.5. It's the same thing. And yes, the values are correct. In this problem, we have trigonometric function. So what we do is basically same thing, integration. It's pretty simple. Let's take this to the other side. It's cosine. Okay, now don't think this is prime here. This is comma for this term. Okay, this is it. It's cosine y. So cosine y into dy is equal to 4x into dx. What is the difference here? Integration on both the sides. Integration of cosine y. It is sine y is equal to 4x squared by 2 plus c. Now here sine y, let be. You can take sine to the other side. The reason I'm saying is, sine, if you have y power 2, y power 3, it's fine. But this is inside a function. So what we'll do is we'll take it to the other side. But before that, first let's find the constant of integration and then we'll do that. Okay. So here sine y is equal to 2x squared plus c. Let's find the c value. We'll substitute over here 0 and 0. So sine 0 will be equal to 2 times 0 plus c. Sine 0 is equal to c because this is also 0. So therefore we have sine y is equal to 2x squared, right? But what you can do is y will be equal to sine inverse of 2x squared. So that can be the final answer, or even this is absolutely fine. So let's look into the answer. They have written, yeah, sine inverse. Okay, now I'll tell you what is this. This is very important. What is the domain of sine inverse function? Sine inverse x is -1 to 1 because you won't have any values other than that. That's the range of this. Range of sine is the domain of sine inverse, right? So these are the values. Now here, instead of x, what do you have? You have 2x squared. So it is not x should be plus or minus 1. Now I'm just going to use equal to because I'm solving it up. It should be within that range. Now I have here 2x squared is equal to plus or minus 1. So let me take 2 to the other side. It will be x squared is equal to plus or minus 1 by 2. Let me take square root on both the sides. X is equal to, it'll be square root of 1 by 2, or it'll be plus or minus 1 divided by root 2 because square root of 1 is 1. So x has to be, see, minus 1 by root 2 will be less, x must be greater than that and less than positive 1 by square root 2. That's how we get the domain. See, this is the domain of the x function, sine inverse for 2x squared. Now another one, it's tan over here and it goes to the other side, so it'll be 1 by tan. So 1 by tan y will be dy will be equal to 1 by x dx, and we have pi by 2. It is similar to what we did just now, but how would you solve this up? Here this is cotan, right? Cotangent y dy is equal to 1 by x dx. But do you have any formula for cotangent y directly? Now if you have remembered ln sine modulus of sine x, that's integration of cotangent is ln modulus of sine x. If it's y plus c. If you remember this, well and good. But otherwise, I'll tell you how exactly you'll get it. Cotangent is what exactly? It is cosine by sine. So cosine y by sine y. This is what I'll have to derive, isn't it? It's 1 by x dx. So what happens in the denominator? Denominator, it is sine y. Now, what is the differentiation of sine y? It is d by dx of the denominator sine y is equal to cosine y. So here when I derive this denominator, I'm getting the numerator. So the answer will be ln the modulus of whatever is in the denominator, and that is it. This will become the answer here, and this is ln x plus c. So this is how we get it. Now we have ln and ln. I'll just take exponential on both the sides. It's going to be here sine y, that is equal to x, but don't forget it will be multiplied by e to the power c. We have done this before. It will become e to the power ln x plus c, and then we can split this out, ln x multiplied by e to the power c, and this will become x modulus x. So this is how we get it. Now, since it was exponential, we'll just ignore the modulus. That's fine. And now what is it? We have the initial value conditions, right? So when y is 1, so sorry, when x is 1, y is pi by 2. So sine pi by 2 will be equal to 1 times e to the power c. So what is exactly sine pi by 2? Sine pi by 2 is 1. You can check it out in the calculator. You should put in radian mode and sine pi by 2. Or if you know sine pi by 2 means 90 degree, I'm just going to write sine 90 degree. Okay, because pi by 2, pi is 180 divided by 2 is 90. It's 1. So here will be 1 equals 1 e power c. So basically it is e power c is equal to 1. Or you can write it as k or a, anything is fine. So now then we'll just substitute back in this equation. See, the sine y is equal to x into 1 is x itself, or y is equal to sine inverse of x. This is the answer. And the domain will be less than 1 and greater than -1. So that must be the answer. So here we go. That is at sine. Okay, they have just written sine is equal to x. That's absolutely fine. Sine y is equal to x is okay. Or you can take sine inverse on both the sides and it'll be y is equal to sine inverse x. So this is how we solve it. There are various different methods or different alterations over here, rather than these steps. You can even skip some steps. See, from here, you can directly write this and jump here as well. It's up to you. How confident you are, you can follow those steps. And that is the end of all the writing part questions. I hope you have found these videos helpful and beneficial. I wish you all the best for your exams. Please do prepare well in advance for your exams. Don't leave it at the last minute. And if you have any doubts, please try rewatching the video or ask your questions in the comments, and I'll try to get back to you very soon. And thank you very much for your support for my channel. I'm really humbled by all the appreciation and thanks I receive on the channel. Thank you so much. I really, really appreciate it. If you could do me a huge favor, then please do share this channel with anyone who do not know about this and who could benefit from it. And if you can, please do hit the subscribe button and like my videos. It would mean a lot. Thank you very much, and bye bye for now.